and organizing FDP on product design and prototype development. It's a good sign that we want faculty members and research scholars from varied backgrounds. We want them to learn with us and to contribute something somewhere with interdisciplinary research in the growth of nation and the growth of state. And let me tell you about the Engineering College Bikaner. It was established in 1999. It's a young budding engineering college of 21 years of age, and it was opened in autonomous mode by the government of Rajasthan. This is the largest, or say as infrastructure and faculty-wise, the biggest engineering college in the Rajasthan, who has achieved many milestones within the 21 years of its inception. I think Raudar sir and was taking efforts for the innovation, product designing, and prototype development. He has also developed some prototypes along with his colleagues in the department of EIC. So many initiatives have been taken in Engineering College Bikaner regarding startups, incubation centers, product designing, and we are having many BTech courses and recently opened BTech courses in automation and robotics. Last year we have opened BTech courses in artificial intelligence and data science. So we are also running with the future needs. We also want to provide the technical knowledge to the budding engineers in the field of emerging areas, which has been provided by the AICT. And with these words, I would like to welcome all the participants who has come from all over the India to make this happen. Without participation, any program cannot be fulfilled successfully. So once again, thanks to the AICT Atal Academy and organizer Raudar sir and Harjit ji for getting this kind of sanction from AICT. Thank you very much.
These details were informative. Thank you, Manoj Puri sir. The motivating academic and research environment is assured by our head of the institution, Dr. J.P. Vamu sir. His active administration has brought our institution as one of the best technical institutions of Rajasthan government. I request Principal Dr. J.P. Vamu sir for few words to inspire organizers as well as participants. Please, sir.
Thank you, Vinod. First of all, cheers first to my Guru, Rajendra Karwa sir, who was guided us in a better way. That's why today we are at this particular platform. So my cheers first to you, sir. And without Guru, we cannot success in our life. So this is the foremost thing. Now the second the person who is basically leading our Bikaner Technical University. When I spoke on day one to our Honorable Vice Chancellor Vidyarthi ji, he spoke about the innovation. He spoke about the the center of excellence. So sir, I welcome you and I regard your thought, your vision, and definitely under your leadership, this particular institute will grow in a better way, not only in Rajasthan but in India in times to come. My special thanks to Rahul Raji, who is always a passionate person to innovate something. Innovate in terms of the product, innovate in terms of the services. So Rahul Raji, you are great, and your team also very great, because I am seeing from last couple of years that continuously when EIC department, in enrollment in the EIC department is going in downward, you and your team has taken the lead, and definitely from last year when I saw almost all the seats filled, this shows the commitment. This shows the commitment for the institute. So I respect your commitment and hope that this journey of commitment will continue in times to come. The persons behind this FDP, the head of the department of EIC, Harjit ji, Raudar ji, Vinod ji, because all we are here, the eminent speaker, the eminent party, the personalities, the chief guest and the guest of honor, they all are here because of you. So I respect this particular thing that you have taken the initiatives to organize such type of event. Sir, with due respect, I want to tell, then we have to think in a out of the box, because sometimes we are comparing ourselves with the China. The China is basically exporting. The China has 12% of export in all our world. and we have only 1.2% in that particular, the business. So if we want to increase the business, we have to go for the innovations. And what type of innovation? We have to see that particular product development. The manufacturing sector has to be improved. So this can be achieved only by seeing that in what way we can develop some product which can help to the environment, which can help to the society, which can help in overall growth of the business. So for all the things from the consumer point of view, from customer point of view, we have to think that in what way the cost can be reduced, the delivery can be the faster delivery can be ensured, and of course the quality of the product. So all these three parameters, quality, cost, and the delivery, we have to think, we have to produce that particular the supply chain system. We have to innovate that particular supply system that will enhance the overall business of the country. You see, there is a 60% contribution from the MSMEs, and they are lacking the product design and in the field of the product design and development field. So ours is the responsibility. We are the technocrats. We have to think that in what way we can strengthen those MSMEs in a better way. How we can provide the the consultancy in terms of the product, in terms of the services, so that their businesses can be enhanced and their overall the improvement can be ensured. So of course, it is a big challenge in front of us that in what way we can provide our services, our expertise, being an academician, being a researcher to the society, to the industries. It's a daunting task, but of course we have to see and in what way we can enhance these activities. Because in by 2027 we require 10 crore jobs. 10 crore young people will enter into the market. How we can fulfill expectation from those young minds? That is a daunting task. So somewhere we have to keep the balance. Somewhere we have to increase the manufacturing sector, because most of the the labor that is presently also they have in the involvement in the agriculture sector. So somewhere we have to shift that particular focus from agriculture to manufacturing sector. So definitely the deliberation from this faculty development program will enhance something from industry point of view, from business point of view, from overall the growth of the country. So definitely I expect lot of deliberations from this FDP, and sure at the particular platform after 5 days we will be in a position to have something in our hand that can be achievable. So again I welcome the guest, and I place on record thanks to the organizers and especially the participants that they shown the interest in this particular thing. Thank you, Jai Hind, Jai Bharat.
Thank you, Principal Sir, for your valuable words. We have Professor R.K. Karwa with us. He is an eminent professor specialized in machine design and thermal engineering. Professor Rajendra Karwa received his Bachelor of Engineering degree in Mechanical Engineering from University of Jodhpur in 1973 and Masters of Engineering in Mechanical Engineering specialized in thermal engineering with honors from the same university. He obtained his PhD in 1998 from IIT Roorkee. He retired from MBM Engineering College, Faculty of Engineering and Architecture, Janna and Vyas University, Jodhpur in 2012 as Professor and Head, Department of Mechanical Engineering after service of more than 30 years. He worked as visiting faculty in Addis Ababa University, Addis in Ethiopia from 2003 to 2005. He served as Director Academics at Jodhpur Institute of Engineering and Technology from 2012 to 2020. He has published about 70 research papers, 22 of them are published in journals. The Google Scholar citations of his publications are more than 1,380. He has authored 4 books and edited 1 conference proceedings. He has 37 years of teaching experience and has supervised 15 research scholars. He has also successfully executed a large number of industrial projects. His area of interest are machine design, heat transfer, solar thermal applications, and energy analysis. Having his detailed introduction ceremony. However, I urge him for giving few motivational words for this FDP. Please, sir.
Dr. Rahul, should I start now? Sir, presentation will start after this inauguration. This is we want to have some few words, blessing words of
Okay.
motivation.
Respected Honorable Vice Chancellor, Professor Vidyarthi, Professor Damu, Professor Rahul Chaudhary, Vinod Yadav, and other dignitaries and participants, teachers and students. It is always my great pleasure to interact with the engineers, especially the faculty of engineering, because ultimately the driving force for economics is the engineering. You cannot think of development, job creation without engineering applications. And the need of the hour is not only to save the environment, but to provide cheaper products to majority of our population. Probably as on today also, almost 70% of the people, especially in India, are deprived of some basic facilities. So we have to develop the products which are within the reach of the poorest of the poor, and this is how we can uplift their life. But to make them able to purchase the products, we have to provide the employment. And in agriculture, already 50 or 55% people are against, but they are also facing great hardship due to some wrong policies of our successive government, I would say. But anyhow, for remaining, you know that a large number of youth are migrating from the villages to the cities in search of the jobs. And maximum jobs are being provided by the engineers. Industrial development, medium scale industries, cottage industries, you have to develop the products which are cost optimized, which give a very reliable performance. I do not agree with this today's philosophy that use and throw the product. There was a time, I am talking about my childhood, we used to say that Dada Kharide Pota Bhate means a product which has been purchased must serve at least for 30 to 50 years. And today's technology is that purchase a car, after 3 years, change the car. And so you are creating a large number of a very huge volume of wastage and the control of the wastage. And more products, luxury products you are producing, more pollution, more you are adding to the pollution. And one scientist said, he rightly said that this living world on the earth is going to end not due to any pandemic, not due to any strike from outer space, but due to your luxuries only. You will destroy the environment and that will kill you. And this human race will be this earth because of your luxury only. So we should, engineers, we should think. Of course, we cannot stop it because it creates probably a very revolutionary economic change is required. But that is a different point. That is not point here. But as engineers, what we can do is we can provide cheaper products, reliable products, products which serve for a long time. You don't think of the rich or the upper middle class, which is having a different psychology. You think of just the 60% poor people who, when they purchase any good, any product, they want that this should serve them at least for 2 generations. So you have to think about good products, but cheap products. I used to give one example in a class that what is engineering, you just understand. Suppose you make a slight improvement in the design and that saves 100 rupees per motorcycle. Only 100 rupees, a slight modification. You have 10 days effort and you are making a slight modification and that saves only 100 rupees on one motorcycle. India is producing 1 crore motorcycles per year. So you are saving 100 crore rupees of our country. Now you just think the people who are just struggling for bread, what these 100 crore rupees can do for these people. And this is the power of engineering. So you as engineers should always think that how I can make a product more reliable, more cost effective, less polluting, and that is real engineering. Your research efforts should be always directed towards this action. Don't think of developing a cheaper process which can produce wallpaper, which can produce very costly cars costing 2 crore rupees. I just always get annoyed when I read the news that some people are purchasing car for 2 crore rupees or 50 lakhs rupees or 1 crore rupees. In what direction you are thinking? Just people have to, you have seen during the pandemic that lakhs of laborers from Rajasthan and Delhi were moving on foot to reach UP or Bihar. At one side, we have such people, and on the other side, we are thinking of purchasing a car of 1 crore rupees. Why we should have 7-star hotels or 5-star hotels? जितनी धर्मशालाएं बनी है वो सारी डंप हो गई. Time in my life I have seen, I have stayed in Dharamshala. There was no problem. Why we should have very good hotels when people are not getting even the hut to live? People are sleeping on the footpath. So what, as engineers, we can revolutionize, we can completely change this world if we can develop cheaper products. And how the cheaper products can be developed, it is all engineers' design decisions. If you are in-depth fundamental knowledge, then you can always think what are the parameters which control the design, performance, as well as its cost. Most important part, whenever I have taught, I told you that think of the alternatives, think of the parameters which control the cost and performance of the design, and then try to optimize that. Engineering is optimization, not making a product only. प्रोडक्ट तो जुगाड़ भी बनता है. द बुलेट कार्ट एंड द ऊंट काटा आपने देखा है, सैकड़ों सालों तक, हजारों सालों तक दुनिया को सर्व किया है. There was a time in 1975, I still remember the news in Times of India that more goods are transported at that time, 1975, I was typing of 1975, more goods are transported by bullock carts than the trucks. So they have served for thousands of years. But now what has happened? But now we are thinking of very heavy pollution inside the city. Why we should have loading taxis? Why not bullock carts? I was traveling in a train. I used to do such type of thing that I deliberately took a passenger train from Jaipur to Jodhpur just to see how the people, very poor people are thinking about our society and what are the problems. तो थोड़ा हिंदी में बताऊंगा. एक आदमी चढ़ा बकरी लेके उसके अंदर, तो मैंने इसे पूछा बकरी कितने की आई भाई? ये बात होगी करीब अराउंड 2006 और 7 की 5,000 की बकरी. मैंने कहा क्या बात कर रहे हो, 5,000 की बकरी? तो गाय तो फिर 1 लाख की होती होगी. क्योंकि साहब वो अकाल वर्ष था, गाय तो 2,000 रुपये मिल जाती है. मैंने कहा तुम मजाक कर कि नहीं सर, ये बकरी है 5,000 की है, गाय 2,000 रुपये की है. मैंने कहा व्हाट इज द प्रॉब्लम, क्या है, व्हाट इज द प्रॉब्लम? उसने कहा सर गाय के बछड़ा हो जाए तो क्या करें उसका, बैलगाड़ियां तो है नहीं, क्या करें उस बछड़े का, और हिंदू होने की वजह से उसको कटने के लिए बेच नहीं सकते, तो गाय कैसे पाले गाय. लेकिन बकरी के जो बच्चा होगा, और ये लाल बकरी है, लाल बकरी का जो बच्चा होता है वो कटने में जाता है, इसको एक पर्टिकुलर फॉर्म है, वो बड़े पैसे देके खरीदती है लाल होने के, इसका बच्चा लाल ही होगा और उसकी बड़ी अच्छी पोस्ट मिलती है. तो हम बकरी पालते हैं, गाय क्यों पालेंगे? Those who are sitting in the cities, those we who are actually rich or upper middle class, we do not know what are the problems of the villages. And we are thinking of development. लोडिंग टैक्सी बना दी सर, बड़ी फास्ट चलती है, 15 मिनट में सामान आ गया. क्या दुनिया पहले हो जाता है क्या? अगर सामान 1 घंटे में आ जाता है कार्ड के ऊपर. What is the thinking? Anyhow, I cannot change. We cannot change the whole economics. This is, but as engineers, if we can develop, there are 3 simple principles. You should know what are the alternatives, how can you develop a product which is cheap and good performing, and how it is impacting the environment. if you can take care, I am always of the strong principle. As of today, we cannot reduce the pollution, the total pollution, but we can reduce the rate of increase of the pollution, and in that we as engineers can contribute. And this is always you should have this in mind. गांधी जी कहा करते थे, गांधी जी को एक बार मेजरदार शिबिर ने पूछा कि मैं कोई काम कर रहा हूं तो मेरे ऊपर से पता चले कि ये सही है ये गलत है, तो उन्होंने कहा कि आपने किसी गरीब को देखा होगा ना, तो आप ये सोचिए कि इस काम को करने से उस गरीब का क्या भला होने वाला है। अगर आपको लगे कि उसका भला हो सकता है तो वो काम एकदम सही है, धर्म सम्मत है, आप उसको कर सकते हैं। So we engineers should always think that the research which I am doing, the product which I am developing, that the lessons we are giving to the students, whether it is going to help the society, the poorest of the poor of our society, and how it is going to save our environment, save the materials, reduce the wastage which is being produced, then you are successful teacher and successful engineer. These are the words I would like to say. Then last, one important thing I would say that we are the luckiest one that we got the opportunity to become engineer. Don't think that it is due to your caliber only. The society as a whole, not only your parents, society as a whole has contributed something to make you engineer. Now, when you, after becoming engineer, if you think that it is only due to my capabilities that I am engineer and I have every right to enjoy all the luxuries of this world, and why should I think about the poor who are not working properly, who are not being educated, they are not sincere in education? No, I think is this type of psychology we have. We are not. I am always very, very thankful to the whole society, the poorest of the poor, who is when he is purchasing oil from the market, he is paying some tax. And that tax is utilized by MBM Engineering College, where when I was a student, I paid only 300 rupees yearly fees. How can I forget? अगर एमबीएम इंजीनियरिंग कॉलेज में सस्ती एजुकेशन नहीं होती तो मैं गारंटी के साथ में कहता हूँ मैं बीकॉम करता और किसी जगह तदरक का किसी प्राइवेट कंसर्न में या गवर्नमेंट में तदरक का काम कर रहा होता. It is only because of the MBM Engineering College and a nearly free education that I was able to become an engineer, and then I adopted teaching. And and from my side, with my best effort, I have tried to contribute to the knowledge of the engineering and impart my knowledge. Whenever I give my lecture, I give from heart, not only from mind. And I want to contribute the maximum to the knowledge. And I think कि मैंने इस धरती का ऋण उतारा है, और ये मैं आप सब इंजीनियर्स और स्टूडेंट्स से रिक्वेस्ट करूंगा कि इस धरती का केवल आपके परिवार का नहीं, आपके समाज का नहीं, कि आप बनिए तो बनिए, समाज का भला करेंगे, करिए उनका भला, लेकिन जो जितने गरीब है, जो पुअर है, जिनको रोटी भी नहीं मिलती, उनको हमेशा ध्यान में रखिए. And we cannot do directly any help, and I am not in favor that you should go to some colony colony of poor people and one fine morning out of 365 days into two times meal they require, एक दिन आप जाके वहां पे 10 किलो अनाज देके आ जाते हैं. Now you feel that you have done the service of the society? No. There are 365 days, 80 years age, 2 times food and other things are required by them. And this can be contributed only if your tax money is properly utilized by the government to provide the facilities first to those poor and then to the other section of the society. And as engineers, what we can do in this respect, we should always think of. Thank you for patience hearing. I think I have taken too much time and gone somewhat beyond probably the main aim of the FDP. Thank you for patience hearing, and I am very grateful to the organizers of the FDP to give me this opportunity to interact with the engineers of engineers, that is the teacher of the engineering colleges, who polish the students to become very good, eminent engineers and serve the society. Thank you very much.
Thank you, Professor Karwa sir. for your valuable motivation. It was really very impactful speech. We are fortunate that our Vice Chancellor has spared his valuable time for this FDP.
We are thankful to Honorable Vice Chancellor. Probably he may likely must be a very busy person. And it is a great thing that he has spared some time to be with us and engage us that the program is having a great importance in the uh, university's outlook also, and that is great thing. We want such type of vice chancellor who promote academic activity and interaction between the teachers and engineers. Thank you, sir, very much. Thank you, sir.
Pro- Professor Amrish Saran Vidyarthi is presently the Vice Chancellor, Bikaner Technical University, Bikaner, since 4th May 2021. Prior to his current appointment, Sir has served as the Director of Government Engineering College, Nanhipari Simant Engineering Institute, Pithoragarh, Uttarakhand, and Institute of Engineering and Technology, Lucknow, Uttar Pradesh. Professor Vidyarthi is credited with the creation of a world-class research and teaching infrastructure at Birla Institute of Technology, Mersra, Ranchi, where he served from 2003 to 2014. Professor Vidyarthi has made significant contributions in the area of industrial and environmental biotechnology, food biotechnology, cancer biotechnology, computational biology, and bioinformatics, and completed more than 10 sponsored R&D projects. Professor Vidyarthi has supervised 25 PhDs, 67 PG dissertations, and published over 275 research publications in peer-reviewed journals and symposia. He holds 2 patents out of 6 filed in Indian process patents on production of various biomolecules. Professor Vidyarthi also gained expertise in value additions to waste materials during his stay at Institut National de la Recherche Scientifique, University of Quebec, Canada, from 1999 to 2002. Dr. Vidyarthi is the member of Biotechnology Advisory Committee of Jharkhand State Biotechnology Board, and nominated member of Task Force to various union ministries. Dr. Vidyarthi is elected Fellow of the Institution of Engineers India and Institution of Electronics and Telecommunication Engineers India, and is a member of Indian Society for Technical Education, that is ISTE, Biotech Research Society of India, that is BRSI, and Association of Microbiologists of India. Professor Vidyarthi in the coming years wishes to position the Bikaner Technical University one amongst the India's topmost technical universities, with focus on building core research competency, developing world-class teaching programs, nurture translational research, and encourage innovation for wider impact on society. I would request him to say his blessing words for organizers and participants. Please, sir.
Uh, Thank you for nice introduction. Honorable Professor Rajendra Karwaji, my colleague Dr. Jay Prakash Bhamu, Rahul, and Harpreet, and all other organizers, the team of this very important programs, the faculty members of various institutions associated with the Bikaner Technical Universities, and dear participants. First of all, I express my extreme, the thankfulness to the organizer to giving me such an opportunity to speak on the text. Actually, this is the, I think, first core engineering, FDP, faculty development programs. Why I said the first of the core engineering problems and providing the solution as the being engineers, it is our first duty to after studying so many subjects and doing a lot of experimentation. It is the first time where we have to go for the product design. Now, the product design is, as Dr. Rajendra was, mentioning, it's a very complex problem, and it's required a lot of thinking process before coming to the preliminary design of the product, you have a lot of attributes is required to understand the requirement of the product. And the same time, this product has to be very cost effective, green in nature, that's causing less pollution, and then the sustainability. Most of the people, while we are designing the product, we forget about the sustainability. Our product, if it's a very, of good quality, even if it's lacks the attributes like the cost effectiveness and the relevance to the need of the society, as well as the availability, and in the delivery times should be very, very small, because say for example, today's we are facing a problem of COVID pandemic, right? Here, most of the the institution will come out with a supply of the oxygen, and I'm fortunate that our this college has come out with a solution to provide the oxygen concentrator in a very short time and in mid of this crisis. So if we can go for those kind of the product design, definitely it will be very helpful to the society at large, as society is looking from the engineer itself, as we say that we are the creator. So we are created in the two form. One is the good human being or human resource, and another is the solution of the existing problem. Now, the second thing of this, the FTP is the prototype development. Now, even if your design is good enough and it passing a number of the problems, a number of the the attributes which are good enough, and it's a perfect design, but if you are not able to make the prototype and you cannot translate it in a product which is very competitive and cost effective and providing the the faster solution with the accuracy and sensitivity, that product design does not have any significance. So the both the the topic which are clubbed together, and they are interrelated, basically the design as well as the prototype development. Now we have a lot of engineering solutions available and processes are available, where we can translate it, our project design in a prototyping and the product development. So basically, like the 3D printing is come out. It has a really great significance in such a way that we can design atom by atom and the phase by phase. So actually we don't have those kind of the tools available, and that's why the engineering product design was a really cumbersome job for an engineer to come up with this. So I congratulate the organizers of this important activity, which has direct relevance and direct relevance to the engineering education, research, innovation, and the product development, as the people have young mind which is very good in theoretical knowledge, but they cannot produce the products. So it's a very good thing, and I just want to mention a small thing, as Professor Rajendra was telling about the small innovations integrated in the existing products, which can save the cost. I was working in Indian Institute of Engineering and Technology, Lucknow. One person from Devariya, of Uttar Pradesh. His academic background was only 10+2. and rather 10th was the he has passed the 10th examination, but he was not able to continue and get the 10 plus 2 degree. He came up with a solution of engineering problem. He has told, the name was, I think, Vivek Patel, and you might have, heard his innovation. And what he did, he has, designed a disc and, couple, the motorcycle and enhance the, he has small bit changes on the nozzle itself. And by this way, he has claimed that his motorcycle, the efficiency, fuel efficiency of his motorcycle was enhanced from, 60 kilometer per liter to 200, kilometer per liter. That was the really great. And when this proposal has been sent to Council of Science and Technology, the CST, better known, of UP, and they have forwarded this problem and for the assessment of this solution to me. And that time we have started seeing the back to the engineering, the problem and the solution what he has proposed. We find that this was, pushing the air, in around 30 to 40% more. So total combustion was, enhanced. And by this way, we were expecting that 30 to 40% of the fuel efficiency can really be, enhanced by this action. Then we start cultivating those by making those kind of, we were very much concerned about the, the torque. Because initially, if it is, going very, very fast, then what happens, it may have certain problem of continuation. Or once the, the vehicle is stopped, then to start it, that would be the major issue. So then we have conducted number of experiments with NIT Allahabad. Professor R.K. Srivastava was there that time. He is now no more with us because last year he has taken the last breath. But because of this, then we have gone for the patenting of this solution. And then we have also approached to start. And I'm happy to, tell you, announce at this point of time that the government of India has given around 10 crores, mentioned the 10 crores rupees for the, changing the design of the vehicle and amount of this. He has made number of, the articles in newspaper, and he has shown this product in various exhibitions. And we were very happy that though it was a initial, the opportunity is given by the CST to me, but I put the honest efforts to connect him with a good institution, with a good professor. And then finally he has, come out with this kind of the grants as well as the product development. And he has already, modified the bike, around more than 200 bikes, and the people were appreciating and giving the feedback that really that works. So I appreciate Professor Rajendra that he has telling that this kind of, or rather he is very much keen to, to inspire all of us that if we can make a small, slight modification, okay, which has, which are improving the design or the products by say 10% or 15% or 20%, that would be a good, the contribution from all of us. Because if you are saving the resources, that would be good enough. I will also appreciate the other points that before going for the product design, we should think of the lighter in the weight of the products, and the same time the material should be taken, which can be a composite material that can be prepared out of the waste, or it's useless for the for the society or the environment. And if we can club together, this will be definitely enhance our capabilities, and we can testify that yes, if we can do those kind of the products and the lighter in their weight and in efficiency, that would be really great, and that is the need of the hours also. So I basically congratulate all the organizers and the participants also, that they are learned and inspired to make their own design of a product which they can think of, and making the product development and the prototype developments. So thank you very much for giving me an opportunity to interact with you, young mind, on a very relevant engineering problems. Thank you very much. Jai Hind, Jai Bharat.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, Honorable Vice Chancellor, sir, for giving us motivational words. Now I request Head of the Department of Electronic Instrumentation and Control Engineering, Professor Harjit Singh, sir, for his valuable words and vote of thanks. Please, sir.
Sorry, the mic is muted. Honorable Vice Chancellor, sir, eminent professors and invited experts for the technical session today. Principal Professor J. Prakash Bamu, sir, Registrar of Engineering College, Bikaner Manoj Puri, sir, coordinator for this FDP, Dr. Raul Chaudhary, sir, participants and guests. A very good morning to everyone. It is my proud privilege to propose the vote of thanks for the 5 days Atal FDP starting from today, organized by Department of EINCE. From the core of my heart, I would like to express my gratitude and heartfelt thanks to Honorable Vice Chancellor, sir, for gracing this occasion and enlightening us with his words of wisdom. Thank you, sir, for sparing time, for guiding us from a very busy, hectic schedule, for being present with us on this FDP of national importance. Thank you, sir, for guiding us on sustainability, relevance, faster process of products, 3D printing, use of waste, and other things, with the technical details also. Your words will be guiding us always, sir. Now I thank experts, speakers who have joined us, Professor Karwa, sir, for the first session. Also, I thank Principal, sir, for his always support and encouragement at every step. I also thank Registrar, sir, Manoj Puri, sir, who is always a crisis manager for us, helping us at every step. I also thank the coordinator, Dr. Raul Chaudhary, sir, for taking initiative and taking this responsibility, and also the chairman AACT and the AACT for entrusting us with this FDP of national importance. And I also thank participants and support staff, without which this would not be successful. Participants have shown their enthusiasm and they have registered in large number. I wish them very good FDP learning for the next 5 days. Thank you once again. Thank you all.
Thank
Thank you, Harjit, sir, Professor Karwa, sir, Dr. Raul Chaudhary, sir, Vice Chancellor, sir, Principal, sir, Manoj Puri, sir, and other guests for their gracious presence in this inauguration ceremony. Now we will formally start our program, and I would like to invite Professor Karwa, sir, for his expert talk. Please, sir.
I'll interrupt. Bhamu sir, now this inauguration session is over, and we are thankful to Vice Chancellor, sir, and all the administrative officers. So I think, could we start this session?
Yeah, you start, there's no problem, but unfortunately, I will join on the way because I'm going to the college. So, sir, I will take the permission that on the way I can join you through mobile only. Okay, so my best wishes to the organizers and thank you once again, Vice Chancellor, sir, and Rajendra, sir. Thank you. Okay, you may start.
Sir, you can present your presentation now. You can share
Okay.
your presentation.
Okay. I am just trying to share it.
Uh, yeah.
Okay.
Echo will not be there. Am I audible to you?
Yes.
Sir, I think Rajendra sir has logged in from 2 devices. So the echo is coming from the other one. Because in the participation, it's not showing.
I think now it is correct.
Yes, sir.
Is it okay now?
Yes.
We have come to the next slide.
Yes sir. सर थोड़ा वॉल्यूम भी आप तेज कर दीजिए, कोई दिक्कत नहीं होगा.
Pardon?
आप सर वॉल्यूम
अभी ठीक है बिल्कुल सर.
वॉल्यूम बढ़ाऊं? वॉल्यूम इंक्रीज करूं क्या?
नहीं ठीक है, अब सही है सर. Now it is okay.
Okay, okay. You can see my slide.
Yes.
Okay. Whenever you are thinking of developing any new product, first you have to see what is the need. So you have to define the need along with constraints. Now, the constraints, there can be many type of constraints, just like cost, then the size, the available materials, available processes to manufacture it, etc. I will discuss them whenever I will discuss that product. Then identify the possible solutions. What are the possible solutions? I give very simple example which can be understood by any engineer. Let's suppose the problem is that you have defined the problem, that the room temperature is very high. So the problem is that you have to cool it. Now the alternatives available are that you redesign the room with such material that temperature of the room is in control. You provide this some operating cooling method, say desert cooler. You can have an air conditioner. So these are the possible solutions. So whenever you have a problem which has been well defined along with the constraints, identify the possible solutions. And then just to start with, you select judiciously one possible solution which is to be analyzed critically. It may be possible that your decision is not correct and that you will have to restart with another solution. Anyhow, you have selected one solution and you start from there. Then you have to, I am giving some examples of designs. That will be because I am basically a person of design. So I cannot give any other example. But I give some examples and I will like to and try my best to to present in such a way that all of the engineers who are sitting here will be able to understand it. So the most after defining the need and selecting one particular solution, which in your opinion that it can be the possible best solution. Okay, now go for the design. Design from mechanical engineering point of view is carrying out the engineering analysis. Even if it is problem of electrical engineering or electronics engineering, you will have to do the engineering analysis. That is the important part. That and when we talk of any product design, you have to include the selection of material also during the engineering analysis. Because if you have selected a wrong material, or if you have not selected the material, then it may be possible that the analysis which you are doing will not be in correct direction. How it can be, I will see in the, you will see later on when I will discuss the design. then optimize the design based on certain criteria. You have to fix certain criteria. Without criterion, cannot be any optimization. And for that, you have to include the manufacturing constraints also. You are developing a product in a particular company or factory, and if you have not seen what are the manufacturing constraints there, then you may come out with solutions from which the product cannot be developed. So you have to very clearly see what are the manufacturing constraints of our organization, our country, or the whole world. Okay, so optimize the design based on certain criteria. I will discuss the criteria in detail. Then manufacture the prototype. Next part. Once it has been optimized, a design is there, then you have to manufacture the prototype. Because while designing the product, you have discussed with the production engineer, you have discussed with the material science engineers, then definitely you will find that not much difficulties are there, but still manufacture the product. And I have shown here by arrow that while manufacturing the product, the production engineer may feel certain difficulty with the certain design parameters which you have specified on the product. Then you will have to rethink and redesign it. So it is feedback nature. Okay. Then during the manufacturing also, the production engineer may point out towards certain other problems with it, and you may have to go for engineering analysis again. So it is all of feedback nature. The information from the next stage goes push you to back to the previous stage or stages, and you will have to redesign. Then once the prototype has been made satisfactorily, the production engineer has been able to produce the product as per the requirement of designer. Designer will have to see after development of the prototype that it has been developed as as per his recommendations. If it has been properly developed, then it goes for the test of the product prototype. Just like suppose a mechanical tension test is to be carried out, or you have to test to see the efficiency of the motor. Then just like that, I have given some example. You have to see what is the running temperature of the transformer. These are all the type of tests which you have carried out. Then you will launch the product. While launching a new product, you have to be always think that the field conditions may be different from your laboratory conditions. So the product which is successful in laboratory may create certain problems in the actual use in the field. So field trials will start, and you will have to take feedback from the customer, and again you will have to go back. To which stage I can't say, you may have to come here or here, and then again test and again go to the customer, launch the product, have the feedback, and this is what we call as development part. Designing, prototype manufacturing or development, and then the real field trials and development part. Just you take this example of this vaccine. What has been said that it is for emergency use. Why it is called for emergency use? Because the test results are from the laboratory, not from the field trial. Now, in the field trials are going, you are giving the vaccination, you will have the reports, you feedback from the patients, and then you will find that okay, in field such problems are there, then it will go back to the company which is manufacturing the vaccine, and then they have to modify it, or they have to specify what are the parameters which you have to control so that there are no side effects, etc. This is how the whole process develops. Okay, now going to the next slide. Now I talk of the optimization criteria. This is very important part. Without this, you cannot develop any optimized design or design which will satisfy the customer. The following are the usual optimization criteria, not necessarily it is covering all aspects. As engineer, because you know about the requirement of the customer, you are from a particular engineering stream, so you may find that some certain other criteria is there. Just like, for example, when you are developing a mobile, the audio or video clarity can be important criterion. So it is from mechanical engineering point of view, or rather you can say very generalized point of view. Cost In 90% cases, cost is always the premise criteria, but there are other conditions, just like performance. Of course, cost may be reduced, but not at the cost of performance. So certain minimum performance guarantee you have to give. Just like when you are purchasing motorcycle, he says that it is 60 kilometer per hour in ideal conditions. So this is the minimum performance guarantee which is there. It may be possible that your motorcycle is actually giving 70 kilometers. But if it is giving less than 60 kilometers, then complaint from the customer will be there and your design will not be accepted. You will have to redesign it. Then the criteria can be low cost. This is particularly for aviation applications where low weight, sorry, not low cost, low weight is important. Then reliability. There are certain applications where 100, almost 99.99% reliability is required, just like aviation industry, nuclear power plants. So there are certain field of application where the very high reliability is required. Now the question is that when you have properly designed, when you have tested the prototype, you have some field trial data also. Despite that, why this reliability point is coming? Because there are uncertainties always involved with certain part of the product development and design. What are these uncertainties? I'm sorry to say that 95% of engineers do not know what are the uncertainties involved with their product. So it is very important to understand the uncertainties. Just like I am giving some examples, you have made certain simplifying assumptions in calculation of loads, etc. While doing engineering analysis, you know that all engineering analysis is not so simple mathematics that 2 plus 2 is always 4. There is no uncertainty here. But they work for mechanical engineering or thermal engineering. You know that when you are analyzing any thermal system, you say that, okay, this parameter has very low effect, so we can neglect it. Okay, we can assume that viscosity is constant, it doesn't vary with the temperature or variation is very small. Such type of simplifying assumptions are always there whenever you are designing or doing the calculations. So these are uncertainties involved. Now, I give one very typical example for mechanical engineers that you have heard the name of Nusselt's correlation for condensation. It was derived, the equation was derived mathematically, very nice. Nusselt was given a huge credit for that. But when it was carried out, experiments were carried out, they found that it was giving results with 25% error. And these uncertainties were due to assumptions which were made by Nusselt in his analysis. So similar, whenever electronics engineer or mechanical engineer, they are making certain assumptions, then load to which the part may be subjected in actual application. You took the example of cycle. It is produced now when it is running on the Indian roads, there may be huge pits. Then if cycle at high speed is going into a pit, what type of dynamic force it is coming? It is very difficult for the design engineer to predict this. So there is uncertainty. Okay. Then uncertainty regarding the material quality. You are taking material from Tata Steel. You are taking material from some other company. Tata Steel material has greater reliability, but don't think that it is having 100% reliability. The reliability of the Tata Steel material may be 99%. Even 1% uncertainty is there. Then during the manufacturing process, some stresses are introduced. Some flaws are there. Not in all pieces. 1 out of 1,000 pieces or 5 out of 100 pieces. Any uncertainty in the manufacturing process during the manufacturing process, some defects may be there. So these are the uncertainties. And for a designer, for product development engineer, it is very difficult for him to. It is not possible that you can test all the products. You are manufacturing 10,000 products daily, 10,000 components daily. It is not impossible that you will test all the components. You will have some certain sampling testing that you will test 5% or 1%. And 1% is giving satisfactory result. You will assume that complete load is good. But this may not be possible. That there may be even then there may be 1 or 2% products which have more manufacturing flaws than possible. So higher the design reliability, better is the cost of the material. So sure, you have to strike a balance between the reliability and cost. If you go for higher reliability, you will have to go for better quality material, more intensive testing, better granulations, and this is all time consuming and cost involved is there. So you have to make a balance between the reliability and cost. But the engineer, design engineer must know that what is the importance of reliability. Then sometimes you go for compact design. Just like take example of automobile. Here, the complete mechanism inside is having a space constraint, so a compact design is required. How a compact design is possible, I will discuss later on. Then space constraints may be there. Compact design and space constraints, they are very close to each other. Sometimes the compact design is done simply by changing a material and saving the cost. So cost may be the consideration. But space constraint is certainly another thing. You have to fit a certain thing in a particular space. So accordingly, you will have to select the material or manufacturing processes so the space constraint is satisfied. Then aesthetic sense, it is important. If you have to, because ultimately you have to attract the customers. So if aesthetic sense is not there, if it is not looking good, then it is not going to, you will not be able to sell it. So however, there are certain requirements where you cannot make any compromise, just like strength. Whatever may be the optimization criteria, I have not given here because the strength is to be there. Or the minimum performance guarantee is there. You will not design an electric motor which will burn after 10 days or 20 days. You cannot, so you cannot design, you cannot make compromise in a design in certain factors. So in the case of, in the slides to follow, I will explain the optimization by taking certain examples. So the example may be from engineering, mechanical engineering point of view, but other engineers can also understand it. Suppose the need, I am coming first to the need. There is a need that you have to join two rods. There is a need that you require a prime mover, just like an electric motor of so much power and so much RPM. Then taking again to the mechanical example, so you have to design two circular cross section load. The load is 30 kilonewton, which is of nature varying from tensile to compressive in both directions it is acting. But the infrequent variation of load is there, low number of load cycles are there. This is how you have to define the load clearly. If incomplete definition of load is there, you cannot design. Then constraint. Constraint is facility you require. You have to join two rods with the facility of easy assembly and disassembly is desired. This is complete definition of the problem, load, constraints, and the need. Now the selection by mechanical engineer, there are two, three, four types of different joints are there, and you have decided that a quarter joint will be suitable one here. Now manufacturing constraint you have seen, you will have to interact with the production engineer. Okay, what are the manufacturing facilities you are available? Definitely you will ask, what type of manufacturing facilities would you require? So you will spell out that, okay, casting, forging, rolling, etc. I require such type of facility. Then he will say, okay, I have forging and upsetting facility. So for developing the quarter joint, which you have selected as a solution, a typical solution, forging and upsetting are available, and from engineering point of view, these are the best one. So you are no worry. Then material available, you will have to again ask the production engineer what materials are available in our store. You will say it is cast iron and plain carbon steel, only no alloy steel. Plain carbon steel, carbon 0.2 to 0.4%. These are the two materials available. So you will have to select one of the materials out of here. Okay. Then how many number of pieces are required? A few in numbers or large in numbers. Accordingly, everything is decided. Whether you should go for automation or the products will be manufactured on lathe, milling machine, etc. by the labor, expert labor, skilled labor, or you will go for automation. If you have to make products in millions or thousands, you may go for automation. If you have to develop on 10, 20 or 50 products only, then you will have to go for simple machines, and you will have to depend on the skilled labor. Then suppose the design decision is that, okay, the first alternative, I will try low carbon steel. Now see, the alternative, it is very important for engineers. I am talking time and again, what are the possible solutions? What are the alternatives which are available with you? So regarding the material, you have the plain carbon steel 0.2%, 0.3%, 0.35%, 0.4%. because the low carbon is the cheapest one and easy to make the product. Processing is very simple, very easy. So you have selected that I will go for low carbon steel. Your selection, remember that the design is of feedback nature. You by going to the last step, you may have written to the first step in redesign it. This is the typical nature of the design, whether it is electronics engineering, mechanical engineering, or electrical engineering. So you have selected as a first trial low carbon steel. Okay, and you have recommended the process that it will be upsetting process followed by machining. Okay, I go to the next slide. So, for mechanical engineers, it is the quarter joint showing all the dimensions. For other engineers, just think that this is the muscle component which you are designing. Okay. Now, this is the road diameter. This is one of the roads. This is another road, and the road diameter is D. And these two roads are to be joined by this particular component. This in mechanical engineering is known as quarter joint. For usual proportions are given that if in emergency you have no time to derive, you can rely on these proportions which are available in handbooks, which are available in codes. If you see BIS code, you will find that these proportions are given. Standard textbooks, the proportions are given. So if you have no time, if you want 1 or 2 pieces, there is no need of wasting time 1 month or 2 months in designing. You can rely on usual these proportions. So you see that you just find out the road diameter, which is simply in tension or compression. A very simple 2 minutes formula is there. You find out the diameter of the road. Once the diameter of the road is known, all the dimensions of the quarter joint are known to you from these usual proportions. But remember that usual proportions do not give always the optimized solution. It is one viable solution. It is just like bullock cart, which has served for thousands of engineers, is not optimized solution. It is a solution which is workable, which has worked, which has served, but not an optimum one. Okay, so if you use usual proportions, you will have a product which is serviceable, which will fulfill your requirements, but not in an optimum way. So how it is? I just see it. Your design analysis, you have selected the material, factor of safety. Now this is another decision where engineer has to take, whether it is mechanical engineering or electrical engineering, you have to keep some factor of safety. So here a high factor of safety based on yield stress has been taken. And why this high factor of safety? Probably in design, the most difficult part is to select the factor of safety. And sometimes we design engineers say that it is factor of ignorance, because you have the not complete information or the information is not there. You are very uncertain, so you are going for a high factor of safety. Really, it is a very difficult decision. After 5 years service in field, you find that not a single case of failure has been reported. Then you can think of reducing the factor of safety and giving a cheaper product. This is how the sometimes development may continue for years together after field trials. So here the designer has taken a decision the factor of safety will be 3.5. Why high factor of safety? Because of reversal of the load. Now you find out the tensile stress, shear stress, and then find out the road diameter. Use the usual proportions. You have all the dimensions. So a workable design is there. Now we go for optimization. Now you do the what we call as strength analysis, because all dimensions are known to you. So there are different various modes of failure. And the interesting thing about this particular element is that a large number of modes of failure are there. There are 12 modes of failure. One was basic, that is road diameter. So remaining 11 modes are there. With these proportions and load known to you, you have find out that in different modes, this could be the strength, which we call as strength or resistance. Which must be greater than or equal to the external load. So I have given the values here. Again on the next slide. Now you see that the external load was 30 kilonewton. Because mechanical engineers know that during the assembly, you have to push the water inside by hammering it. Now we do not know how much assembly stress will be there. So you have to take again some assumption is there that 25% extra load will be there due to this initial assembly stress or load. So design load you have taken as 37.5 kilonewton. As far as the basic load is concerned, 30 kilonewton outside load. And you see that the component has been designed by using the usual proportions. And you can see all of the in different modes, in all 12 modes, the strength is greater than 30,000 Newton. So it is workable solution, but still risk is there that if assembly stress is too much, failure may occur. No, but that is second different. The important thing that you see that these four strengths modes in these four modes, the strength is less than the design load. So you will have to be very careful during assembly that too much hammering will not be there. Okay, you can tolerate it for time being. But you see this mode, your strength requirement is 37.5 kilonewton, just approximation, and strength is 60,000 Newton. In this mode, again 40,000 Newton, 60,000, 43,000, 56,000, 49,000. Is it a good design? Optimized design? No, it is not optimized design. I give very simple example which can be understood by any layman. A chain consists of 100 links. A chain consists of 100 links, and one link is very weak. All links are having strength of 1,000 Newton, but one link is having strength of 800 Newton. What is the strength of the whole chain? It is 800 Newton. Because if you apply a load greater than 800 Newton, then that particular link will fail. Now, what is the sense of using 99 other links of greater strength? It is shear stress. You can optimize it. If load is 100 Newton, you make that the weakest one of 100 Newton, 1,000 Newton. But remaining links should also be ideally should be of 1,000 Newton. If any link is having strength, say 1,200 Newton, it is wastage of material. So the best, what is optimized design? Optimized design is that in all modes of failure, the components should have equal strength, and that is the optimum design. But remember that it's just in electric circuit, you optimize it, but you have to keep one component weak, just having strength equal to the external load. So if overloading is there, that component will fail, and this failure will have the minimum damage to the component. So taking example of electric circuit, you provide the fuse. So if overloading is there, heavy current is flowing, the fuse will blow up, and there will be no damage to the system. So similarly in this coater joint, the cheapest component is the coater. So if overloading is there, the coater should bend. And once it will bend, the joint will be loose, and you will say the joint has failed. So you can change the coater. So you have to make all equal strength at all modes, but the weakest will be the coater, because it is the cheapest element which can be changed. So I have tried by modifying the dimensions, and now you see that different modes are having these strengths. And still there are 1, 2, 3 modes which are having greater strength, much better than earlier one design, but it is not still optimized. Now the question is that a component is having 12 different dimensions, 12 modes of failure, and by hand calculation, how difficult it is to make it such that it has equal strength on all modes of failure. That's why computer program is required. Manually, you will have the fatigue, and either you will not attempt another alternative, or you will start making mistakes. That's why in design it is essential that you develop the computer program if it is not available. And once computer program is there, you can readily change the dimensions and find out the optimum solution. Now, how much computational time is required, that will depend on your skill. That if you are finding that in particular mode strength is too much, then you should know which component's dimension is to be reduced, so that its strength is reduced, but other modes are not affected. It is a really very intelligent process for the designer to do the optimization. So computers are available there, and it is not such a simple problem. It is really a very intelligent activity to carry out the optimization. Now I give one another example, and I think Most of the mechanical engineers think that the design of the lever is probably one of the simplest problem of machine design. I say no, it is not so simple. You go in depth and you will find that it is very interesting. You see that these are the lever cross sections which are used. Those who are not mechanical engineers, they should simply say that there is certain component for which there are four alternative sections which can be used: circular, elliptical, rectangular, and I sections. Now, what are the specialty? Circular, easily available. Rolls are available in the market. You purchase any size, make the component. Very simple, simple solution. Then, if it is elliptical, either you will have to go for forging or casting. So you will have to make a decision. First, whether circular or elliptical, then forging or casting. No, it is not very simple. Then you have another solution, rectangular. Rectangular one readily available in the market. So it can be better solution than elliptical. Not necessarily. Here, you see that I will show the arrow in this direction. Those who are mechanical and civil engineers, they know that the lever is subjected to bending for mechanical engineers. For civil engineers, simply you think that the lever is there is a component which is subjected to bending, and in bending we know that I section is the best one, but it is very difficult to fabricate I one. So I section is the best one, but the way to fabricate it for mechanical engineering, if it is metals, it is forging. Forging is a difficult process. Why? It is costly process because a forged machine is very costly affair. Although component will be of very good strength, but forging itself is a costly process. So if you want to produce large number of components, you can go for forging. A few number of products. Now the competition is between the elliptical and rectangular. Those who are from mechanical engineering and civil engineering, they know that this is the best section, this is the worst one. Now, this you have to produce a few number of components. You cannot go for I section. So the choice is between rectangular and elliptical sections. Civil and mechanical engineers know that this is a moment of inertia will be more than this elliptical section. So you will have to go for rectangular section, which is readily available in the market. But sometimes it may be not possible that you are not getting the right cross section. Then you will have to go for elliptical. The good thing about elliptical is that you can make it, if you are making casting process, you can think of elliptical. It can be made by forging. So with this discussion, you can very well think that how difficult for engineers to make it a decision. So it is all prepared nature. You will think of one thing, will go to the last stage, do the cost analysis, do the product testing, and then you will have to come back. No, elliptical decision was not good, and I should go for I section. But sometimes, if you can take correct, there are certain constraints and information available with you, and you can make very good decisions. You see, I have given 5 examples. You got one lever loaded safety valve. You see, this is the lever, and it is of uniform cross section or rectangular cross section. Very simple. You take any plate of, it may be possible that this strip is available. This strip is available with you, and you have to make the boxes for the fulcrum and the lever pin. And for that, you know that a greater box length is required. So you just put one solid cylinder here, weld it, and then make a hole for the pin or the fulcrum. And it will be manufactured. Few components if you have to manufacture. If large number of components have to be manufactured, you may go for forging or casting. If casting is there, you will not go for rectangular cross section. You will use elliptical cross section because some products of rectangular cross section cannot be casted properly. You see this lever. Now, due to this typical shape, you cannot manufacture it from simple plate. Tapered is required. Then you see that this is plate in this direction, this is plate in this direction, this is plate in that direction. Of course, you can manufacture with this plate welded here, this plate welded here, this plate welded here, and making the bosses if you have to make few components. Now, the basic load is bending load. Again, as is usual levers, you will have to find out what is the load is steady. If it is low number of cycles, 10⁻³ or less. If it is 10⁻³ to 10⁻⁵, the factor of safety must be increased. If it is fatigue loading, if the number of loading cycles are more than 10⁻⁶, fatigue loading is there, and you will have to go not for simple welded design, but you will have to go for forced cross lever. Then coming to the next slide, this is rocker arm, which is used to open the valve in the engines, and we know that it runs at a very high speed. Where very large number of load cycles are there. If it is 1500 RPM 4-stroke engine, valve is to be opened 750 times per minute. You see during the life of the engine, how many number of cycles, billions of cycles will be there. So the loading is fatigue loading. Lightness is important because it has to move and return to its original position, again move upwards, move downwards. So it should be light so that inertia forces are less. So subjected to fatigue loading, lightweight, and the high lightweight. So you will have to go for medium carbon steel or alloy steel. And I section will be give the lightest possible lever. So you will have to make it by forging. You see that according to application and requirement, you have to make a decision regarding the manufacturing and materials also. As far as designer, simple designer is concerned, he is concerned with the loading and I section. But that is not a design engineer, and you cannot make optimum design until unless you cannot decide regarding the material which you will use and the process which you will have to use. So it is not possible that a designer will be very good in material selection or knowledge of the materials, how they will be heat treated, what will be their own properties. You cannot be. So you will have to discuss with the material science engineer while designing. And then regarding the forging process or manufacturing process, you cannot be expert. So you will have to discuss with the production engineer also. So you see that the designer's work is most difficult work. And I used to say, हिंदी में बताऊंगा मैं कहता हूँ, हमेशा क्लास में कहता था, डिजाइन पढ़ाता था कि माँ, एक औरत की पूर्णता माँ बनने में है. एक औरत पूर्ण तब होती है जब वो माँ बन सकती है और एक ऑफस्प्रिंग को जन्म दे सकती है. तो एक इंजीनियर की पूर्णता तब है जब वो डिजाइन करके जो प्रोडक्ट दे सकता है, केवल डिजाइन नहीं, प्रोडक्ट दे सकता है. तो इंजीनियर तो असल में इंजीनियर जो डिजाइन करके प्रोडक्ट बना सकता है वो कंप्लीट इंजीनियरिंग है. सो यू हैव टू बी कंप्लीट इंजीनियर, एंड फॉर दैट आई एम टॉकिंग नॉट अबाउट द प्रोफेसर्स, just like I am a person of design, so I cannot be very good in manufacturing or material selection, but I still have sufficient knowledge to make a decision and then have discussion with the production engineer. That is very important. So I used to say that the most difficult part in the product manufacturing or product delivering to the customer is designer's work. So the designer have to take decision according to the, these are the all constraints that this component is subjected to fatigue loading. Because of inertia forces, you have to keep it light. These are the constraints. So while designing any product, you have to see the constraints. Then you will see this crank. The cranking of the engine, you have to start the engine with the help of a crank. Now, its loading is not only bending but torsion. This is the engineer, design engineer, any design engineer who knows the strength of materials properly, which he must know. The design engineer must be perfect in the strength of materials analysis. If he is not, he cannot be design engineer. So combined loading not a big problem. Infrequent occasion, only sometimes you have to start the engine, say 2, 3, 4 or 5 times in a day. So the number of cycles are not large. It is only produced by cast iron. The question is why cast iron? It's exclusively. I have not written on any other material. Because of this complicated shape, this is actually the crank. Up to here, this is the crank. This is the crank part. Because of this complicated shape, it is very difficult. And as you see, its size is quite big. It is very, very difficult to produce it by forging. It is very costly affair. Very costly affair. So you will have to go for cast iron. And when it is cast iron, the whole thinking of designing will be changed because cast iron is very poor in bending. Cast iron is good in casting, wearing, but is not good in bending and torsion. And accordingly, you will have to select the factor of safety and you will have to design. You see how difficult it is. Now, casting is the method because of the complicated shapes. I go to the next. Very important thing. Here, I will not discuss this spinner. This is spinner, you use it. Now, the loading is bending, shearing, crushing. infrequent operation. Sometimes you are using it. Material will be because of heavy load and lightness is required because of space constraint also within carbon steel or alloy steel. I section invariably because of lightness and forging invariably you have seen on the spanner. It is written drop post means it has been made drop hammer forging machine. Okay. Now the question is, can I make this spindle from a simple plate? This is plate of thickness. What is thickness? This thickness required. This I section maximum thickness required. I take a plate and cut it like this. Will this spindle be good? No, because a rolled steel sheet has fibers in this orientation. So if you cut the sheet to make the spindle, you see that this fiber. If I take this example of this fiber is going up to here and not connected to the whole body of the spinner. So there is possibility that failure will occur here, may here, or any here like this. If I go for casting, there is no orientation of the fibers. It is uniformly distributed. Again, it is weak. But if I go for forging, I have given the typical fiber orientation. In forging, you see that all fibers are going to the whole body of the spinner. So when you are putting a load, I have shown the load here. When you are putting a load here, no fiber is just having a small length or not supported by other fibers. This fiber, even the first fiber, second fiber, any fiber is going to the depth of the body. So it will have the greatest strength. And this gives this particular example gives us indication that what is the importance of the forging process in designing. Then I go to the next example, selection of design of drives. Rahul, I would like to continue for half an hour more. Is it okay?
Yes, sir.
Okay. Okay, good. Because I started late. I started at 10:05. Now, the selection of the drives. This is the first most difficult part for a design engineer. To transfer, what is the need? To transmit a known amount of power from given driver and driven machine are given. Driver is given, say, an electric motor or an engine, a turbine. Any driver is there. Driven machine, it may be a lathe machine, it may be a pump, cursor. So any driven machine is there. And what the RPM of the motor or engine, RPM of the driven machine required RPM may be variable RPM. Maybe are known to you. This is the problem definition. Now, loading, you will have to find out what type of load is there. Steady load, minor shocks. If minor shocks are there, you can create in mechanical engineering steady load. Medium shocks of two heavy shocks. There may be medium shocks, heavy shocks. You will have to find out according to the nature of the driver and driven machine. If driver is say engine and driven machine is centrifugal pump or blower. Blower load is steady, but engine output is not steady. It is variable. So wherever power stroke is there, a shock is there. Now engine is 4-stroke engine or single stroke engine. If single stroke engine is there, more shocks are there. If it is 4-cylinder engine, less shocks will be there. If the driven machine is say a reciprocating pump, then whenever compression stroke will come, the load will increase. Then during the success, the load is reduced to almost zero value. If it is crusher, then whenever crushers down will strike, a very heavy stroke will come. So you have to study the characteristics of driver and driven machine. You see just how interesting it is designers work. So very interesting, very interesting. Then intermittent operation, you want to operate the machine for 3 hours. In 2 shifts, 8 to 16 hours. In continuous running, 16 to 24 hours. That is known as continuous running. If continuous running is there, you have very less time to inspect the machine, whether it is all components are in the correct shape, looking to be correct shape. And then oiling can be very difficult to do the oiling in between, or very difficult to clean it in between. So if continuous operation is there, you will have to go for a high factor of safety. If 2 shifts are there, then 1 shift is available for maintenance. If it is intermittent operation, then you can assume it to be steady load. Then space constraint. Suppose you have to make a compact design, space is very small. You will have to go for gear design, gear drive. If large space is there, आप एक चक्की पे गए होगे ना, ठीक है ना? एक प्लेट बेल्ट सकता है काफी लंबी डिस्टेंस पे, है ना? 10 फीट की डिस्टेंस पे, space is not a constraint. Safety requirement. If you are using the belt, if overloading is there, belt will start slipping. So there is no chance of damage of the driver or driven machine. But if you are using the gears, and I'll take an example. You are running a lathe machine using gears. An electric motor is driving the lathe machine using the gears. Take this example. Now, due to foolishness of the labor, semi-skilled labor, he has taken too much depth of the cut. Rough cut is there, and the depth taken is too much. His speed is quite good. A very heavy load will come over it. Suppose it is being driven by a 5 kilowatt motor. Now the load is coming as 10, requirement is 10 kilowatt or 12 kilowatt. Motor is not able to give it, but the gears are there, they may be able to transmit it. So what will happen? Either the tool will be broken, or the gear will be spoiled, that will be broken, or the gears will fail, or the motor will burn out. So what should be done? A safety element must be there. So if we put a belt drive in between, then whenever loading will be there, then belt will start slipping. So you cannot put a load more than 5 kilowatt because the belt is there. Belt is safety element in between. Just like in electric circuit, the fuse is the safety element. So if you try to overload or some circuiting is there, the fuse will blow off. So this is the decision that designer has to make while making the design. Then material availability, definitely you will have to see it. I will discuss it later on. Manufacturing capabilities, what you have. The availability of standard elements, sometimes standard elements are required, whether they are available or not. Availability of skilled labor, noise consideration. Why it is noise consideration is important. You know that V-belt is less noisy. If you use plastic gear, nylon gears, there will be no noise. In audio machines, plastic gears are used. There will be no noise. But if you are using cast iron gears with a scant lubrication, more noise will be there. If you are using a flat belt with a joint, then you know that whenever the joint will come in contact with the pulley, there will be noise cut. Then another pulley cut. This rhythm is there, noise is there. So you have to consider the noise. Then cost, although it is last point, but it is always the first point in most of the products. Now, what are the types of drives? Belt, plate and wheel, chain drive, gear drive. In gear also 4 types of drives are there. So total, what are the possible solutions? There are 4 plus 2 plus 6 and 7 solutions are there. So for this problem, we have 7 solutions, and from all considerations I have discussed, you have to make a choice of it. Because you see how important the designer's decision is there. So suppose, as a trial, the designer has decided that for this particular application, you are going to use spur gearing. Okay, let us try it. Okay, now design of spur gearing. It is for mechanical engineers, but other engineers can follow it. When you are designing a component, machine component, you have to see, you should know what are the possible modes of failure. Those who are non-mechanical engineers, they know that the gear tooth can fail in 3 modes: bending of the tooth, then fatigue failure, uprooting of the tooth. I have shown here. With passage of time and fatigue loading is there. So what is fatigue loading? When number of cycles are more than 10 raised to 6 loading cycles are more than 10 raised to 6, then a fatigue crack may develop. It is not properly designed. This crack will proceed further with passage of time, and ultimately the crack will complete, and this tooth will be uprooted. That is known as fatigue failure, uprooting of the tooth due to fatigue fracture. Then surface fatigue may be there. You know, those are mechanical engineers, that during the meshing of the tooth, first the meshing tooth will rub in on the surface in this direction while engaging, and while disengaging it will move in the opposite direction. So you are pushing the surface with a heavy pressure, first in one direction and then in the other direction. And whenever such reversal of load is there, fatigue failure occurs. Now, where this reversal of load is taking place during the rubbing, it is on the surface. So actually surface fatigue is there. So there are three important modes of failure for which we have to design. Then normal wear is there, which is always will be there. And the gear cannot run forever. With passage of time, normal wear will be there. Normal wear is nothing abnormal. Slowly its size of the tooth will come down. It will be reduced, and after 10, 15 or 20 years, it will be weak and you will have to redesign it. Now coming to the first mode of failure. We know that mechanical engineers that this is the equation which is taking care of the first mode of failure, that is bending of the tooth. Those who are not mechanical engineers, they simply take it as a mathematical problem. There is a mathematical problem that this is the external load and this is the strength of the component, which is function of it looks 1, 2, 3, 4, 5 parameters are there. Pi is not a parameter. So this load carrying capacity of the tooth is function of 5 parameters. What are these parameters? It's not much concern of other engineers. For mechanical engineers, they know what are these parameters. Anyhow, well, now see the alternatives. What is design stress, sigma T? Now, there is long list of gear material. Whenever you are selecting material to design full stack, design stress, first you have to select the material. Now you see the alternatives. There is a long list of gear material. If you see the gear material in a handbook, quality handbook, you will find that there are 30, 40, 50 types of materials available. From cast iron, medium carbon steel, alloy steels of different type. Then non-ferrous metals, bronze, low coefficient of friction specialty is there. In bronze, different classes are there. Then if you have plastics, I have already talked low noise. So you will have to decide a material. Not necessarily that your decision is correct. You will have, if you have certain thing in mind, but okay, this material can do, this material can also do. You will have to start with one material. Design it, find out the cost. Try another material, again design it, find out the cost. You see that so much analysis can one carry out with the hand. That's why computer program is required. So the mechanical engineer should be very good in computer programming. He should be able to develop its program if he is not having a standard program available in the market. For design, some programs may be available, but for all designs, you cannot have the computer programs. So you will have to develop your own program. So you see in the first parameter, there are large number of alternatives are there. Then this factor is known as, those who are mechanical engineers, they know this is known as velocity factor. And it is in function of it is due to dynamic loading. Dynamic load means any load which is where time is the factor. If I hammer anything, it is dynamic load. If load is varying, changing with time, it is dynamic load. Dynamic means time factor is there. Now it depends on which line velocity. At what velocity the gear is running. Which line velocity means gear is just like a circle, a circular disc. So what is the peripheral velocity? That is known as pitch line velocity. It depends on pitch line velocity and quality of gear. Again, when we talk of quality of gear, 4 qualities of gears are available in the industry. Those who are mechanical engineers, they know it. Those who are not mechanical engineers, they should simply know that for this parameter CV, there are 4 types of quality of gears available. So many alternatives here, then 4 alternatives here. Then a form factor. This factor Y is known as form factor. It is a function of pressure, angle, and number of feet. So this Y is function of 2 parameters. No more. Here is phi is having 3 values: 14.5, 20, 25. So 3 here and 1 here. So you have 4 parameters, 4 alternatives. 4 parameters, 4 alternatives are there. Then, if you want to go for compact design, if you take a criteria compact design, a compact design is generally a cost-effective design. Normally, not necessarily. Sometimes a cost-effective design may be other one. But if it is a compact design, then definitely it may be cost-effective. So you see that those who are mechanical engineers, they know that 14.5 degree, 20 degree, and 25 degree pressure signals are used. Now, minimum number of teeth of the PDN is 32 in case of 14.5 degree, 17 in that is number of teeth of the gear. Other engineers can also understand because they must have seen the gear. So greater the number of teeth of the gear, bigger will be the size. If you go for 25 degree, it will be 11 teeth only. So if you compare 14.5 degree and 25 degree, it is 11 teeth minimum. This is 32 teeth. So Indian will be 3 times bigger. So should we always go for 25 degree? 90%, I would say yes, we always go for 25 degree. And those who are mechanical engineers and teaching design, they would say, sir, 25 degree is not used. No, I tell you them that in textbooks it is not available. But now machines are being supplied with gears of 25 degree pressure angle. Unfortunately, in textbooks which are available in the market or handbooks, no data is available for 25 degree. So generally, those who are teaching design, they go for 20 degree pressure angle and minimum number of teeth at 70. Okay, so you will see that in designing and bending only, large number of alternatives are available. Now I go to the next slide. Then fatigue failure. I told you that second mode of failure is fatigue failure. This is fatigue load equation. In this load equation itself, you can see how many parameters are there. V, the pitch line velocity. C, a factor known as dynamic load distress factor. Then the beam width of the tooth. Then the external load. This is not in your control. The variation of B is in a very small range. So not much scope. I will discuss it later on. Important factor is the dynamic factor or load distress factor. Now this dynamic factor is function of the error in bearing action, the actual error in bearing action. Then Young's modulus of elasticity of the material. Again, C is function of 2 parameters. Dynamic load is function of 4 parameters and C is function of 2 parameters. Rather, you can say 3 parameters. If the pinion and gear materials are different, then there will be 3 parameters. Now, the most difficult thing here is, what is this error? Error in bearing action. No machine part can be produced with 0 error. Sans product may be there. It is possible that you are produced 1000 gears, and when you find out that one gear is having no error, it is sans error. सभी औरतें हेमा मालिनी नहीं हो सकती, उसको मैं हमेशा हंसता हूँ क्लास के अंदर कि वो सांस से एरर है. भगवान तो सब प्रोडक्ट एरर के साथ ही बनाते हैं, लेकिन वो 0 एरर के साथ ही आ गई तो वो हीरोइन बन गई. ठीक है ना. सो अदरवाइज भगवान भी परफेक्ट नहीं है, भगवान भी एरर के साथ ही बनाते हैं. मैंने को 5 फुट 4 इंच का बना दिया और राउंड को 6 फुट का बना दिया. मैं 20 किलो से ज्यादा वजन नहीं उठा सकता. एक आदमी है वो 100 किलो उठा लेता है. एक बहुत जोर से दौड़ सकता है, एक नहीं दौड़ सकता. कोई काला है, कोई गोरा है, किसी की आंखें छोटी, किसी की मोटी. तो भगवान भी परफेक्ट नहीं बना सकता. नो मशीन कैन प्रोड्यूस परफेक्ट कंपोनेंट विद 0 एरर. सो यू हैव टू टॉलरेट सम एरर. So this is probable error. Why it is called probable error? I will discuss next. You see, first you have to see what is the permissible error. First you have to see that you have to tolerate some error. As designer, you know that you cannot produce the product with 0 error. So you will have to allow some error. Now, lower the error, greater will be the cost of production. So you will permit the maximum possible error, so that will give the cheapest. This is how the decisions are to be made by the design engineer. So suppose the velocity, pitch line velocity is 5 meters per second. The maximum error, as per the recommendations of the designer's handbook, the maximum error you can give is 0.064 mm. So you should try to select the process of manufacturing such that the error is equal to or lower than this. You cannot give more than this error. Otherwise, dynamic loading will be too much and fatigue failure will be there. So first, according to the pitch line velocity, the designer has to decide how much maximum error he can permit. Remember that first principle is that no part can be produced without error. How much error will be there, that will depend on the skill of the loader, type of the machine, type of the process, etc. So designer knows that error is to be there. He has to limit the error according to the velocity. So this is the error. Now, Suppose the gear which he has designed is having a size which is defined by the number of teeth and module. Module is one particular dimension that is known as module. Suppose module is 6 mm. Now you see that in your workshop there can be three type of gears which can be produced. Precision gear, very low error. Carefully cut gear, more error than precision gears but reasonable. Commercial gears, highest error. You see this, you limit that it should not be no more than 0.064. Now you see that 0.64, it is almost a solution which can be used. So you can recommend that commercially cut gears will be used. This is very important decision. Suppose the error, maximum error here is 0.05. Now and module is 6 mm. You cannot recommend this, you will have to recommend this. Carefully cut gears, the cost will increase. Now, I have discussed many parameters. You go back regarding the materials, quality of gear, the number of teeth, the pressure itself, how difficult it is. You can think of, I would say that 50 alternative solutions are there. Then if I go back, spur gear and then helical gear, 50 plus 50, 100 possible solutions are there. And out of that, I've made for one particular constraint or conditions of operation, one is optimum one. And the designer has to select the optimum one. You see how important you cannot develop a product, a cheap product. A product has been the requirement or need of the customer. Until and unless you are not able to think of the alternatives and take correct decisions. That's why if designer cannot design a correct design, optimized design, the product cannot be optimum. This you should keep this in mind. So the probable error must be always less than the maximum permissible error, and accordingly you will recommend to the production engineer that you have to make carefully cut gears or commercial gears can be used and like that. Okay, go to the next error. Now you have selected everything. Now you have to check it. I am the previous equation was giving the load, which dynamic load which is coming, which is not a Bernoulli equation. Now dynamic load is to be taken care of by the gear tooth. Gear tooth has to take the dynamic load. So dynamic load is again comes from so many parameters. Other parameters are same. This is stress concentration. Those who are mechanical engineers, they know what's the effect of stress concentration. For other engineers, I give one very simple example. You take a strip of paper. A strip of paper, pull it. Can you predict where the crack will develop? No, you cannot predict. The crack can develop anywhere. But on this strip, you give a small cut somewhere and now pull it. You are 100% sure the crack will develop at the cut which we have provided. This is example of stress concentration. There is a stress concentration at the cut. So whenever change in cross section is there, whenever flows are there, when manufacturing stresses are there is a possibility that stress concentration is there and a crack may develop there. So you have to take account of that stress concentration if you by taking this vector Km, selecting this vector. Then sigma yield is known as endurance system means fatigue strength. I told you that the gear is always subjected to fatigue stress. A pinion is running at 1500 RPM. That means the tooth is coming in contact with or coming in base 1500 times a minute. It comes in contact, disconnected, again comes in contact, disconnected. This is 1500 times a minute. Between 1500 cycles of loading are there. So your fatigue loading is there. And if it is steel, medium carbon steel or alloy steel, you can improve the fatigue strength by giving proper hardness. So a designer has to decide the hardness also. How much the material must be hardened. This work is of manufacturing engineer, production engineer. But designers should know how much hardness is required to give the proper strength to the material, to the tooth, so that it doesn't fail in fracture. So you will have to define BHR, mineral hardness number. Now, not only that, a designer should know that the material which he has selected, will it be able to be hardened to that number? Suppose you have taken medium carbon steel and you want that BHR should be 500. No, it is not possible. You should know it. If you are not knowing it, You consult the production engineer that I have selected medium carbon steel and why I want that hardness must be 500. Is it possible? He will say, no, sir. You should not go for hardness greater than 400 and 350. So you will have to redesign. No, 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 no. It is a very difficult decision how to improve the design. So if it is failing in the endurance, then the first step is that if DHL is say 250, you can improve the fatigue strength against crank by increasing the BHN. But there is limitation. BHN cannot be more than 400 if it is medium carbon steel. If it is alloy steel, you can go to 500. So according to the material, you can increase the BHN. But if BHN is already 400, this is not the solution. You go to the next. You can increase the parameter B. But this is also giving small sense. So if you have to increase the strength slightly, you can just B. No, if it is not count, then use better quality gears. What is better quality gear? You have already selected that you will go for carefully cut gears. Now you find that it is failing, so you will go for precision gears. Remember that cost is increasing. So this cannot be a final solution. You will have to think of another solution by increasing volume or by changing the quality of material. So as I have said, that you will have the 50 alternative, you may have 50 alternative solutions. And out of those 50, what will be optimal? Then real load capacity. I told you the surface fatigue is there. How surface fatigue appears? It is pitting on the surface or scratches of the surface. So if you do not take care of it, then there will be surface pitting or scratches. And you know that there is rubbing action in the gears, where the base they rub against surface each other. So if pitting or scratching is there, too much friction will be there and heating will be there. The power will be lost in friction. So you have to take care of the surface durability, that is wear load capacity. And this is function of, among the other parameters, the important is most one is the factor K, which is not the material combination factor, and which is function of, along with the Young's modulus of elasticity, function of surface hardness. Now I am talking about surface hardness. The earlier one was core hardness. Suppose the tool thickness is 5 mm. The core hardness required is 350. And here you find out that to have sufficient strength, the surface hardness required is 400. Surface hardness is on the surface. We measure always surface hardness. So, to designing to production engineer, you will specify the surface hardness. Along with you will say to the production engineer that for this material and this particular tooth size, I want that surface when surface has 400 BHN hardness, the core must have minimum 350 BHN. Now, the tooth thickness is such that, and material is such that, production engineer says that, sir, it is not possible. You have selected a material which is having poor hardenability. So surface hardness will be, we can give it 400, but the core hardness will not be more than 250 or 300. Your design has failed from production point of view. You will have to redesign it. You have to change the material, you have to increase the module, you have to change the quality of the gear. Yeah, coming to the last step and going back to the first step. This is design. Friends, you have seen how beautiful it is to discuss the design and design philosophy. Then another important thing, that gear pair, there is one PDL, another is gear. PDL is smaller, gear is larger. PDL is subjected to severe service and gear is subjected to less severe service. So chances of failure of the PDL is more than that of gear. So you will have to specify that the PDL hardness must be more than the gear hardness. So there are certain modes in between where both PDL and gear are to be designed. That is fatigue factor. You will design the PDL as well as the gear. And so another alternative, another step is there. So you have the whole process is very time consuming. All the alternatives are there. You will have to frequently interact with the production engineer. You will have to interact with the material science engineer because you cannot be perfect. You don't know how much hardness when I give to the surface. What will be the core hardness? So whole interactive process is there. Large number of alternatives are there. You have to take large number of decisions, and greater the number of variables involved, more will be the number of alternatives you will have. And you see how beautiful, how interesting it is. Or in the end, I would say that whenever I teach design, I enjoy the maximum possible. उतना ही मजा आता है जितना अगर आपको शास्त्रीय संगीत में इंटरेस्ट है और आपको शास्त्रीय संगीत में बेस्ट कोई इंस्ट्रूमेंट को सुनते हैं किसी धुन को कितना आनंद आता है उतना ही आनंद डिजाइन करने बनाने में आता है लेकिन डिजाइन करते वक्त आपके पसीने छूट जाते हैं because to see the alternatives, make the decisions, create the alternatives, and select the design, design which is the most optimum one based on your criteria. That's the selected criteria. So, friends, I found that you must have found the whole design philosophy. I have tried to explain the design philosophy, and I have taken all material from my book. I given my email address at the in the second slide. So those who are mechanical engineers, they can always ask questions to me by mailing me on my email address. I will have the greatest pleasure. Okay, thanks, friends. I don't know how the internet was functioning. How much you were able to hear me. I have tried my best, and I will invite now questions. There can be more questions than solutions. What I have presented here must have created more questions in your mind than the solutions which I have provided. I have not provided any solutions, remember. I have discussed only the possible alternatives, the design decisions you have to take out of those alternatives, and the alternative designs and how you can optimize it. Optimization for the cost, size, performance, the weight, etc. Okay? And if any questions, friends? Rahul? Rahul is there?
Yes, sir. I'm there.
I don't know how the internet was running and how much you have been able to hear me.
Yeah, it was a slight echo was there. थोड़ा सा आपका जो स्पीकर है सर उसका वॉल्यूम कम कीजिए. आपका जो स्पीकर है
हाँ
उससे थोड़ा सा इको आ रहा है बट इट वाज रियली
the lecture is over and I would invite the questions immediately or later on you can mail me. Okay?
Yeah, participants may please ask your questions.
Okay, there are no questions. I would say Rahul one thing that I feel that if you have been able to hear my lecture properly, then it will create more questions in your mind than the solutions. And I would ask the mechanical engineers especially, or those who are teaching the machine design, to ask me questions through email. I will have great pleasure to answer them.
Am I audible, sir?
Any query. And not only the subject, but if you have any difficulty in transfer, you can ask any questions to me. My email address is there. And usually, many of the research scholars who are doing PhDs in MNIT or some in NIT Mirpur, this Pilani, Delhi College of Engineering, Some of the students in MPBC could be
I think, sir, one of our participants want to ask the question. Yes, please. Is there somebody
Sir,
want to ask the question?
Yes, sir. Yes, sir. Good morning, sir. Good morning, sir. Sir, this is Dhiren from Buddha Institute of Technology. And
Mr. Dhirendra, just repeat. Your voice is like it's.
okay, sir. Basically, I am in a lecture. So, sir, this is Dhiren from Buddha Institute of Technology, Gorakhpur. And
Okay, then you just give the PDF of my lecture.
Sir,
So,
I will give that PDF, but Dhirendra wants to ask a question.
Okay, very
Dhirendra-
nice.
Yeah.
Yes, sir.
Please,
Sir.
Dhirendra.
Yes, sir. Sir,
Yes, Dhirendra.
I am also from mechanical department from PIT Gorakhpur, and I have some question, sir. As your last PPT showing that opinion is will be the stronger one, but a book that is RS for me, you may know this RS for me. It is given that if pinion and gear both made up of same material, then obvious pinion will be weaker one. But if pinion and gear both are from different material, then what will be the condition that is Lewis gives a condition that is form factor. By finding form factor, we will able to find out the value of the weaker, that is either pinion or the gear. So what will be your response according to that, sir? Hello, am I audible? Hello.
सर क्या सुन पाए आप?
हेलो
Hello.
सर, क्या आप कारवा सर का ईमेल आईडी क्या सेंड कर सकते हैं क्या? क्योंकि
मैं
मेरा
आपको सेंड कर दूंगा. मैं आपको
क्योंकि
सेंड
मेरा
कर
भी
दूंगा.
फील्ड है मशीन डिजाइन, तो सर से ज्यादा एक्सपीरियंस हम उनसे ले सकते हैं सर.
श्योर श्योर, डोंट वरी.
करवा सर, प्लीज आप माइक अनम्यूट कीजिए. हेलो, प्रोफेसर करवा सर, यू आर नॉट ऑडिबल. प्लीज माइक अनम्यूट कीजिए.
Okay, sir. Please give me, sir.
I think he has muted his mic and we are not able to listen.
Okay,
I'll
sir.
just
Dhirendra,
give a
sir.
call.
Hello.
Hello.
Dhirendra, sir.
Yes, sir. Yes, sir. I'm hearing your voice, sir. Can I repeat my question, sir?
Yes.
Okay, sir.
I'm trying to give you an answer on behalf. Sir, when pinion and gear are made up of same material, at that time, whatever the bending trace and Levy's form factor, combine it and end up the product of it, and whatever the lesser product, either pinion lesser or gear lesser, based on that lesser product, you
Yes, sir.
Hello.
हेलो सर, आपकी आवाज नहीं आ रही थी.
सर इको हो रहा है सर थोड़ा आवाज.
Okay.
Okay, sir. Thank you. If possible, please provide me sir email ID. I will directly mail to him. And though my area of research also the machine.
क्वेश्चन हो गए थे धीरेन्द्र का, तो उसको कहना मेरे को या मोबाइल पे डिस्कस कर देगा और या मेरे को ईमेल कर देगा.
Okay, sir. Okay. Okay, sir.
Okay, Rahul.
Okay, sir. Thank you, sir.
This was a valuable session.
Okay, thank you.
I request Dr. Rahul
It's
Raj
not my patient hearing.
Professor Karwa.
Okay.
Is there any participant? Okay. Now I request Dr. Rahul Raj Chaudhary sir to thank Professor Karwa for his valuable session. It was very informative session.
Sound is not clear, sir.
Yeah, Professor Karwa has made very clear that providing that useful product in the ultimate is that ultimate function of an engineer. We have to really deliver the products, and which can be achieved with proper designing and optimization of the design. Rather, it is not wrong to say that prime function of that engineer is optimization. Optimization is very, very important, and that is the very basic process to come out with the perfect design or perfect product, useful product. So sir is always one of the best teacher I have seen, and he has been always very good in delivering his material, his knowledge. And today also we got a very informative session with him. Though I am from electronics and communication engineering background, and sir is from mechanical, but he's still so fascinating. And definitely these first two sessions would be focusing on more on mechanical part. Later on we'll be shifting to the design part or design thinking part, and then thereafter we'll be taking some information about electronics, IoT, and all these things. So what I earlier said, that we have different areas to be discussed in this FDP, and we cannot leave. If I say that I have that electronics and communication background, and I don't want to learn some mechanical concept or some aesthetic concepts or design thinking, we have to go through all these things, all these areas. Then only we can really propose some very good products to the society. So be with us, be patient, and try to entertain this, and definitely will come out with some good learning out of this program. So we have to discontinue this session. I will share the PPTs, and I'll share the Professor Karwa's number. He is such a good person. He always look for such type of questions, and he will be happy to interact with you. I'll share his email address also. So now we have to discontinue it, because within 10 minutes, within 6 minutes, we'll be starting our next second session. Today we had this inauguration session, and that's why we have to stretch up this first session program. So within 6 minutes, we will be starting that second session. Professor A.K. Sharma from IIT Roorkee is also known a big icon in this innovation and process product design. So he would be taking that session and meet you in that second section. I would request you to log in with your second link so that we can start up that another session. Thank you very much. Thank you, participants, and thank you, Professor Karwa sir. Thank you.
Thank you, sir.
Manufacturing by Professor A.K. Sharma from IIT Roorkee. I would request Dr. Rahul Raj Chaudhary sir to formally welcome Professor Sharma in our faculty development program. Please, sir.
Rahul sir, please mute your mic. Rahul Raj sir.
Sorry. So we welcome participant in the second session, in which the different product development stages and computer manufacturing would be discussed by Professor A.K. Sharma. Professor Sharma is a very known personality in innovation and product development. He has mobilized innovation in IIT Roorkee and established one of a prestigious innovation center in IIT Roorkee. So I formally welcome Professor Sharma and thank him for providing us his valuable time for this learning session.
Thank you. Thank you,
Thank you, sir.
Rahul.
Thank you, Rahul sir.
Yeah.
Dr. A.K. Sharma is a full professor in the Department of Mechanical and Industrial Engineering at IIT Roorkee, India. Currently, he is also the Dean of Academic Affairs, that's DOAA. He was the coordinator of Navonmesh Design Innovation Center at IIT Roorkee during August 2018 to March 2021. Earlier, he was holding the positions of Associate Dean, Academic Studies and Chairman, Institute Academic Performance Evaluation Committee in this institution during July 2013 to April 2017. He has obtained his bachelor's degree from Dibrugarh University, Assam. He has subsequently obtained his master's and PhD degrees from IIT Madras. Research interests of Dr. Sharma include advanced manufacturing methods, hybrid processes, microwave material processing, that's microwave drilling, microwave casting, microwave joining, microwave cladding, and surface engineering. Dr. Sharma has filed 10 Indian patents. 5 of them have already been granted. He has published more than 110 research papers in international journals. He has also published more than 120 research papers in various international and national conferences. Dr. Sharma is also a receiver of several reputed international journals, including uh, Journal of Microwave Power and Electromagnetic Energy, Composites Part A, Applied Science and Manufacturing, International Journal of Mechanical Sciences, Material Sciences and Technology, International Journal of Metal Casting, Journal of Manufacturing Processes, Journal of Advanced Manufacturing Technologies, Physica Scripta, Proceedings of IMAC-E, Part B, Journal of Engineering Manufacture, Proceedings of the Part E, Journal of Process Mechanical Engineering, Surface and Coatings Technology, Precision Engineering, Surface Engineering, Tribology International, Tribology Transactions, Tribology Letters, and Covey Metallic Materials. He has also edited one international conference proceedings and was guest co-editor of the International Journal of Advanced Manufacturing Technology. Dr. Sharma contributed one chapter, Electrochemical Discharge Machining, on invitation in the handbook titled Design for Advanced Manufacturing Technologies and Processes, published by McGraw-Hill Education. He has also contributed 3 other chapters in book published by John Wiley and Sons and Taylor and Francis Group. Dr. A.K. Sharma achieved first rank among the Indian researchers with 9.4 citations per paper and 65th rank in top 100 authors of IITs based on number of articles as reported on Indian Citation Index 2016, published by Confederation of Indian Industries. He has developed a full web-based video course on advanced manufacturing processes under the NPTEL program of the Government of India. He has also developed a course as the principal developer on principles of industrial engineering for undergraduate students under the pilot phase of the National Mission Project on Pedagogic Development, sponsored by the Ministry of Human Resource Development, Government of India. Dr. Sharma has advised, supervised 14 PhD programs and 8 other are in progress. He has also supervised 50 master's dissertations and 32 bachelor dissertations. He was working as DAAD Germany Fellow in the Institute of Pulsed Power and Microwave Technique IHM, Karlsruhe Institute of Technology KIT Germany. He has completed 5 funded research projects. 3 other projects funded by MHRD and DST, Government of India, are in progress. He has also completed a few consultancy work. Dr. Sharma is associated with several professional bodies, which include Fellow of the Institution of Engineers India, Member of American Society of Mechanical Engineers USA, Member of Society of Manufacturing Engineers SME USA, Member of Global Science and Technology Forum, GSTF, Singapore, Member of Material Research Society of India, Member of the Indian Institute of Industrial Engineers, and a member of ISTE, New Delhi. Dr. Sharma is also representing IIT Roorkee as the principal member in the Pneumatic Tools Sectional Committee, PGD08 of Production and General Engineering Department at the Bureau of Indian Standards, New Delhi. Dr. Sharma was instrumental in formulating and implementing the new program structures for UG and PG programs in the year 2013 at IIT Roorkee as Associate Dean, Academic Studies. He is also a member of Board of Studies of other universities. He has been external examiner for few PhD theses of different universities, institutes. Dr. Sharma has chaired several technical sessions in prestigious international conferences, including ASME-sponsored Manufacturing Science and Engineering conferences in the USA. Dr. Sharma is a member of editorial board of the ISME Journal of Manufacturing Science published by the Indian Society of Mechanical Engineers, India. Now I request Dr. A.K. Sharma to please continue this session.
Thank you. I think it is very exhaustive, like introduction. Thank you for your kind words, but I was expecting a very short introduction only. Anyway, so thank you so much. Maybe I'll directly go to my presentation. Just 1 minute. Hope my screen is visible to all and I am audible.
Yes, sir, you are audible and your screen is
Very good.
visible.
Thank
sir.
you. Thank you. So first of all, thank you to the Government Engineering College Bikaner, especially Dr. Rahul. So who was after me for this session, one session. In fact, he was requesting 2 sessions, but because of my time constraint, I could not make myself available for 2 sessions. But anyway, I'm very happy to be with you. This is probably for the first time I'm interacting with Bikaner Government Engineering College, and I'm really very happy. Sometimes if days are becoming better, like in future, I would love to come to your campus, meet you all, and probably spend some time there. Okay. But for the time being, since this is the norm now, so we are through virtually. Okay. We are with you. Okay. And I'm really very happy that during these days, a lot of this type of programs are being conducted, and Government Engineering College Bikaner is also taking a lead in this, organizing this type of program. And organizing these type of programs are not very easy. It is a challenging task, bringing the experts to a single platform, and then having their time and getting their availability and all these things. But Dr. Rahul has taken that pain, and fine. So now we are here. So maybe next 90 minutes or so, I'll be talking about some product development, related to some product development. As Dr. Rahul said, I have been involved in development of establishment of one center here, Design Innovation Center. So that is one of the 20 centers in India funded by Ministry of Education. And it is basically to boost the innovation in the country and to boost product development in the country. As you know, all of you we know, we even today, even after this many years of after independence, we are to depend on other nations, developed nations, even some very small countries. Okay, small in terms of area, small in terms of course, population. Okay, they are helping us in many aspects. We used to get a lot of products other countries. We import this product, and thereby we spend a lot of money in importing. So had it been produced in-house in India itself, we could have saved a lot of money, and we could have used those money for other development purposes, say, for example, healthcare. Healthcare is one of the sectors where we need to put a lot of money. Then education. Education is another sector in India which is not very well funded. Okay, so therefore, so government of India thought that we should popularize this innovation, or rather to create a kind of innovation movement in India. Okay, will result in more product development, and ultimately it will lead to reduction in import, thereby saving our valuable resources for our own development. Okay, now that's the very idea, and we have developed that center in IIT Roorkee. And now I'm happy to tell all of you that under that development, under the initiative of that center, Design Innovation Center, we have opened a new department itself, Department of Design. Okay, and that Department of Design is offering now 2 master's programs straight away from DCR itself. That is MDes, okay, Master of Design in Industrial Design, and the other one is Master in Innovation Management. Anyway, so these are some of the related things. Okay, now let's move to product development. Why product development is important, how innovation and product development are related, and what are different stages of product development, and how we can go ahead with design and manufacturing in today's context. Okay, all these things are of course very vast. If you see, product development itself is a 1 semester course, right? Then design, computer-aided design is completely 1 semester course. Manufacturing is several semester courses. Okay, there could be number of courses, as all of us know. But I'm not going to deal all those textbook kind of things. I'm just trying to give a link between these important activities. Okay, just trying to draw the linkages. Okay, how innovation is important, how it is related to product development, how product development is related to design and manufacturing, and in today's context, how it is going. Okay, so with this, probably I will move to okay, the talk. So it is something like, okay, we will start with innovation, product design, then product development, then the process, okay, and then trends. So this is another important thing we should know about product development. Let's move to innovation or design innovation. So what do we understand by innovation or design innovation or innovative design? So there are this is innovation has become a kind of, you can say, buzzword in today's context. Everybody is talking about innovation. If you look at the developments in the last 1 year, sorry, 2 years roughly, yes, 2 years, during the pandemic time, during this coronavirus time, we have developed a lot of new things. If not new, existing things in kind of improved design, with improved design, or in an innovative way, we have adopted many old things into the form or into the functions that are useful today, or that are required in today's context. Like if you talk about the mask, if you talk about mask is nothing new. What is new with this mask? Are we not aware about this mask? In fact, this mask is a very, very old concept in Indian history, if you see. It may not be in Western country or Western history, but in India, mask is one of the most beautiful, most scientific, most health hygiene oriented product, which has been in use for several centuries before, or several hundreds of years it is there. but not in the form like we get it today. Some N95 and all these things, some with some new shape or whatsoever. Okay, not in this form. You are sitting in Rajasthan. I am sitting in Uttarakhand. Rajasthan people have one. What is that? I don't know what it is called in Rajasthani language. Also, one cloth is there. Very long cloth is there. People used to like.
Pagadi.
Put in their head. What is that called, Dr. Rahul?
Pagadi.
I don't know.
Pagadi.
Pagadi. Pagadi. Yes, pagadi. Yes, pagadi. Pagadi. So that is basically they put on head, but at times they cover mouth also. Am I correct?
Yes, sir.
Many times the same cloth they used to cover their mouth and nose also. Basically to like avoid sunshine or burning because of sunshine, etc. And in many cases, like while distributing some food items in public places. I don't know whether it is there in Rajasthan or not, but in many other states, including in my state, I'm from Assam, we have the same kind of concept, one we call gamsa. Okay, that gamosa we use to cover my head, to cover my face, then nose, all these things. And that is a basic hygiene, and that is nothing new. That is to be taught by corona or pandemic situation. That has been in use for 600, 700 years old culture in our society. So is in Rajasthan and so is in some other societies. Okay. But what we have done today, and then it came to the doctors, as you know, like most of the physicians and surgeons, they used to cover nose and like mouth with mask. That is a different mask, that is a surgical mask. So there is nothing new in this mask. Okay, it is there in use. But today, what we get in market, you will get like several hundreds of different models of masks with different specification, different like shape, different design, different like cloths, different material, and so on. So this is where probably this innovation is there. So people have like those concepts of gamosa or pagdi material, etc. So now they are bringing it in a more handy, more compact, more kind of good looking by today's standard. Okay, and more you can say gender neutral form. Okay, nowadays masks are like being worn by. Okay, so these are kind of innovation as required by the society or as required by the situation at different point of time. Okay, and how when we call it as innovation. So here is a very like you can say very good statement given by the co-founder of Champions of Design. Champions of Design is a very big firm, design firm. So Bobby Martin Jr. So he is like one of the founders of this firm. You can check in your like browser. This Champions of Design is a very big firm. So he says innovation comes from pushing beyond the expected. We have expectations, some expectations, and all these things. And if you are just giving the same thing what people expect, and then it is nothing new and nothing innovative. So it is okay, it is another form. But if you go beyond, okay, beyond people expected, so then it is innovation. That is what he said. He says, innovative design is thoughtful, appropriate, and ambitious. Appropriate, that is what just now I was talking about, appropriate. So it is appropriate even if like if I put it here and I can keep on speaking, I can like, okay, I need not to probably take care of the big clot, etc. So it is appropriate for the situation. It is appropriate. Now the material. So it should be appropriate for different like conditions, weather conditions. In fact, last few days I was having some rashes, etc. In my faces, in my face. That is because of some improper material of the like mask probably I was using, and so that was not appropriate, at least for persons like me. Okay, so therefore it should be appropriate also, and the kind of whether you are sitting there in like probably in Rajasthan, or I am sitting like right now I am sitting in Uttarakhand. The kind of weather in Assam now, kind of weather in Maharashtra, very, very different. So therefore, we need a different material, different kind of like product for suiting, okay, different environment, so that it is, we can say it is appropriate in this environment, okay. So innovative design is risky, not everyone can be an innovator. They're risky in the sense that whenever we innovate something, it is basically for the people in the society so that they can use it and they can get benefited by this. But each and every innovation comes with some sort of cost. Okay. And these are whatever I am talking about, say this is a very low cost product. Okay. Low cost product. If I am talking about a pen, probably it is a low cost product. But the moment I talk about a product like this, so this is no longer a low cost product. And this is like no longer a kind of unique product in the market. Like this, there are like maybe hundreds of models available. Now, the moment you go for a new innovation, you have to come up with that is beyond expected. So like it is said here, then only you can expect that, yes, probably my product will be liked by the people, will be more useful to the people, and they will go to purchase it or buying this product. Okay, so therefore, if I invest a lot of money, then from business point of view, innovation is just like fine for my like hobby or as a passion. I can go on inventing new products. Okay, I can go on adding a few things to my kitty. But as far as business is concerned, as far as commercialization is concerned, so it is sometimes risky. Okay, so therefore one must be very, very careful. One must be very thorough with what we want, what the society want, what people or the like buyers want, okay, or the customers want. Now coming to product, so that is about innovation. Now product, which kind of product, or how to go about the innovation of this product. So what is a product basically? So all of us, we talk about product, but what is the definition of product? How do we talk about like product? Obviously, the laptop I am using is a product. Obviously, this is a product. Obviously, the light pen I am using here is a product. But how do we define them? So basically, products are like divided into two classes, if we see. So one is tangible, the other one is intangible. So tangible products are whatever I have shown you like here. So all these are tangible products. All these are tangible products. Okay. But there are some products which are intangible. What is that intangible product? How are you getting my like image on your screen? How are you getting my voice in your speaker, like in your laptop? So you have one device there, I have one device here, but who is making it possible to display my image on your screen? Who is responsible for like playing my voice in your like laptop or in your room or with wherever you are. What is that? Is it just like that? I'm speaking here, you are you're here, there. It's not possible. Okay. So we are taking help of some technology. What is that technology and what the technology is using? So there are multiple technologies involved in this, in which imaging is there. One thing, image, like taking my image here, okay, then image, converting this image into digital signal, then signal processing, then sending it to your system, and again reconstructing that image so that I appear like me only. Okay, so it should not appear like some dots, something like that. Okay, it should appear like exactly how I am, or exactly the same features that I am having, or the way I am behaving here. So it is not a very simple technology. There are a number of technologies are there. Now who is making it like possible? Who is making it possible? How these technologies are being coordinated and being made useful to do this? So for that also, there is a product, or there are multiple products. There are multiple products, okay, which is responsible for bringing these to you. So that is what probably, yes, all of us are using Webex platform. So Webex platform, so it is one tool, video conferencing tool, and we cannot see it. We don't see it. We have never seen what is Webex, but it is working. It is working so nicely that whatever I am speaking, the way I am appearing here, it is like bringing it to your screen, to your device, exactly the same way. So it's a product, but we cannot see it, we cannot touch it, okay? But we are using it. So that's a kind of, these are some of the like products which are intangible. We cannot touch, we cannot see, we cannot feel, but it is working, okay? So no physical existence, but they are working, okay? They are working. Similarly, some products like home loan, life insurance. So they say nowadays we have new product, we have hundreds of new products and so on. I'm in a, good morning. I'm in a meeting, so I'll come in the afternoon. Okay. Sorry. So these are also products. Okay, home loan. So these, we cannot see home loan. What is? We cannot see anything. We can see the checklist, or we can, nowadays that checklist concept is also almost disappearing. So everything through, what is that? Through only click, and somebody is getting money, somebody's amount, somebody's account is getting debited, somebody's account is getting credited. Okay, so we cannot see anything, but it is happening. My money is going to like somebody else, somebody's money is coming to me, or whatsoever. Okay, so these are some of the products. Now how to develop such a product? Is it same for what we do with like tangible product and what we do with intangible product? Okay, basically if we talk about development, product development, basically the stages do fit in for both tangible and intangible products. But with variation in product, there will be slight variations or slight adjustments required, okay, for or in the development process. But basically, ideally, conceptually, the process or the stages are same. Okay, so that's why I'm just at the beginning itself, I'm trying to give you a kind of like link how innovation and product and the development stages are linked, or they do have relationship. So we need innovative product, and that innovative product, okay, so we need innovative product, and that innovative product may be tangible as well as intangible. Now, how do we go about this and when to like develop a product? Say, for example, like iPhone. Now in the market, my phone is quite old. So this is iPhone 7. Probably no one amongst you will be using this iPhone 7. Nowadays in the market, it is iPhone 12 is there. Okay. Now, whether there should be one iPhone 13, iPhone 15 or whatever, iPhone 14. And if it is to be there, okay, if it is to be there, so when it should be, when and what? So it will be simply another version of having a higher version of iOS or something like that. Or what will be that 13, okay, iPhone 13 product? In what way? When that is to be launched, okay? What will be their features? Or how to design the new features? Based on what? Somebody has some crazy ideas and he will go and innovate. That is fine. That may be a new or something new. But whether it will work in the market or not, okay, whether that innovation will be commercially viable or not, so that is risky. That is what Bobby Martin was talking about. Okay, Bobby Martin was talking about. It is risky. So the moment like iPhone people or that Apple people, okay, they go for their new product, okay, say 13, 14 or whatsoever, they will not take that risk. They will go with lot of analysis. They will go with lot of scientific like exercises, okay, so that their product becomes commercially also viable or commercially success. Because in the same range, already iPhone 12 is there. So people will not migrate from 12 to 13 until and unless they find that, yes, really iPhone 13 is really very good and I must go for it. Or otherwise, those who are using other smartphones, says Samsung for that matter, or some other high-end phones, so they will never get attracted towards iPhone 13 until and unless you provide some very challenging and very new, very innovative features in that product. So for that, you will have to have lot of like work behind the screen. So in the drawing board, you have to do lot of analysis, lot of work before bringing in that product to the market. So this is what probably we are going to see how different this is, although it is not possible to cover entire things. So probably Dr. Rahul will excuse me for not able to cover the entire things, entire range, okay? But I will try to like discuss few things, okay, within the given time. So how does this do come? So generally, product development like stages, it comes with three distinct like stages. Starts with introduction, then product grows for like it grows, okay. Then it comes to maturity. Then it again that product, like I'm talking about, say iPhone 12, iPhone 7. Now, if you see iPhone 7, so it is almost, it is decline means almost it is getting like withdrawn or eliminated from the market. Although I'm an old person, I'm using old product. That's okay. So like this, so like this product is now getting almost like withdrawn from the market. Okay, so every product, each and every product, but it was not so when it was introduced few years back. So it was introduced on in the market with lot of fanfare, probably like iPhone 12 or iPhone 10 was introduced in the market. So the company made lot of like advertisement, lot of uh, regarding the product. They did a lot of publicity in social media, website, this, that, or by different ways. Okay, so they introduced that product. But if you talk about iPhone 10 even, so it is probably in the decline phase. But before that, so at one point of time, it was growing. The market of iPhone 10 was growing like anything. So probably what is happening like iPhone 12 today. So it is going, like growing. That market is growing. But at one point of time, the market will mature. Okay. So this we can see with the help of this diagram. During like introduction period, so we cannot like think of many cells. Okay, so probably profit and okay, competition is out of okay context. We are not making any profit, but we have to introduce a new product. Otherwise there will be big problem. So iPhone 7 was introduced, iPhone 10 was introduced. So like that, say Maruti. If you talk about Maruti 800, one day Maruti 800 was introduced, okay, with zero sales or zero profit. But slowly, if you see, so the product grew like anything. Okay, the growth, it was growing like anything. Similarly, that iPhone, different models, or for each and every product, this curve is, you can say, is a you can say generalized curve. Each product will go through these phases: introduction, growth, maturity, and decline. At one point of time, like that Maruti 800 model, if you remember, many of you maybe won't be remembering that. But in our time, Maruti 800 was like, it was a big hit in the market after that Ambassador. So it was like the market was flooded with that. And after that, it came to a stage that probably it has come to a maturity and no more addition can be done in that. So probably they added many features later on. They changed slightly shape, they changed slightly different features. Okay, they added this system, music systems, they added air conditioner, they added multiple other features, so many things. Okay, but then slowly it's what is that? Sales started decreasing. Okay, so it came to maturity at one point of time. After that, it started decreasing. And then what they did, they brought in some new product. Okay, so what is that new product? So probably they brought in, say, Alto, they brought in Swift, they brought in other, they brought in Desire, they brought in so many other models, so like that. Okay, so that means what? Each and every product will go through introduction, growth, maturity, and then finally it declines. Now, if they do not work on bringing or introducing a new product with zero, say for example Alto, if they do not bring in Alto, then at one point of time when 800, say M800, so it's like sales will be zero, how the company will survive? Or if its sales comes down below a threshold level, as you know, there will be always a kind of like sales and cost. So there is a kind of like threshold beyond which only you will the company will have profit only after crossing certain total cost or total revenue earned. So total revenue must offset the total cost. Okay, then only there will be a profit, as we know. Okay, so now if the sales is coming down, total revenue earned will come down, and therefore the profit will ultimately it will go to negative. Okay, profit will go to negative. So therefore, before it goes to negative, so companies, they do like introduce some more products at different stages, okay, at different stages. Now say I12 is at the peak, say for example, then the company must be already working on its next version, so that before this iPhone 13 or 12 comes to a kind of declining stage, so they can introduce one more one more product into the market. So this is very, very important. And at the same time, just only like for the time being, they will let us bring something, it will also not work for the reasons I have already told. Okay. And until and unless people find that there are new features, there are new innovations, there are new some advantages or cost advantages, people will not leave their existing product. Okay. Say, for example, somebody is having Desire car or whatever, Honda City car, they will not move to another car until and unless they find that, yes, this new car is better than what I am having on these aspects. So I must go for that. Okay. So the important thing is that each and every product will go through this stages of development, that is product life cycle stages. Okay. And the products are being developed according to this. When, so this time, okay, this timeline, and there is nothing like there is a fixed numerical value I can give to it. Say this is 1 year, or this is say 2 years, this is 5 years. Nothing like that. Nothing like that. This for some product it may be 1 year, 2 year, 5 years, in years. Okay, in years. For some products it may be even in months. Okay, even in months. For some products, say different cloth designs, etc. So it will also some like designs, etc. Their life is very, very short. So probably one season only it will okay, it will be there in the market, and after it will disappear. Like say woolen cloths and all these things, etc. Okay, so one season it will be there and then it will disappear. Okay, but some products, like say I have given example of this like Maruti 800. It was there in the market for several decades, and then only the company has totally withdrawn that car from the market. So therefore, so this if you ask me what is this time, what is this timeline, what is the numerical value for this, so my answer is it is not fixed. Okay, it will vary from product to product, it will vary from sector to sector, and even within the product, if you talk about say Maruti, so today they have number of different products. Now recently they have one XE product. Okay, they have Desire, they have like say Alto still running, they have other, what is that, so many other, Swift is there. Okay, they have Swift car is there. So there are Ciaz is there. So for even for different models within the same company, these like stages will be, or this timeline will be different. Okay. So I think with this, let's move to next. And why we have to do that? So there is a kind of and this, why I'm bringing this here. So there is a kind of like relationship with manufacturing also. So every stage, the introductory stage, will have different manufacturing facilities or different manufacturing like philosophies involved with this. Say growth stage, there will be different approaches for manufacturing. Maturity stage, there will be different requirements, manufacturing requirements, or they use different manufacturing facilities, different manufacturing philosophies. And in the decline stage, again, it is different. Let's see it very precisely. So here, as I said, so this is like something like 0, very low, very less number of. So immediately, even if they go for like a new product, okay. Now say these are almost like a very stable product, like iPhones. I'm talking about not variants, but I'm talking about iPhone. So iPhone is a very well respected, well like stabilized product in the market. Similarly, Samsung smartphones, they are stable products. They may have different variations, different models. I'm not talking about that, but otherwise they are very stable product now. But if they at all go for a new product, something new, very new, which was not existing, okay, then the introduction is different. For these products, which are very stable in the market, people have already faith in these products. So whenever Apple brings out that say new Apple, say i13, iPhone 13, etc., people already know that they cannot bring a kind of say inferior product what they are already enjoying. That is already proven, right? So if the Apple comes up with the next iPhone model, so probably they will come up with a huge number. They will not start with 0. They will bring with huge number, but then the curve, the nature of the curve will remain same. The profile will remain same, but only thing is that number. So here probably they will come up with 1 million or whatever, okay, 0.1 million or whatever. And in some products, when they started their first product, first iPhone, probably they started with maybe only 100. So 0 means it is indicative that it is a very small number. Okay, don't consider it 0 as 0, but 0 as say 100 or something like that. Similarly for a car also, when say Mercedes, so like S series and all these things, so they are very stabilized product. So now whenever they bring in the next version in that series, so they need not to start with only 10 cars or 100 cars. They can bring it in thousands because it is already proven. But when they start a new team, okay, so that number will be very, very small. And that is something like that manufacturing philosophy is process focused philosophy or jobs of kind of philosophy. So let us like make one first. Let us make 2 or something like that. Okay. So that manufacturing philosophy involved here, the facility will be very limited facility. 1 machine, 2 machines, and they will try to make 1 or 2 or 10 products. Let us see how it works, how people like it. Okay. So they do not invest a lot of money in that. They do not invest a lot of money in that. Okay. Then when they feel that, oh, people have started liking this, demand is increasing, so sale is increasing, then they go for, okay, making in batches. Let us increase our production facility, production capacity. So now you can probably appreciate that how that production philosophy is, okay, manufacturing philosophy is closely related to like different stages. At growth stages, so they will go for like process focused philosophy. Okay, so they will start manufacturing in batches. Now say 1,000, let us make a batch of 1,000. Let's make another batch of say 2,000. So like that, still they are not going for mass production until and unless they find that yes, their product is doing very good. It is like now the demand is increasing at a very faster rate. So they won't go for mass production. And the moment they say that yes, the growth rate is like the slope is too high. The slope is too high now. Okay. So growth rate is too high. So therefore, so they will go for what is that? So mass production. Okay. They will standardize the product and they will go for mass production or continuous production. So this is nothing but mass production. Okay. Like assembly line and all this, they will go for setting up of assembly lines they will put multiple machines, assembly line, and they will go for mass producing the product. So before that, they will go for say 1,000 batches, then probably okay, bigger batches, say 5,000 batches or 10,000 batches, something like that, as the curve is like, or the slope is increasing. And when they find that yes, now the product is like very highly acceptable in the market, everybody is is like asking this, or it has become popular, so they go for mass production of the system. So manufacturing philosophy is closely related to how the product, or at which stage the product is, at which stage the product is. Is it in the introductory stage, growth stage, or maturity stage? In the maturity stage, they go for standardize the product. They will standardize the product, and they will go for continuous production by using, say, generally, this is the assembly line. As you know, most of you might be knowing, assembly line is one technique that is being used in most of the mass production facilities. Okay, and that is how like different stages are like correlated with manufacturing philosophies and facilities. So if you talk about here, so at this stage, the kind of facilities that will be needed, so that will be different. So here it will be different, here it will be different, and here it will be different. So the investment that will be needed will be different. So now if the company invest here, so they will love to invest in at this stage. So they don't have a risk now. That if you remember first slide, we were talking about innovation and risk. So that risk they have now crossed while coming to this stage. Maturity stage means the product is matured. Now there is no risk, and they are going for huge investment in the form of different facilities like assembly line, multiple machines, like recruiting like people, more and more people. Then probably they are expanding their units. Earlier there were only one unit. Now they are going for 2-3 units at 2-3 different places. Like you know, Tata has got different manufacturing facilities at different places. Okay, so similarly, so they will invest at this stage, and whenever they find that it is now free of risk, there is no more risk involved in this. Okay. Now, how do we go about like developing a product? We want to develop a product, something new. Okay, something new. How to go about? And whenever I'm talking about a product, please remember I'm referring to both tangible as well as intangible. It is mostly applicable to most of the things, most of the discussion are applicable to both tangible as well as intangible products. Right? So now there is one approach called design thinking approach, which is nowadays very like a very popular approach. Design thinking approach. So how to go for developing a new product? First thing is empathize. What is empathize? So we should know what is required. Now, for example, like almost online teaching, learning is going on everywhere. The school kids, the kind of laptop I need and the kind of laptop it is required for like second standard, third standard students, or that primary level students, is it same? Will it be same? Are the needs same, similar? What kind of product they want? Okay, so their like keyboards be as small as fine as the ones I'm having or I'm using. Okay, what kind of, so will that screen be this small like I'm using? will the voice be similar? Okay, or many other things. Okay, many other things. So that we must know. Similarly, if it is this facility is being given to like very elderly, illiterate person for their, say, as you know, like adult literacy program, we have adult literacy program. So if we ask one adult person to use my laptop, probably he or she will fumble and he or she will probably feel it little, or they will hesitate it. Okay. So for them, what kind of system is required? What type of a system they will love to have? So to know that, okay, so we need to empathize with them. We need to talk to them. We need to observe them. We need to we need to understand their requirements. So that is where that is very, very vital. Very, very vital. Okay. So what do they need? What do they need? Okay. Why they need that way? Okay. What will make them what are the features will make that product attractive to that particular like age group people? Like the way the primary school children will get attracted, it will be certainly different for the aged people, adult people. Okay, they will get attracted by different features, some other features. Okay, so these are the kind of like things which one has to like know at this stage, empathize stage. Then once we get those data, once we have some idea, yes, they need this. Okay, so similarly for that matter, that phone also, the kind of phone you will be giving to a school-going kid and the kind of phone probably you will be using and your parents will be using, they do not need all these three people. Okay, in a single family, there are three different people as far as the age group is concerned. Okay, three different age group people, and all their needs are different. They think in a different way, they enjoy different things, their needs are different, they interact in a different way, and so on. So therefore, after knowing this, so we need to define, oh, product should be like this. Okay, product should be, it should have this type of features. Okay, it should have like keyboards like this. The keyboards will probably be your local vernacular. Okay, keys should be probably bigger, and probably in that keyboard, probably we don't want lot of like kind of complicated characters, etc. Complicated features we don't want. It is only for basic learning, so only basic numerics and basic numerals and basic alphabets and all these things will do. So that is the definition stage. I needed this type of product. I need this type of product. First, we should be clear about that product, what type of product I'm going to develop. Say, for example, it is applicable to everything, like the video conferencing tool, WebEx. Okay, if somebody is like now targeting another platform, okay, suiting to say for example one platform, say meeting platform or video conferencing platform or interacting platform for say visually challenged people, or like those who are having challenges in hearing or talking. Okay, what we call as like hearing impaired or whatever. Okay, differently able people, and in differently able also there are different cases. Okay, say I'm talking about differently able people as far as the hearing is concerned or as far as speaking is concerned. Now their requirements are different. So for them we have to define the problem in a different way. For me, it has to be defined in a different way. So Once this definition is ready, then we go for ideating the product. Okay, now let's think about how the product will be. Okay, this can have this should be this big, this should have this type of lever, this should have this type of keys, this should have this type of features, like I will be speaking only and it will, the machine will learn everything. Or I will have some gestures. Okay, I will show like this, and it will automatically start interacting. Gesture features are there. So this is like probably that ideating. What will be the color? This color, so whether this color will be appealing to the kids, this color will be appealing to the adult people, this color will be appealing to me, and so on. So that is the ideating phase. So product development, now the designer is ideating how it should be, okay. Then now he has, now you can say, his idea in his brain. He has to like transfer it into some sort of like say design, some sort of like written files and so on. He has done it. Now you should see like whether that works or not also. Many a times, whatever you think, whatever you like design, it may not work. Design in the sense I'm talking about like conceptual design. You are conceptually, you think that it should be like this, but whether it will work or not, you have to see. Okay, or how it will look like, how the color is, whether the color is appealing or not. That you have to see. You have to make it now. So here at this stage, so you are making a product physical. And see, yes, oh, this looks like that. Oh, this will be this big. Oh, this is like that. And then you have to test it. Like, I wanted to have this way. So these features are working or not. So features wise. So whether it is working or not. So these, this is the testing phase. Whatever I have like defined or ideated, so those are, now I can see. So in the prototype level, I can see that yes, it is happening, that this is this big, this that kind of thing. Now, as far as the working is concerned, so probably now I am testing it in this way. This is, you can say, starting with this. Okay, with this, so these are, you can say, very standard like phases of product development as far as like design thinking approach is concerned. So this is called design thinking approach. And you can say this is the very basic thing which is required for each and every new product development. Okay, each and every, so all product designers, whenever they want to design something, they go to that place where it will be used. They mix with those people who will be using it. They interact with those people who will be using it. Okay, and they will interact with the manufacturers also, whether they will be able to like produce the prototype or not. So thinking something in the air, sometimes it may not materialize as far as the manufacturing like constraints are concerned. So therefore, so design and manufacturing, it cannot be treated like in a separate context. So design must accompany the manufacturing features as well, or manufacturing capability as well, particularly when we are talking about commercialization of a product, okay, or a product that will be made available in the society for use of the people. So that is what almost every innovation is meant for. I hope this is, then now we go to different. So this is the basic like approach. Okay, so this approach is, as I said, so this is a kind of universal approach, and people like interpret in this process, this entire these 5 basic elements in different way, so that suits their own enterprise or own manufacturing concern, own design form or whatsoever. But basically these are the things, and now they will try to see it or subdivide it into many other phases. You will find in different books, different research papers, you will find that there are different stages are there, multiple stages. Some people will say 5 stages, some will say 7 stages, some will say 8 stages, some say 10 stages. So all those things are there, nothing to worry. Okay, don't get confused by which book to follow, which is correct. Okay, IIT professor says this, this book says this, MIT professor says this, whom to believe. Okay, please don't get confused by these different versions. Therefore, it is very important to understand the concept. Okay, and once you understand, if you know these 5 phases, emphasize, define, ideate, prototype, and then test. Okay, then you will be able to map whatever be the number of phases they are giving, 7 stages, 8 stages, 10 stages, and all these things. So you will be able to find it. Yes, this is nothing but it is part of definition only. Oh, this is nothing but part of developing prototype only. Okay, or it is nothing but a part of test only. So all these stages, so 8 stages, 10 stages, and all these things, so please do not get confused. Only try to get the basic idea, basic concept, okay, on which this is product development is taking place. Now, for example, I am putting here one scheme, different process, development process. So here a number of stages are there. Okay, maybe 7 stages are there or something like that. Some books, somewhere you will find 8 stages. Okay, so that doesn't matter. But it all starts with, see, I'm giving the first stage is what? Requirement, definition, or need analysis. So now if you see this stage, and if you see here, so probably I'm having these 2 things there in the same box. Okay, so requirement, how do I know what is the requirement? So I am going with that emphasizing. I need to talk to the people, what kind of things you want. Okay, I need to talk to the battlefield people, say army people, what kind of you can say armory they want, or what kind of clothes they want. Okay, so they will have to survive in what is that, say minus 40 degree, minus 30 degree Celsius. So what kind of clothes they want. Some people are working in plus 40 degree also. So what kind of outfit they want. At the same time, they want bulletproof also. So what is the requirement of bulletproof? Which one they want to, which portion they want to protect in the body? Which one is vital? Okay, that I must know. There is no point probably by protecting our hands with bulletproof and all these things. My fingers, okay, bulletproof things. My legs, fine. All parts are equally important. I'm not saying they are not important. I'm not saying my hand is not important as far as war is concerned. Okay, or battlefield is concerned. Without hand, I cannot operate my say machine gun or whatsoever, gun or whatever artilleries and all these things. That is important. But if I lose my one of my fingers, 2 of my fingers, still probably I will survive. But if I get 1 bullet in my heart, so probably I have only a few seconds left. Okay, so that is where the difference is. So this bulletproof, if I'm creating a bulletproof you can say outfit for fingers for this. So it will not come just like that. It will have weight attached to it. It will put constraints in operating my fingers, in using my fingers. Now, how freely I am using it, or how freely I am moving it. Okay, how freely I am moving my hands. That kind of things. With a bulletproof like outfit all along my hands, my fingers, these things, will I be able to do that? So probably not. Probably not. My legs, for that matter. Okay, even if I get a kind of bullet wound, bullet injury in one of my legs, probably I will survive. Okay, but not here. Not here. It is only maybe few seconds, matter of few seconds. So this I should know. I should know. And okay, I'm making a bulletproof jacket. Fine, very good. No bullet can pierce into that jacket. But what is the weight of that jacket? Weight is 100 kg. Will any work, what is that? Soldier be able to wear that 100 kgs? If his outfit itself weighs 100 kgs, he has to carry gun also. He has to carry his some sort of like eatables also. He has to carry communication equipment also. He has to carry spare like bullets or detonator or whatever, all those things also. Is it possible? Not possible. So that means, so what is the necessity? What is the requirement? What is the requirement? So that I must know for any product development. So I must go and empathize with the people for whom I am developing it. So is the case with this. If I am going for developing iPhone 13 or iPhone 15, so I must need to know what are the next level of features people are looking for. What kind of is it that weight of this is a deterrent? Is it that big screen is a deterrent? As you know, maybe some 4 or 5 years back, or maybe 5-6 years back, there was a trend of how big the screen can be at one point of time. Okay, big screen means it is a kind of prestigious or some kind of, okay, I have a different profile. But if you see last 2-3 years, almost all companies, they are bringing down the screen size. So they went to bigger screen, and now they are again bringing down to coming down to some smaller screens. So that is by this need analysis or that requirement analysis. Probably whatever I want to see, I can see on this screen also 6-inch. Mine is, I think, 5.5 inch. 5.5 inch. Okay, I can see here itself. Why I need a bigger screen? For bigger screen, I have this laptop. Okay, and bigger screen means I cannot keep it on my pocket. Now you can see I'm very comfortable in keeping in my pocket. I'm very comfortable to keep it in my pant pocket or whatsoever. Okay, so these are some of the things like why we need to analyze what one needs for developing a product. So accordingly, they will define. So they will come for conceptual design. So this conceptual design is nothing but that ideate. Okay, ideate stage. So here, as we have seen, okay, so empathize and define, that I have combined in one this thing, and ideating. So this is where we are going for conceptual design. I'm ideating it. Yes, this should be like this. This should be color should be like this, or whatsoever. The feature should be like this. There should be one handle like this. Say I'm going for developing a new specs like a frame. How it should be, whether there should be some design here, okay, whether there should be some other say my speaker, I can put say whatever that mic, my mic I can put here itself. Okay, can we? My whatever that speaker I can put here itself, fix here itself. Okay, instead of having one new kind of feature, so I can like have a provision so that I can put a button like speaker here itself. So I will only. Okay, so these are different kind of like stages. So that is called conceptual design. Then comes detailed design. So detail, as I said, like I have conceptually I have developed it, but now I have to convert it into some kind of dimension. What will be the dimension of this? Like if this is okay, so I want to bring that big screen into smaller screen. Okay, down, bring it down. But how small it is, or how small it should be. So that I have to come up with detailed design. Say I'm not going to make it more than 5 inches or more than 5.5 inches. So that detailed design. I want very good camera, but what camera? Which type of camera? How many cameras should be there? What will be the pixel level? Okay, where all these cameras will be fixed. Okay, in this corner or this corner. Okay, as you can see, it can be in this corner or this corner. Which corner will be more convenient? Okay, or could it be in the middle? So all these takes detailed design. What will be the size of the camera? Okay, all these detailed design should be like now documented. Should be drawing should be ready, and the kind of thing. Okay, then you prototype. So in between probably that one this is there. Okay, say detailed design. So design is also tested and evaluated nowadays. So earlier that kind of things were mostly not there. So now it is available. So earlier what they used to do is they used to have like a sorry. Anyway. Oh, it's hanging something. Okay. I don't know. I don't know what is the problem now. Something happened.
Sir, please press Shift F5.
No, I'm trying, but I don't know what is happening. Yes, now it is coming. Can you see? It is full screen is coming.
Yeah, now it's okay.
Okay. It got hanged. Something happened. Okay. So this is an evaluation. So here nowadays it is. Earlier also people used to do with some kind of like what is that scaled down model? Scaled down model. So if they are to like manufacture a big things, a big card, etc. So they will make a small card. Then they will try to see how does it look like, where the different features will be fitted, and so on. Say a building, they will try to have a scale down model, etc. So nowadays, the advantage is we have, for all these things, we have softwares available, tools available. Okay, so we have what is called simulations simulation tools available. Different like simulation softwares are there, so you can test. So how the output will be, how it look like, how will you can even see different color schemes. You can see different like dimensions. You can see different say level of like speed also. Car you are testing, you can see at different speed how the things will be, at different temperature, at different speed how the engine temperature will be. Okay, at different speed how the like say fuel consumption will be. So all these things you can nowadays test at like you can say in the laboratory level itself, or with the help of simulation tools, or with the help of software itself. Similarly, this is applicable for even for software developments also, software product also. So WebEx, whenever it was produced, so it would have been tested multiple times, okay, with various like kind of applications, various kind of like situations at that stage itself. Okay, then go for manufacturing, or you can say like in between you can say prototype development. Okay, and here it is like you can say the manufacturing involves prototype development as well, like we have seen in the previous slide. Okay, so prototyping. So prototyping will be done just prior to going for manufacturing, or you can say it is nothing but manufacturing only. Only manufacturing here, what I'm trying to say is manufacturing at like a commercial level or at a business level. Okay, so this is also prototyping is also manufacturing, but only you will prototyping means you will make only 10, you will make only 5, so that I can have further test at actual level. Okay, actual level with actual size, with actual like dimensions, with actual colors. I'll see and I'll test, and if it is fine, then I will send it for manufacturing for at a higher scale. Okay, so that is what is the usual process. Then next comes it like once I have like manufactured the product, so it will go to what is the market. So for market, what we have to do, so this is also earlier, like if you go through the classical product development like books or classical design books, etc., you will not find this phase here. You will not find this phase. But nowadays, this is considered as part of product development itself. You have developed, but it is lying in your godown or in your storage area. So nobody will know, nobody will come to know, or nobody will be able to like see it. Nobody will be able to get attracted by its features and so on. Earlier, there was a case kind of things like if you are sitting in some like okay, somewhere in say some other districts, probably you will go to Jaipur and get a car delivered. So I'm sitting in Roorkee. I used to go to Delhi or Chandigarh to get my car delivered. Okay, many of my colleagues, they did this. But nowadays, what is that? You just order in probably through your laptop. The boy will come with the car and they will deliver it at your home. Okay, so now that part is taken care of by this logistics. That means your product, until and unless it has come to you, it is with you or in your hand. It is not the product. It is something. You are talking about something. Yes, product. I have not seen it. I have not used it. Okay. So therefore, so people nowadays, they call or they consider that this logistics or supply chain and environment. So this is also part of product development process only. You develop the product, you have tested, you have found everything correct, but you are not making it available to the users for whom this has been developed. So without that, product will not be used by the customers or okay, customers or the consumers, and your product is useless. But at the same time, one more thing, that's what we can say, is a test and simulation, as you can see. So nowadays, one more activity that is being very actively taken up is commercialization. So for that commercialization, so test phase itself, people start working in that commercialization. They find that the product is now working good. Okay, so the product has like passed all the tests. Okay, all the tests, but the manufacturing will take another, say, 4 months, 5 months, 6 months, or something like that. So after this manufacturing phase may take some more time. So without wasting time, what people will do, they will start commercialization. Commercialization is, you can say, it is not simply like you can say advertising or so. There are other things available. Like other things means you have to go for protecting your right. So that is called IPR, etc. So you have to have IPR if it is a new product, new innovation. Okay, then that IPR is to be registered, and then you have to keep your like market ready. So by the time your product is getting manufactured, probably you can make a lot of like publicities, advertisements, so start getting booking, etc., and all these things you can start. So that is like part of like commercialization. Okay, so now you have got if it is not your in-house developed product, then you are getting the licenses, or you are giving licenses to other people. Say you have developed a product, but you don't have production facility. What you will do? You don't want your product to get like wasted in your laboratory or in your a computer itself. You sell it. You give it to Tata. You give it to Hyundai. You give it to, like, I'm talking about car manufacturers or automobile manufacturers, but it is applicable to anybody for that matter. You have a software concept. You have developed the software. You have developed the full package, but you don't have money to make it in a like big way. So you sell it to Microsoft. You sell it to Adobe. You sell it to Cisco, who is providing this, say, like Webex, like that. So that is called commercialization part. And that without commercialization, it is very difficult that it will come to the hands of the intended users for whom I have like developed that product. So that is where that commercialization is required. Okay, and then it will go to the supply chain, or it will go to the market. So now if you see, like here in this entire like phases, so here 6 phases I am discussing here. So these 6 phases are nothing different from that of whatever I have used in that whatever here in these 5 phases. Okay, so it is only like kind of extension, kind of like clubbing the functions or so, but going ahead with the same phases. Okay, fine. So how many more minutes are there? Probably, Dr. Rahul, another 15 minutes.
Yeah, we can continue for 15 minutes more. No problem.
I can continue for 2 more hours. But
we would
okay,
be
I have to
happiest person,
honor.
sir. It's so interesting. I am not able to leave for a minute.
Oh, okay. Okay, people are liking it.
Yeah.
You're right.
Even sir, I want to ask
Yes,
few
sir.
questions, and
It's an excellent session.
it will take more than 20 minutes, I think.
More than 20 minutes?
Yes, sir. 4 questions I want to ask, and I think that will take more than 20 minutes time.
So maybe
It's
maybe
very
I'll
interesting
speak for
presentation,
another
sir.
10 minutes or so. After that, we will have some interaction. Is that okay?
Yes,
Yeah.
sir. Yes, sir. It's very interesting presentation, sir.
Okay. Okay, let's see. Then since we are talking about the product development, so how the trends affecting this product development? One is rate of innovation. Another is what kind of software tools, rapid prototyping tools, virtual reality, all these things are like how it is. See, rate of innovation. Nowadays, every day you will find new ideas, new design, new like innovation. So that's why, like people, if Apple is developing or innovating something new in for their iPhones, Samsung is again jumping into it. So they will try to like develop something. So if Apple has developed 2, they will try to develop 4 new things. So now innovation, so that they can say that our phone has got even 4 more features which Apple they do not have. So that is giving a kind of race or a kind of competition. Okay, and the end result is what? Rate of innovation is increasing. It is increasing at a very fast rate. Okay, so people are all competing with each other, and therefore rate of innovation is increasing, and therefore the product development is getting affected. That means every day we are getting new products in the market. Okay, so is the case with say very recent or the present example is video conferencing tool. I did not hear anything about this video conferencing tool till, to be very honest, 2 years back, or say 3 years back, I knew only Skype. Skype is the video conferencing tool. To be very honest, 3 years back, I knew only Skype. I had a couple of like Skype sessions with, within India or abroad. So I knew only Skype. And today, if you ask me, or if I am asking you, how many video conferencing tools? Oh my God. Okay. WebEx, MS Teams, what is that? Zoom. So many, blah, blah, blah. So rate of innovation is increasing in such everybody is bringing in some new features. You can do recording this way, you can do recording this way, you can do this way also, you can do that way also. So many things they are bringing. And at the end of the day, you are having a very steep curve of as far as the rate of innovation is concerned. Okay. Software tools. Nowadays, there are, as I said, like for simulation, for even manufacturing, for this, there are so many tools. Rapid prototyping. Nowadays, you can make that prototyping very easily at low cost, very less time, very effectively, and within a very short time. Similarly, virtual reality and other tools. So these are coming very handy to the designers, product developers. They can use these technology in such a way that the cost of developing a product is becoming very less, and the flexibility they can use during the design process while ideating, while developing that new detailed design. They can use these tools and they can try with n number of different possibilities, n number of different varieties, and the product becomes very good. Okay. So these are the new trends, and that is affecting the product development. Mass customization and customized on-demand production. So that is another thing nowadays. So people used to dictate the companies. I want my seat height should be like this, or at least adjustable to up to this. My color should be like this. Okay, I want this type of rooftop for my car. So these kind of things. I want the unique key that will be operated only with my fingerprint only. So all those type of things, so many things are coming. Core competency. partnership, outsourcing. So these are the new concepts. These are like coming. Say, I just now a few minutes back I was talking about outsourcing. You may have idea, you may have design, but you may not have like your like manufacturing facility. Then outsource it. Okay, you give it to some other firm who is having that capability. They will produce it. Then the marketing also you can outsource it. Nowadays people are doing that way. Okay, they will on behalf of you, they will market, they will advertise, they will do, they will take the products to different places. Okay, and it will be done. Partnerships, I will talk about partnerships little later also. Core competency, this is another thing. So whenever we talk about like Apple, so one thing or one or two things that immediately come to our mind is iPhone as well as Apple computer or some what is that, tab. So it is, that means this company has core competency in this. Similarly, the moment I talk about Mercedes, so I cannot think about, if I talk about Mercedes, I cannot think about what is that, earbud. I cannot think about pen. The moment I talk about Mercedes or BMW, I cannot think about watch. So they have core competency in one sector, and they are developing new and new products, okay, which their core competencies, and that works well while commercialization, while sending to market, while selling it. Okay. Internet and telecommunication. I'll give one example later on if time permits. Already, I'm afraid of seeing towards the clock. It is moving very fast. Although I told Rahul that I will speak only for 1 hour or 1.5 hours. Now probably I'm feeling the time is less. Anyway, so internet and telecommunication, now the things are moving so fast with e-commerce, flexibility and agility. This is another thing like in the product development stage. So people are looking at it. What is that flexibility? So flexibility means I have that say manufacturing, I have manufacturing facility for say Swift car. In the same platform, whether I can develop Swift Desire also or not. Although they have some differences as far as the features are concerned, as all of you know. If I can, then that is, I have the flexibility. And if tomorrow, if there is a big order comes for say Desire, not for Swift, that other one, older one. Okay. Say some country, other country, you have got a big order, say they need 5,000 units very immediately. Okay. But you don't have that new facility for producing Swift Desire, but you have that Swift facility, Swift manufacturing facility. If it is capable of making Swift Desire also, that means you have the flexibility. And in fact, while designing the product designers will always look for that if they can use that existing facility to a greatest extent. That is very, very important. That reduces a lot of cost and that reduces a lot of lead time. That gives the company flexibility. So because this Swift and the Swift Desire, they can be produced in the same assembly line. So this is the great flexibility, and this 500 units order can be now implemented very like you can say very fast. That is the advantage. And agility means responding to the market. So say now they are going for say electric car. Just shall I call you back? I'm in a laptop. Okay. Yeah, so tomorrow that electric vehicle manufacturing is required. How fast I can move to electric vehicle manufacturing? Suppose suppose Maruti has developed one electric vehicle model. Okay, how fast they can move to that manufacturing, as well as that say servicing network, okay, as well as that their dealership network. So all these things reflect the agility, how fast they can move to the changes, or they can adapt changes. Just battery cell is drying out. Yes, fine. So that is agility. So that is very much required. Then global manufacturing. Another is global manufacturing. What is global manufacturing? So here, this internet, telecommunication, all these things are coming into picture. And global manufacturing, there is a new concept that is coming out. So in which what you are doing is, like, you are developing your market survey somewhere. Maybe you are doing market survey in South America. Okay, you are developing a product for South America, and that you talk about, or you just remember that empathize phase. Okay, empathizing. So now our designers, our people, like, they have gone to South America, that country, maybe Argentina or whatever, Brazil, somewhere. Okay, so they are doing the field surveys, they are trying to talk to people, they are trying to get data from that, what kind of product they need, what their culture, and all these things will get reflected in that. So that is they are doing that. Then where that ideation is taking place, few designers, one designer maybe in India, one designer maybe in Germany, one maybe in Japan, one couple of them maybe in US. So they are doing that. Then they have developed a design. All these things will be facilitated through internet and telecommunication. Then they will develop the prototype probably in US. Okay, the firm is who is taking this job is probably say US firm. Okay, so they have developed that prototype in US. They have tested in US. They have tested in Germany. Okay, they have done it. Now, next phase, if you remember that diagram, whatever I have given. So now it comes to manufacturing. So manufacturing, where to do the manufacturing? Now, if they start manufacturing in US, it is very costly. Their manpower is very costly. Okay, so let it get manufactured in India, or let it get manufactured in Malaysia, Indonesia. This Asian countries, generally manpower is very cheap. Okay, they have developed the facilities in, say, India. Manpower is very cheap, so land is very cheap. Okay, so tax is very less. Very good. Now they have started operating from here, but raw materials. Where do I get the raw material? So raw material is available in Africa. Okay, it will come from Congo. It will come from maybe Ethiopia, maybe from South Africa. So raw materials are available in there only. Bring it from there. So now what is happening is, like, raw material may be from somewhere, manufacturing facility may be somewhere, design will come from somewhere, experts will be from somewhere. Okay, and product that will be developed for a country will be somewhere. So this is giving a kind of situation, or that is called global manufacturing. Okay, that is called global manufacturing. Experts or the resources spread over the globe are being used for developing the product, and that is all these are made possible through computer-aided design, computer-aided manufacturing, internet, and telecommunication system. That is, like, we are we are using extensively in this product development as well as manufacturing phase. Okay. So I think 4 more minutes are there, so I should stop here. Dr. Rahul, is it comfortable?
Yes, sir.
So shall I stop here so that I can interact with the people maybe for 4 or 5 minutes? You have,
Yes.
I think time is up to 45, right? 4 more minutes
Yeah.
are there.
Even we
4
can
more
extend
minutes.
that for some more minutes.
I think
We can extend. But it's a really very excellent session, really very interesting.
So
We can go
I
for
have
question answer.
so many more slides are there, so that if I start talking again, it will take another 1 hour or 1.5 hours. So
That's
probably
why I requested you to have 2 sessions.
I think you were right. But okay, I thought like people should not get bored also.
Yeah.
I don't know like how they will take it. Okay, so fine. So I would like to stop here with this. So if I get some more chance sometimes in future, so probably I will again talk to
Definitely.
you, and we'll have some more talk. Or okay, I'll talk to you. Already you have
Sure.
seen number of calls are coming, so I have some other things also.
I understand, sir.
Yes. Anyway, so thank you so much for giving me this opportunity. I don't know it was helpful for you or not, how the talk was, or how I could communicate to you the intended things or not. Okay, so if
It was excellent.
some people want to like interact, if you have any question, very short question, 1 or 2, probably I'm here.
Yes.
Thank you
The
so much.
participants, please come out with your questions.
It was very informative session. Sir, I want to ask one question. Kindly provide an example of rapid prototyping and how it is different from normal prototyping.
Oh, how it is different from normal prototyping. Nowadays,
sir.
rapid prototyping is like there are machines available as rapid prototyping machines that you might have
Yes, sir.
seen also. That is called 3D printing also.
Yes, sir.
And the thing is, like in normal prototyping, you have say this is my design.
Yes, sir.
Okay, this is somewhere my design is available, or in my computer it is there, or the blueprint is there, what we call as design blueprint, or what we call it as CAD design. Okay,
Yes, sir.
and I will give this design to my manufacturing people there. They will see
Yes, sir.
each and everything, how what is the material, what is the this dimension, that dimension, this parts, that parts, everything they will see, and they will try to manufacture in their machines. Okay, maybe it is CNC machine or ordinary machine or whatsoever. Okay, whatever. I'm not talking about like only CNC. The prototyping will be done. Prototyping may be done by hand also. Okay,
Yes,
so
sir.
anyway. So it will be done, and that process may take little more time. Okay, it takes time. But in rapid prototyping, what we do is whatever my drawing or the design is there, CAD drawing is there, I need not to take it to the paper, hard copy. From
Yes, sir.
from my computer itself, I will connect the machine. That machine is nothing but your this printer, whatever we are this printed page is 2D printing, right? The letters
sir.
are on the XY plane only. And in that machine, so the third dimension will also be developed. That means
sir.
the material will be given in such a way that the whatever the material or the product is, say this is the product. You can
Yes,
see
sir.
probably, I don't know whether it is like visible or not. So this is the product. So this product, if I give the material in that that machine, so the machine will put the material like we do the inkjet printing, like we do the laser printing. So it will build up the material. Say my mouse, I can get it developed or get it printed. That is called printing, 3D printing. Okay, so this is a 3D product. So my printing will be in 3D, and the product will get developed. Okay, and that process is very, very fast generally, than faster than that of physical or the other mode of developing the prototype. So that's how it is coming as rapid prototyping. An advantage is at any moment you can stop it. You can use different, you can test it with different dimension or and so on. Okay. Disadvantage is you cannot use all the materials that is required for printing. Only few materials are basically polymer based materials are used for that rapid prototyping. Okay. Nowadays also, although metal printers are also coming up, they are being used, but very, very limited. Okay. So that is a major drawback. Say this is my water bottle is of say copper. Okay, so to get it rapid prototyped, so that copper printing machine will be required. So that is not very easy. But if I want to get this rapid prototype with say polymer based material, it will be very easy and very fast. Okay, so that is what. Hope I am clear.
Yes, sir. So that the prototyping machines which used CAM processes, computer-aided manufacturing,
Yes,
and
yes,
they will
yes.
implement the rapid prototype. Yes,
Exactly,
sir. And
exactly. So CAD drawing will be converted into some codes. Okay.
Yes,
So
sir.
manufacturing. So with CAM, with the help of CAM software,
Yes,
and
sir.
that codes will be transferred to the machine, and the machine
sir.
will implement those codes in the form of like printing. Okay.
Yes, sir.
So that's why I told like CAM part is very exhaustive part. So there are a lot of things are there. Post processing is needed.
Sir, another question is lots of people have many ideas and they want to commercialize it, and they are even able to make a minimum viable product version. Now, during the commercialization process, there are few documentation problems like Bureau of Indian Standard, compliance, etc. So a normal person just don't know about these things. Where should he go?
So I would request Dr. Rahul to organize one day workshop. So probably I will talk about this. So I used to speak on this for 3-4 hours. Okay, at various places. So there is a normal, there is a very standard procedure. There are okay. One has to do these things. There are offices like at different places. There is a standard procedure is there. Okay.
Yes, sir.
And that is why like many people are hesitating. I don't know anything. Let it be. So something like that they say. But there is a standard procedure. You have to go through a procedure, or at times you may have to take help of like attorneys. Attorneys means the advocates. Okay. Advocates.
Yes,
so they help. And many people come to me also, like here locally, some people, whenever some patenting related things are there, something, sometimes they come, Sarma sir ke paas jao, bas. So they used to come and I used to tell them the procedure, etc. We have in our institute one office is there, dedicated office is there. Okay. IPR cell, intellectual property rights cell. So they used to process all these things. And then for commercialization, you can go to take help of some, you can say professional firms also. You can take help of some legal firms. So as the case may be.
Sir, another question. In the design thinking process, we continuously change the design of our product, physical design or functionality, etc. So when should we start taking care of copyrights and all these things? Because we are sharing all the information with the developers. Okay, so other competitors may use these informations, but we must have copyright of our intellectual property and all these things. So when should we start it? Because it's continuously changing until a minimum viable product.
From today.
Yes. Okay, sir.
From today, you should start. If you are thinking something, so you should get it noted somewhere. Okay. And if you are doing something in your laboratory, etc., then you should get it recorded in one book called called Laboratory Record Book, LRB. Okay, so in that record book, you should mention it with date, whatever you have done today, whatever you have tested today. It doesn't matter whether it is success or failure. Even if it is failure, you record it. Okay,
Yes, sir.
today I did this test, but I did not get this result. Get somebody's signature from your lab or from your, say, maybe head of the department, or maybe your colleague, or maybe your lab instructor, or whatever. Okay, some witness should be there that you have done it.
Yes, sir.
Okay, otherwise nobody knows whether you have copied it somewhere from somewhere or you are the actual inventor. Now, when the actual product will be completely developed, so before sending it for like commercial production, you must register it for copyright or IPR, patenting. Then they may ask, that patent office may ask you, although I have filed 10 patents, 5 granted, they have not asked me so far. Okay, but they may ask, they have the every right to ask, show your evidence when you have done it. Then I have my book, LRB, laboratory book. Okay, in my talk, all those things I'm explaining, like how the laboratory books, how it looks like, what are the things you need to, these things. Okay, so I will show my laboratory. You will show the laboratory book then. See, I got it recorded 2 years back itself. These are the witnesses. Okay, so you're, say, at that time, whatever the photo of that product, unfinished, let it be unfinished, let it be raw material. You have pasted the photos also there. You put your signature with date. So that way, so you will be keeping your records for yourself in future if it is required, so that nobody can question you that you are not the inventor or original innovator.
Yes, sir.
All the best.
Thank
So,
you, sir.
What's
thank
your
you.
name? What's your name? What's your name, please?
My name is Pushpendra Rajpurohit, sir.
Pushpendra Rajpurohit. All the best, Pushpendra.
Thank you, sir.
So I hope any participant remaining want to ask any question. So it was a real nice session. We learned lots many things, product development stages, that design thinking, how empathetic thought process we have to adopt, and how to identify or the requirements of the product. So definitely we would like to have some more sessions in future. And, I believe that you will be available for us. You will be sparing your time. So thank you, sir. Thank you very much. And thanks to participant.
Thank you so much.
Sir.
If you have liked, if the participants have liked the talk or the discussion, I'm very happy. Fine.
You can see that in that chat box also. They are they are actually they were demanding to continue the session, but it may not be a difficult situation for you, but it's a difficult situation for me, because I have to initiate that next session also.
Exactly.
So it was a really great session, excellent session. Thank you very much, sir.
Thank you.
Thanks to participants. And participants will meet after around half an hour at 2:25 again for the third session of the day. Thank you very much, sir.
Thank you.
Thank you, sir.
Good afternoon, sir.
Welcome, Professor Mali, this faculty development program.
Major is this side, sir. Thank you. Hope your first 2 sessions are going good. Have gone good.
Yeah, and these two, this session will also go in a perfect manner. Because the very first thing is for innovation, for product designing, everything we have to have some problems, and we have to deal with problems. We have to interact with problem, and definitely we can have better intelligence level of a person who has come out of different type of problems and different type of work exposures. Generally, we have the person's experts from one particular mode of his work, like in academics or in industry. But we have a different sort of personality here. For participants, I want to tell you that different type of personality who has worked with Indian Air Force for 10 years have a different type of exposures, different type of product development for Indian Air Force. And now for last 14 years in academics at MNIT Jaipur. So definitely, Professor Halal, you have interacted so much time, so many problems and so many different situations, and definitely that's why you are able to file more and more patents than an ordinary professor in MNIT. So your work in research innovation is really very extraordinary, and you have been very kind for other students also. You are providing the counseling information for filing the patent, IPR conferences, what you are conducting at regular interval. So we are having you. Definitely, we are fortunate to have your session, especially 2 sessions we are having. So thank you for being with us, and I request you to start your presentation.
Thank you, Professor Chaudhary. In fact, the pleasure is this side, and in fact, the way Professor Uddhav and you have raised the level, introduced things. Now only I can disappoint you that I might not deserve your praises. But I'll do my level best to interact with your participants, particularly in this afternoon session, day 1 session. So, Dr. Uddhav, if you let's make a kind of interaction. So, since I'm not able to get those chat comments here, I'll request you to read those chats intermittently. Is it okay, sir?
Yes, sir. Yes, sir. Sure.
Yeah. So let's start. I think thank you, ECB, Atal Academy, and everyone, those who made these things possible. For I think 200 odd participants from across India. It's a good initiative, possibly, that we are able to interact so remotely to talk about each other's research areas, to talk about some best practices, because everybody does some best practice, has some best practice in terms of yeah. Is it okay? Am I audible, sir? Screen is there. Oh, thank you. Thank you. So I request participants to mute so that we will have an opportunity to interact during chat session, or if organizers permit, we will request you to unmute and then speak. Okay. So thank you for being in this room, all of you. Let's talk about the the concept of design thinking today. So I'm sure many of you may be knowing, but in case those who are new to design thinking, the way I was some 5-6 years back, it will be my pleasure to introduce those of you with this wonderful concept. We'll talk about, because your course is on product development, product, as well as its prototyping, right? So let us see that how this word called design thinking will be coming here, but it may not be coming here in the starting, but I want you to appreciate in the beginning, what does the product mean, what are the flow of the product, how it is realized. But before realization, I think we need to go for a word called design. So I'm sure many of you are, or all of you are aware of it. Most of you are faculty members, but I want you to take this journey. So we'll take around maybe 30 minutes talking about this word called product and productivity and design and the flow of all those. And in the product development, when the word design comes, designers come, and design thinking comes, right? So we'll take this, and then we'll have some kind of scenarios which are suitable for design thinking, and we'll try to understand design thinking as the academician's word particularly. Then of course we have done some kind of product development. We want to do some kind of case studies today. So one will be there on prime bag, and second will be there on some kind of processes, remanufacturing, and all those. So this is the flow of the content which you are looking forward. Moving next, let us understand what is a product. So I need not to tell you that what is a product, because we see so many things, tangible, intangible. So a product is definitely a man-made product. Other tangible things which are not man-made is like grains which are manufactured in, which are like produced in the farms by the farmer. But otherwise those products, but let me tell you, products need not to be all the time tangible. So what is a product? An article or a substance that is manufactured or refined for sale particularly. So this is what the word meaning of product is. A thing or a person is also a product. Say for example, many of you are in academics and your products are your students. So a thing or a person that is a result of an action or a process is also a product. So these are the two definitions of a product, right? From my point of view, I hope Professor Sharma must have talked to you about all this. He has a nice DIC lab in IIT Roorkee. So when moving next, this is for the sake of completeness, we are just trying to move in. So what do you see these two products? One product is tangible, another product is non-tangible. Both are products. So what do you, can anybody identify? I think no guess to identify this. This is iPhone i12. And then this is what your Google as a product. It's a wonderful product. It has plethora of particular products within this the umbrella of Google, right? Then so when we see other products, it is not only that product has to be commercial, it could be very close to our heart. Since Professor Chaudhary told me that I had a defense background, so one of the wonderful product which whom we can be proud of is BrahMos. So this is also a product, right? And similarly, the product which may not be that, though it's a necessary evil for all of us. Water should be free, it should be easily available. Most countries have the piped water. Anywhere, any water we can go and drink, but unfortunately, the quality of water being supplied by municipality sometimes may not be that good. That's what we have good in MNIT. We are supplied with Bisalpur water. Oh, this packaged water is also a product, right? So I want you to, or let us take this journey of a product. It need not to be all the time tangible, mechanical in nature. It can be electronics integrated, or let's see what are those peculiarities of a product. Okay. So moving next, what is peculiarity of a product? So product can be a tangible product. It can be a non-tangible, intangible product. Okay. You need to see that every time serious international or the intentional efforts are put in. It will not come away nahi aayega. It will has to be you have to put lots of efforts to get this work done. Efforts are required to make this product realized. Okay, then it will only come when you have sustained, continuous, and lots of iterations. Please, iteration means just evolve multiple times, fail, evolve, and then your product will come out. It could be in the form of an item, as I told you, tangible, or it could be services. Okay, then sometimes the product can be the face of the organization. If you have, say, for example, IIT student, so IIT is known by the undergrads who graduate from IIT, or the student who has graduated from ECB, or any other organization. If you get a product, the company name sometimes we forget, and the product reminds us that is the face of it. Okay, so then is, before we talk about a product, the initial seed of the product is the seed part is design, right? So let us understand the word about the seed, and the seed of anything. As I told in the beginning that there are lots of Hindi movies, and when we see those Hindi movies, and sometimes the actor comes and say my designs are approved and I won this thing and that thing. So let us understand the word design. So what is design? Design upon the look and functioning. Say it could be like the initial sketches of a building or a garment or an object, or so that you can have detailed elaboration about that particular product in the beginning. So we all know design is done by designers, and we say there are lots of words for designers. Lots of, I mean, 70% money, 30% money is involved in design, 70% in the realization. On the other hand, 70% cost is committed during design. This is what people say, those who are conventional designers, that if you don't make a good design, you during design itself you have invested so many things, so much of investment has been done. That how the future product will come out like this, and what is the realization will take place. So this is what the design is. So design is a plan or a drawing produced by to look and function and working of a building could be design, a garment, or all those things could be design. I'm sure you are aware of it. Okay. So what you see here is some of the designs which have been shown over here. So some of the wonderful design, you may have various products. Say this is a product. What you see in my hand, a pen is a product. So they are all products. But initially when they are designed with some concept. So that particular concept could be referred as a design. Okay. So now we'll talk about what this freehand sketching and actual design and what those fundamentals mean for us. So when we say aspects of the design, let us go in detail. And there are three terms which are essential for a design. One is the human, all of us for whom the product is made. Second is the form, and third is the function. So now is the time. If you want, you can write in your chat box. If you are a mechanical engineer or electronics engineer, or if you are an engineer itself, are you dealing in human mostly, or dealing in form, or dealing in function? I want an answer. Either human ka you can write H, you can write F for form, or 1 or 2 or 3. So looks up, if you get some answers, you can read those. Udavji, so let's interact. It's the afternoon session. People are sitting at their home. So do I get an answer? Most of the engineers are there. Most of the engineers, I'm saying, are they supposed to deal in human aspect of design, or form aspect of design, or function aspect of design? That's the question. Is it H, F, or M? Is it H, form, or function? Both are F, of course. So we can say function, or form, or human. Any answer, sir? In the chat, or I can see the chat here. All of those, okay, but mostly function aspects. Very nice, Dr. Reddy, you are right on track. So most of the engineers are dealing with the functionality, but what about the form? Who deals with the form mostly? Say you imagine your students who have made a product in a lab. The product will be a kind of crude product with lots of wires hanging here and there. Of course, nobody will buy that. But if you have to get into the market level, it has to be dealt with the form. So form means most of the industrial designers or people from, say, NIT Ahmedabad, let me see some premier institutes, those are the people who deal with the form. So they functionality is covered by most of the people like mechanical engineers, electronics engineers, but form is done by these industrial design people. And so this domain is coming in the intermediate domain is coming as industrial designers. Is the word clear? Function and form. Functionality is one area. So I remember one competition. I was trying to be a jury in Mumbai, where NIT and lots of students were there from engineering institutes. So those people, they designed a nice drone, but when I tried to inquire about the functionality part of it, they said it's dummy from inside. That means they only look for the form, not for the functionality. But when our students make something, it is only the functionality, not much about the forms. So we'll have to deal with both. So that is this domain, interdisciplinary domain, is coming as industrial design. Very similarly, if you have some form, say the form, say the form of the pen or whatever it is, it has to be deal with the humans, the ergonomics and all kind of things. it has to be in the form of a communication design. So this domain comes as communication design, humans and forms. But this is the area where I am interested in, and that area is this designer's domain, or whereby we looking at humans or looking at these people, if we can do some kind of functionality, so it could be those designers which will be referred. So I'll try to say there are two types of possibilities. One, let me say, a conventional designers or designers whom there had been some kind of product development since centuries. So let us focus on conventional way of designing, where the watch has been designed, the pen had been designed, or you see all products around you from the companies, various firms they have designed. But we will also talk about another term called industrial, this design thinking. But when we go for design thinking, let us understand the other word called rational thinking, because until unless we see all around lots of products, everywhere we see products, so they are all made by this rational thinking, or the thinking need of the society, or people sitting across the world, maybe Europe or USA, they must have designed your mobile phone, your mouse, your laptop, and you are using it. There is nothing wrong in that, but that let me see that has come from this rational thinking or this designer's aspect. Okay, so before we talk about design thinking, let us ponder into this designer's aspect. Okay, so when I say design, so any design, whether it has to come from rational thinking or design thinking, let's see. Let's not introduce design thinking right now. But when I say any product, it has to be any design has to be based on utility. It has to be based on peculiarity. It has to be based on having some kind of distinguished feature, some kind of ergonomics, some kind of safety aspect, its unique selling point, its marketing strategy, or whatever, how this has to go to the ultimate user, or whether the organization who is trying to make this, whether it is the services, the humans, or product or services, whatever it is, so how they will be dealing with. So utility is one. This is what we mean by utility. So look at a wheel, which had been a wheel, any century-year-old product, but this is continuously evolving. So what is the great thing in wheel? See, this was first developed by any circular object which revolutionized the transportation, right? The way fire has revolutionized Homo sapiens life, similarly, these wheels have revolutionized. But you still see lots of wheel development is happening. Look at this single wheel which is being used as a transportation. So it has to be having a utility. So utility is say transportation here. Then say peculiarity. The product here is a stapler, but look at this. For one kind of customer or kind of people whom they are interested in, this is referred as the peculiarity. Okay, so I think this could be inspired by nature or inspired by something, but that it can have a kind of peculiarity is another word. Then the third word could be ergonomics. Say what you see around in your, it's a typical electromechanical product, whereby it will have lots of electronic circuitries inside, injection molded parts are there, and they are assembled mechanically and all sort of things. So from this printer to this printer, keyboard to this keyboard, and then of course to this keyboard. So why? Because whenever you use regularly, those operators use regularly, when they use the keyboard, they will have some kind of strain on their hands, wrist problem, and then this could be a better design or an ergonomic design, let us see, ergonomically designed keyboard. So this has to have a ergonomic aspect. Then it could be safety aspect. Whenever you design a place, design another product, all safety aspects have been taken care of or not, that is another part of design. Then a unique selling point of a design. This is the bike which I love, because when I got my first job, I could buy a second-hand RX-100, Yamaha RX-100. This was a bike of, my first love kind. So this bike to this bike, the same bike is now stopped, but this kind of bikes are now coming in. So when you have, now if you ask anybody, they will not be able to look at this bike. They will like to, any young person or Gen X person will like to ride this kind of bike. But that does not mean, so what is the unique selling point? So these two aspects has to be coming in terms of design aspect. Then what are the steps of engineering or a product design? So what are the steps of engineering design or ultimately lead to product design, product development? But we are only dealing up to prototypes. We are not moving the next step. Next step we'll see tomorrow. We'll only handle up to prototype. That means the first product, the first thing which has come after design will be referred as prototype. So we'll see, even if you are talking about the steps of the design. So first the ideation, those cases, then you make a design proposal. Design proposals are very, very critical stages because that is a serious effort which has gone in. And then of course the feasibility analysis, and finally the prototypes. So when I see, if I look at those Hindi movie references which I was giving, say, if you say that somebody says that my designs have been approved, that means design proposals have been approved. Design proposals have been approved, and or some funding has gone, whether it's a government funding or a private funding or whatever funding, it has gone to move it further. So carry on the feasibility analysis and make prototypes and do iterative things so that you can get ultimately a product. It has so many things which we'll talk tomorrow, but at least these 4 words we should be knowing: the ideation of the sketches, the early stage. Tomorrow we'll talk about something known as TRL, technology readiness level, but at least the ideation, the prototype, this design proposal and feasibility analysis, and finally prototyping. If prototyping doesn't mean only you have 3D printing, then only prototyping will happen. We'll talk about that. So these are the 4 steps of a design for a product to be reaching closer to this prototyping. So what do you see these sketches? These are all various ideas. You can have a kettle like this, or a product like this, or a watch like this. So you can, there are lots of designs which are right now available. There are lots of soft websites where you can buy designs, you can upload designs, you can get your designs, money in place of design like this. Those things are possible. So these are all designs early sketch cases. So when I say design proposal, this is a little crowded slide, but let me see what this design proposal has to be. So design proposal has to have these things. So first thing is, it is talking about the product, of course. It has to have the complete portfolio management, particularly why that particular need has been satisfied by this particular design, or of course all sort of procedural aspects. So those are all management, project management or project design level. But the important part, if you look for any kind of design, it has to meet the requirements. It has to be appealing. It has to be having a kind of practicality or a feasibility, and budget of course has to come in. So these are the things which will be taking care during design inspect, and the detailed document will be referred as design proposal. So design proposal will filter out these things. Say, yeah, it is like those who, when you talk to the student, I am famously reminded by example when we were students, or even the students say that is a huge syllabus, ek balti syllabus hai, and then we do some teaching learning. So एक मग टीचिंग लर्निंग करते हैं, उसमें से एक ग्लास हम उसको एक ग्लास या एक टम्बलर या मतलब थोड़ा सा क्वांटिटी, सो बिग क्वांटिटी टू huge quantity to the small quantity, we are able to grasp what is being taught, and then syllabus is so big, and then filter. Ultimately, we reach out to some kind of few drops of something. So that is what, say, there are desires. So what you want to make, any designer to think on in this direction, that is a desirability. Then feasibility is very important. You may think that you like to do, even those who are doing PhD or master scholars, they think that they want to do so many things, but what is feasible? What is best and feasible for what you want to do that? Or in that particular case will be referred from feasibility. And finally, actual. How the performance has come out is your actual. So this, based on your design proposal, this will be filtered through. And your design proposal will cater to all these processes. Okay. So if you don't do that, you will end up doing something known as not able to move in the direction, or not able to be on the ground. That's what his design proposal will look for. Then of course, feasibility analysis. So once you have the design proposal, the next thing you should be doing that, or you can ask for others can do your feasibility analysis for any design, whether it is feasible in terms of finances, in terms of capacity utilization, whether what are the kind of supply and demand, whether the customers will get satisfied with this, and all sort of that thing. So this will be referred as feasibility analysis. So we are only talking about design aspect. Once that analysis has been done, it is passing through that particular criteria, then of course we'll move on to the prototyping. So prototyping, you can have initial sketches were there, but you have they won't work. You will have better drawings, better complete drawings or sketches will be could be one part of prototyping. It could be digital prototyping, all kind of CAD CAM CAE, those particularly mechanical people, we do CAD CAM and CAE, or of course electronics people do the Cadence could be your CAD tool for all kind of circuitries, and then you go carry out kind of analysis or simulation, that will be CAE, computer engineering. So that is nothing but digital prototyping. So it will be referred as digital prototyping. Then if you have a product in terms of tangibility, you can go for modeling it using clay or metal or wood or whatever it is. Even since all of you are engineers here, I can definitely say that if you have a product, say for example, if you make a pattern, when do you use pattern? If you have to make a casting product, a casted product. When you want to make a casted product, first you make a pattern for this. So pattern could be made out of thermocol, clay, or whatever it is, or wood. So the pattern is deposited inside the mold, and then you pour your molten material, and then you get your product done. So that is your nothing but your prototype. So based on this term called RPT, rapid prototyping, and rapid tooling has come. That we'll talk some other time, or maybe in the end of it. Okay. Or if you give me feedback, I'll cover in my tomorrow's class. Okay. So RPT is rapid prototyping, or RT is rapid tooling. So the pattern could be tooled, or you can refer it as a prototype. So those are, but that doesn't mean everything will happen. Of course, now things have revolutionized with a concept called additive manufacturing. We may talk tomorrow further for this. There are 7 families of additive manufacturing. We can, I think you may be knowing, otherwise we can cover about it. But the rapid prototyping is one which is based on this CAD CAM CAE technology knowledge. Okay. Then otherwise you can have lots of other conventional materials which can be used for making prototyping. So what do you see here? Why at all you need a rapid prototyping? Because sometimes the design is very complex, so you need to make it quickly, you need to make it precisely. So you may use it. Say this is an example of a typical head of a dinosaur. So this will be looking like different shapes and sizes, and this is highly organic. So conventionally you cannot make. So you may use rapid prototyping. So there are X number of printers, X number of printer makers. There are lots of technologies. If you want, we can cover tomorrow, else someone else will cover for you. Okay. So that is what is your product to design to prototyping aspect. So these 3 things we talked about, and we take a quick review here in last 25 minutes or so, that we wanted to talk about humans, form, functionality, and this will get realized by design, and then of course to so many iterations in between, and of course the proto, and of course here also multiple iterations. Okay. So moving now, we talked about the conventional way, what happens in factories, so many products you see all around. Why get into this domain? Should we learn about it? Why Professor Chaudhary has covered this topic in this. All those answers will be coming soon, but this cannot be forgotten. That means conventionally what is happening inside design world, designers, or you see lots of buildings and all those things. So people are doing work. People are making things for the sake of profit, or maybe I don't know, the sake of charity and all those, but that is happening. So we just covered this. If any question is there, Dr. Madhav, we can quickly answer that in the chat box. Udav Saab, sorry. If there is a question up to now, just trying to relate you to the conventional design aspect for a product and its serialization. So please put in your chat if you have any question. Dr. Reddy says no. Anyone else? So let us, we can spend another 5-10 seconds. If you have any question up to now. Okay, so moving next. And the next thing is, let us understand design thinking. But before we move on to design thinking, let us talk about these scenarios. Okay, so what do you see here? What do you see here? Anybody? You can just put in your chat box what kind of stuffs available here. I mean, what kind of scenarios they are. They are all taken once if you Google up India poor photographs, you will get this kind of images. The net is full of it. So I'm just pausing here and seeking your feedback. What you see all around, what we see all around, what those products are there around us. If you have money, you can buy iPhone 12, you can buy a good car or a good building flat, you can buy anywhere in this world. But what is this all around? See what you see. So I just want you to, I want your reactions to be captured very quickly, possibly. So there are problems, yes. Dr. Hema says there are problems, yes. I see difficulties, sir. Some poor people, yes. Okay. Dhirendra Kumar is saying some poor people. Okay. So that's what Dhirendra, you are rightly saying, real problems. Okay, great. Social issues, great. Good that you interacted. So not availability, challenges faced by human beings, life of people must be improved, great. Okay, so I think you are all fantastic people. Aveji, I'm hats off to you. Unemployment, poverty, okay. Life of poor people with lots of problems due to poverty and education, okay. Is social issues in real world, okay, great. Okay, so we stop here. Thank you for being so interactive. So now when you see these kind of images, what you see is a kind of a fact check. You see that though you are studying in ECB, though you are a faculty in some good college, so you are from a well-to-do family, but this is also the world is. Okay, so now that this is the world, of course, if you are not from this domain, we need not to bother about it. But if you think that we are all supposed to do some solvers, we are supposed to be designers, we are supposed to be problem solvers, improving the life of others. We are an engineer. Yesterday I was attending a ICT syllabus making meeting with, and then one professor there gave a wonderful, Professor Amitabh Ghosh sir told that as engineers are supposed to, inhale science and exhale what? Products. Such a wonderful talk in terms of these yogic terms. So inhaling science. So engineers should be knowing pretty good knowledge about science, and that science knowledge is not sufficient. We should be having an eye on the society and exhaling the solution for the society. That's what the right word was. So once you take on these things, it's fine, and that means all of you have a very good heart. And we know that Indians have an excellent heart. That means we are all very kind people, and we do lots of charity. That's why possibly India has lots of beggars. Whether you go to our temples, mosques, anywhere, bus stand, you'll find people begging, and then they also find it sometimes more profitable relative to comparing to doing some job. So there is a reason for this, and we want to decode this today. We want to decode these problems and how engineering people, how people like us can solve that difference in approach. And difference in approach, we want to relate it. So let us see what you see here is, I don't have to relate it. We'll come back to this slide later on if required. But it is not a matter of unemployment. It is not a pure matter of social issues in terms of we are only showing pathetic. We need not to talk about this, but they definitely need our attention, because there are our people, and we don't solve their problem, and nobody from Europe or USA or Japan will come and solve their problems. Okay, and if you don't solve their problems, probably it will be beyond certain way. But mind it, we cannot solve the problem by having pity on them, by having sympathizing them. We cannot solve. So we have to understand these two terms: what is sympathy and what is something known as empathy. So that's what we should be moving in. So दया करके नहीं करना है किसी को, किसी का rightful right दिलाने के point of view से अगर सोचेंगे, that we'll see. So that's a thought, and solving, we'll see those problems. I'm trying to give the words to these problems. There are undefined problems because you don't see what is the problem here. Say maybe because even if you make some X number of houses, the problem will not get sorted out. And what is the problem with these two kids? Not a problem. Whether it is a problem or not, I don't know. What you see here is patient with a disease called clubfoot, which has not been treated, or someone who is working here. This image I took from Bikaner because they make lots of sweets in Bikaner. So these people are there, they are working. Sometimes they are very happy. Sometimes very happy working in this field. Absolutely not a problem. And you remember the Nayak movie? People want to live in Jhuggi Jhopadi. Even if you give them houses, they will come back and stay here. I don't know for what reasons. Do you know for what reasons? Nobody knows. If you look at, there are self-respecting people. So if you try to tell these workers, construction workers, you try to give something additional to them, possibly they will be, if your approach is not right, they will not accept right kind of, what if you think they are right tools, they will not accept. Okay, so because there are multiple issues, there are attitude related issues, the problems have been unmet. That means they don't know whether it is a problem or not. Attitude, culture, definition of problem is not at all there. So let us move into this territory where, because product mobile will be made by someone, pen will be made by someone, but definitely these, if you think these are all issues and these are the things we need our attention, they have to be done by people like us only. Okay, here also I am taking your attention here. So what is your input here? What you will say for this scenario? This I have taken from anywhere in Jaipur itself, this image. So what is this? The dustbin is there. It has been placed. It has been placed well. Lots of efforts have gone. Lots of investments have gone. But people are not using it. So how people can use it? Can engineers do something so that this is usable? So again, your inputs, please. I have opened the chat box. Anyone? So I am not here. Koi Gyani Baba nahi hai who will be just giving you lots of gyan and then I'll deliver a power lecture. Let us understand this problem in terms of design thinking, and then this is mindset of human being. Okay, great. Design changes are required. Okay, design changes are required. Great. Dr. Reddy, nicely appreciated. Dr. Momin, yes, mindset of human being. Okay, what else? So mindsets are not, how can we change the mindset? And what design changes you're looking for? And it should be convenient to be used. Okay, sometimes it may not be convenient. Place a music device which will attract users. Okay, illiteracy or literate people. Okay, oh right. Then the placement of dustbin and easy to use. Okay, so those are the things which you think that it can solve the problem. Training is required to use it properly. Okay, so there is some X number of replies, and you are right in saying those things can be worked with. Okay, and how I have taken a very, very simple example and a simple which is popularly known video also. which you might have seen. So I'll show you this. Can you see the audio also? So the problem which had been attempted to be solved, and you already hinted, one of you hinted, that if you make a kind of a display device or a music device or any kind of systemic device, if you throw some garbage in the dustbin and if somebody says that it has been placed right well, you will ensure that you will hit your target. And if it is not done, it will not be. Sometimes you don't know, you don't care, you have thrown it, and if it is there. So a simple case study which has been done in terms of design thinking, which I'll tell you with whose reference I'm talking to. So a simple dustbin with a small circuitry. You look at. Could you see the audio also, sir?
Audio is not available.
Audio. So I think I have to do some changes so that you can listen this music as well. So no audio, right? So shall I go back and do some changes here? When I say share with sign mutes, because I usually do the Teams platform, and there I have option to share my meeting window. So let me do it again. When I share, it should ask me share with the audio. Anybody expert here who can guide me? Automatically optimize. Because I am. Anyone? Anyone can unmute and tell me? Okay. Sorry for that. I still couldn't get the audio.
Sir, just try to share entire screen, sir.
Try to share?
Entire screen.
Okay,
instead
entire
of
screen.
window.
Okay.
Yeah, instead of window.
Okay, we can do that. But entire screen is not an issue here. It's the issue of audio. So for that, usually
include system sound.
Sorry? Come back.
Include system sound, sir, in that.
Include system sound. Yeah, I'm looking for that tab. When it will come, ma'am? Tell me. When it will come? At what place?
When you share your screen, no, that time it will come.
Okay. When I'm sharing, it is supposed to tell me, but I couldn't find where it is. Include system sound. It comes in Teams wonderfully.
Yeah, just share it, please.
Yeah.
And you will see right top corner.
Right top corner. Yeah, there are some buttons here.
You will see automatically optimize, and just inside of that button, right side.
Okay, manage
there is
panel.
A small, no. Share content. When you share your content.
Okay, shared.
Just follow this. First, you click the share.
Okay, I'll do it again. So I'm clicking share.
Now you find this share content window.
So you are saying me to find the share content window. I found screen 1.
No, right, extreme right, where you find that window closer switch, that close switch is there. Just below that, there is a
automatically optimize. Yeah, optimize for text and image, optimize for motion and video. Optimize for motion and video, right?
No, just beside
I think
this.
I got it. I think I got it. It is saying don't share your computer audio. That means I said yes, I'll share it. So share. Now you tell me. Get it? Thank you. So what you see here is
இல்ல அந்த டீடைல் வேணும் முதல்ல. வனிதா அந்த இந்த டீடைல் வேணும். இல்ல கூகுள் ஃபார்ம் போட்டு அதுலயே வந்துராது. ஆமா ஆமா சரி சரி.
So it's a Volkswagen case study, and I want you to appreciate those who are not speaking. Please mute yourself. Okay, thank you. And what is the inference out of it? It says that the dustbin which were, it is not a case like only in India that the garbage is lying out of dustbin, but you will find many places. And then this has another case study. And what you saw in the previous case, now the garbage collection has gone some 41 kg in a day, which used to be 3 to 4 kg per day. That means people were getting around, they were coming and throwing it inside, even if the garbage doesn't belong to them. What do you see here? Anyone? What is the scenario? Scenario is any metro station or any bus station. These days we have in railway station also elevators. So everybody is after this elevator, right? So now how can you ensure that people also use stairs which are so wide here comparing to the escalators? And you see everywhere. So any idea? I'm looking for your chat. So nice. So that's what. Put some kind of what could be the incentive. So this video will sell, the Volkswagen video will sell, they'll put some piano, some music. But what you will do as an Indian to ensure this? That's my question. Okay, Dr. Sujay K, tell me what you would do in a Kochi metro station. You are saying healthy tips for a single. Okay, then very good, Sujay. Anyone else? So and how
sir,
it has come? Yeah.
Sir, to attract kids, some paintings are there, means for each kids will try to get they will avoid escalator and they will use a step at that time, sir.
Okay, so the moral of the story is this is not a conventional design or conventional designers. It's a wonderful design. There is an escalator here. There is lots of stairs planned, and design is wonderfully done for all kind of emergency exit and all sort of thing. So wonderful designers have worked on it, but still there is the mindset change has to take place. And as somebody said, for those who have not seen this video, what you see here, this case study again from Volkswagen. Can we get more people to choose the stairs? What has been done? Redesigning of your stairs, right? So as somebody said, see, these are all humans. Developed countries or underdeveloped countries or developing countries. See the human behavior. No pity has been done. Nobody has sympathized with that. Their behavior code changed. What that means? So 66% is a great number, I think. See? Okay, here we are. So now the question is how the solutions have been arrived. Thank you for your so interactive. I think we wanted this kind of thing so that the monotony will go away and this afternoon everybody gets interacted. So how the solutions have been arrived here or world over for their problems? The solution lies in design thinking, right? Let us understand design thinking now. We are all set to understand design thinking. I want some yes from all of you. Okay, thank you. Thank you, Ram Kumarji. So let us see design thinking. What design thinking is. So design thinking, what it is, if you understand it in full term, it is a mindset also, a process also. It is not only a mindset, but it is also a process. So it's a combination of a mindset and a process, which has to be understood by local people, by indigenous people, and it is not a others cannot solve your problem. You understand the word endemic, ENDEMIC. Can anybody tell me the endemic plant of Rajasthan, Jodhpur, which might not be there? The endemic has its extension is pandemic, which you are aware of it, which is everywhere. Pandemic. But what is endemic? Which is related to local. So that's what, if you have to appreciate design thinking, it has to be appreciated in terms of a mindset. So only through contact, observation, and empathy. Let us understand this word empathy with end users. So if you understand the empathy and empathize end users, what you saw in the beginning can help design solutions that will fit into their environment. So it is not that any kind of solution will work for them. You have to understand, connect, observe people, and empathize with those who are going to use it. Then only you can design solutions and they will be. So that is your mindset, right? Second part is, it's a process. Add up opposing to what we thought. We have this problem. Let us jump onto the straight way, the brainstorm and solve it. No. In this case, the technology, what technology is useful, what way things can be done. So this sequence of process can be worked upon. So that is, it is a mindset as well as a process. So I'll talk about design thinking in terms of its process. So first step is empathize. That means we don't know the word empathy much about, but let us understand the empathy in the next slide. But let us understand that, and this mindset problem is done by empathy. For anything else, once you have a problem, once you have solved once you have a problem, you think that there's a problem, there is a need of something. Say, what is the development of a nano car case study? So nano car case study is like that. It came in papers, of course, some 30 years back. Ratan Tata was traveling to Ahmedabad, crisscrossing through the city. He saw a two-wheeler, a bike. So a bike is being ridden by a husband, wife, and there was a other kid was standing here, and the wife was carrying one kid. So he thought that in place of this two-wheeler ride, can he convert into a four-wheeler ride? So this two-wheeler can be converted to a four-wheeler. That may be an empathy part, but once that he has empathized and whatever business idea he found, based on this, he came up. So this is not that Nano becomes so successful or that, but it was an idea. Based on this idea, what they did, they defined a problem, they ideated, they prototyped, and they finally tested, and then went to the market, right? So what are the steps? Empathize, then define, then ideate, then proto. So what do you see? Define is a problem defined, and ideate is nothing but your all kind of sketches which you have seen, and then making the prototype. So this is nothing but design. Ideate is nothing but design. What you have seen in the previous, since last 1 hour, design part, and the design has to be prototyped, and then it has to be tested. So that is one part. Only thing differentiating it is this empathize. Okay, and we will be focusing on empathy, the word empathy. All right. So shall we move forward? When we see empathy in the beginning, So that doesn't mean it is one-time activity. What is required is this whole process of design thinking, or if you just look at this design development process, if you are thinking in terms of design thinking, it is a mindset problem, then every time you have to be making iterative things. This is what literature says, and I took it from here. Tim Ogilvie's theory. So it says empathize, then ideate, then define, of course, and then ideate. But you have to go back to prototype and go back again to empathize. You make a prototype and again go back to the definition and see whether it is there as a definition or not. You can straightway go to ideate without defining sometimes. So this is a highly iterative process, but the process is simple, and those engineering students, all of us studied in our machine design or instrumentation design or whatever, electronics design or power design you have studied, we move in this diet. So we have a problem statement, or what we call it as a need analysis. This is what we have done. Then we have ideate, and then we make a proto, and then test it. So this is all a conventional design or a design process. It was a design which was initially it was referred as serial design, and then we started doing it at parallel design. So what we parallel means, you have to come back to any of the stages. Okay, so parallel, or in mechanical engineering we refer it as concurrent. So I want to tell you here that when you out of bloom, or it is not something great which has just like that. That means other than 5 steps, 1 step only is different, right? And let us see what this difference in statement means. Okay, so first step, shall we focus on the first step? Now please appreciate, does anybody know the difference between a word called empathy and sympathy? Or let us see what is empathy. So when I say empathy, again I took it from literature. When we try to decode design thinking, empathy has to be done first, and empathy means the user-centered approach. What is the approach? The user-centered approach to problem solving is the one word which can be written for empathy. Now, once you have empathy word understood, what is this empathy means? See the word of the user, understand the feelings of the user, appreciate them as human beings, communicate your understanding with the end user. So this is what is written for empathy. But mind you, I got this 6 years back. These fundamentals I understood 6 years back. I mean, I was introduced 6 years back, but I did not understand much about it. When I understood much about it, very recently, maybe during the last lockdown, let me tell you, I was going through some kind of videos, and I found one gentleman. So if you have to understand this empathy and sympathy, how will you differentiate? Before I tell you who has taught me empathy, the difference between empathy and, so there is an answer here. Empathy is understanding the consumer's feeling. Okay, then what is sympathy? You are saying understanding, right? You are saying understanding. Then what is the meaning of sympathy? Dr. Sarnu, would you like to differentiate empathy and sympathy?
Yes, sir. Empathy is understanding the consumer's feeling, and
Yeah.
sympathy maybe it is kindness towards the consumers, that satisfaction towards the consumers, such that quality products can be assured.
Okay, very good. So now I have, I think you rightly interacted. Now let us see a small story which I'll share with you, which I heard from a gentleman whom I'm going to introduce in next slide. So there were 3 friends, friend A, B, and C. 3 dost hai. Maybe you can take their age. They are teenagers, right? They are teens. 3 friends are there, good friends. It need not to be, you know, boys or girls, or it could be mix, or all 3 boys or 3 girls. Now, what happened? The person B, or the teen B, his mother dies. She is no more, and they are all very close friends, right? So now both obviously A and B will go to B, both A and C will go to B's house because of his or her mother has died. Now, there are two scenarios here. A is having both his father and mother, both are living, and C's father is there, but a year back her mother has died out of cancer. End of theirs, B's house, who will be able to sympathize and who will be able to empathize with B? So what is their attitude, behavior difference, or understanding difference, or whatever you can call it? What lies the difference between the overall attitude of A towards B and overall attitude of C towards B? Anyone? So when we use these words, when we say I'm sorry for that, and we call all kind of use English words for that, or Hindi word, or any language words for that. We sometimes don't mean that, but we will definitely speak something. So the question is, A will be able to say, but he doesn't have any kind of understanding of the situation where somebody's parent dies, because he is fortunate, he is lucky to have both his parents alive. So that doesn't mean he is not happy, he will not, he is not upset, or he doesn't understand, he is not able to give right feelings to the B, but he will definitely sympathizing to B. On the other hand, since C also has felt the pain very recently because of his mother dying, he or she, when goes to B, will definitely able to say that I understand your pain, what you are thinking. Even not, but empathize. So that's the first difference I want you to appreciate. Is it okay? Now, the first word meaning between empathy and sympathy, I tell you, I found lots of talk between the differentiating between these two words, empathy and sympathy. So as one of you rightly said, sympathy is the ability to feel. It is the ability. Feel pain and suffering of others is referred as sympathy. But this word meaning itself will have lots of difference of attitude for all of us. On the other hand, empathy is the ability to understand not only suffering, because it is not always the suffering, even the moods and mental state of others, that is empathy, right? So if as a designer, if you are empathizing something, that means you understand moods and mental state of others. This need not to be always suffering. So sympathy is always suffering. You will get sympathy when you see somebody in a dire situation, but it need not to be all the time dire situation. So understanding even their happiness in normal state or suffering, any kind of feeling, so understanding that is empathy. Okay, it can be of three types. It can be cognitive, then relating yourself to the emotion of others is emotive, and then doing something compassionately, doing something or feeling some kind of compassion with that is known as compassionate. So this empathy word has these three words which I differentiated. On the other hand, sympathy is always with the suffering, and please do understand, people don't want pity on them. If you take poorest of the poor, if you try to, what happened during COVID times, I don't want to digress from the topic, but any kind of donation, any kind of help people want to do, they'll take selfie and then post it. So it was so pathetic for the person who is receiving the help, right? So on the other hand, if it is empathy, if somebody is empathizing with somebody who is in need of it, or I don't know, not only normal condition or suffering, but even in happiness, that means it. So sympathy is also emotive, we feel emotional with somebody, we feel compassionate with somebody, and so please do understand these are the terms taken from subjects like ethics, psychology, emotional intelligence, philosophy, aptitude, moral science, which we have learned in our school days, right? But our feelings. So, what are empathy and sympathy? They are our feelings or action or behavior towards our fellow human beings, or sometimes even to animals, or sometimes even to fictional characters. We see movies, we empathize so much with the sorry, or and we try to do something, or I don't know situation, what kind of situation it is. I remember one small case in 2007. I was in a conference to Malaysia, and that conference registration was going on. There were two faculty ladies were sitting, and not much crowd was there. So, and when I was trying to register, they say we started chatting, and they say, "Why do you watch?" She said, "I watched once a Hindi movie," and then she says, "Why do you watch movies to cry?" She was remembering something like the which movie Hum Saath Saath Hain or something. So the idea is you can have these feelings, sympathy or empathy with the fictional characters. So this is what the primary difference means, and this I got from this gentleman called Dr. Vikas Divyakirti. So Dr. Vikas Divyakirti is a person, you will understand this. Can you remember? Can you just pay attention to this? His YouTube video is having 12 million viewers, and this is on basic structure of constitution. He is basically a person who is he is teaching to these IAS aspirants also. Mainly it is in Hindi medium, but he has his English medium lessons also. I found him a wonderful teacher, the way he carries things and the way he involves his students. Very, very famous person. Okay. So he has given these 3 circles to us. What is the circle? The first circle is even if you have to differentiate sympathy, empathy. So sympathy, empathy, and there are some common stuffs. So you already now know that sympathy is only for suffering. So you can find yourself a case. This can be in happiness also. So if you empathize with somebody, how do you differentiate somebody's that you are empathizing? Say, for example, after 10 years or so, I don't know what age you are. If your friend or if your kids, say, for example, they get jobs or they get admission in some Premier League colleges, what kind of feeling you get? And those things are also part of empathy. Okay, and what are the common things? You can always refer to lots of literature available there. Okay, so that is what. So it is differentiating in terms of these 2 word meanings. Okay, it's a 1-hour topic only for this differentiation. Okay, so that's why I thought that let me pay attention to it. So now we are back to our talk, and what it is, when to use design thinking. When to use design thinking? Not always when the problems are weak. You understand the problems are weak. What you saw in the screen, the situation, the social problems, the problems are ill-defined. When you don't know whether there is a problem or not, when both problem and solution are unknown in the beginning, when both problem and solutions are unknown in the beginning, a large part of the problem solving is actually defining the problem. If you rightly define the problem will be solved very quickly. And situation like this, VUCA, very, very interesting situation. Volatile, uncertain, complex, and ambiguous. So I have a situation here. It's a today morning news. You know, those who are not from Rajasthan, they might not be able to, though you are doing an FDP. But if you are doing a physical FDP in Bikaner, say, you will know such a beautiful city it is because of its palaces and so, right? So very similarly, we have a wonderful palace in Jaipur called Amer Palace. So Amer Palace is on a hill, and this palace has so many watchtowers made historically. Now yesterday some 50 people were, because the weather changed from some winter to this hot summer to it started raining in Jaipur. So local tourists, or maybe I don't know who were there, they moved to this Amer Fort for hills, on the hills to enjoy life. But they were on this watchtower, and they were taking all kind of, because the other two sides of the watchtower were deep trenches on the hillside, and this side is the mauta of the Amer Fort. The fort is there. So they were climbing here and they were taking all kind of selfie and having fun. Suddenly this thunder, lightning happened, and 12 people died, and lots of injuries. So what could be is there a simple solution for this? I don't know. So many things might come to your head. Whether the buildings are old, modern buildings. The building in which I am right now I am on the 8th floor. They are all having this lightning conductor properly designed. Those on hill, they may not be having the right kind of lightning conductors. Then what is the nearby area? What kind of thundering is happening? They all were having mobile phones. Is their mobile phone responsible? Okay, so there are so many problems you'll find. The problems may not be defined at all. They may be uncertain, they may be complex problems, they may be unambiguous problems, they may be volatile problems. So in this case, you will be using design thinking. All right. So you can come out with some kind of thought process and move to the answers. When not to use, design thinking is not answer to every problem. For some problems, one will need rational thinking. I mean, acquiring a competency. Rational thinking is like, I have a product, I have one you will get one call, the launch of one product, the second product. That is rational thinking in competition. So most of the products you see are rationally thought products, and it is not that you will use design thinking for those products. But whenever you see this kind of problems, you will be using design thinking. Is it okay? So now we can move on, and design thinking can be further explained in terms of, say, people say, when you have people, you have technology, and you have use of this technology for the people and a business. The business will give you a viability. If it is not commercially viable, it will not take care. So if it is not commercially viable, that means the mobile phone, the dustbin which you made, if you make a musical dustbin, in between you can give some kind of advertisement also, so that it is becoming business viable. Okay, and of course cleanliness, and it can have some extra carbon credit for that. So that is a business point. The technology has helped, and of course people are required. So this is what the design thinking process is, and it will try to integrate all three things: people, technology, and business. Okay, so I think this word is clear. So now I will try to adopt this design thinking, because I want you to appreciate the adaptation of it. Say, what is this? This is empathize, analyze, then ideate, solve, and test. So I want you to appreciate, remember easily. So even I was trying to talk to you in terms of those additive manufacturing technology, or 3D printing technology, or prototyping technology, or RPT technology we're talking about. I always tell my students, divide into two categories. There are 3 and 4. Which are those 4? 4 is both for polymer and metal. If you are doing printing for polymer and metal, these 4 technologies. If it is for only polymers, these 3 technologies. So polymer, which are technology? Polymer, MVM. And then in this category, DSPD. This is ISO classification, ISO 1437. Sorry, I forgot the exact number of ISO. This ASTM classification is there, which talks about all the 3D printing technologies. So this is material jetting, wet photopolymerization, or then is material extrusion. So what you see in these days, 3D printers are nothing but material extrusion, or we call them as FDM, fused deposition molding technology. So you can divide into 3 categories. Okay, very similarly, if I talk about, so this is again a kind of adaptation of things or a kind of a small design thinking, because teaching these days is a big challenge. And those who have in this room, many of you are faculty members. So when I try to talk about this, I told them this is only for polymeric materials, all plastic materials. So if BSPD is say binder jetting, sheet lamination, P is powder bed, D is direct energy deposition. So likewise, in my class, I can remember also, and I can also talk to them eye to eye, and they will remember and they will come back after 10 years or so. Sir, aapne sikhaya tha. It is still helping us. Okay, we have, then whenever they come back and they say, sir, we have this printer. You talk the D, we have now D. I don't have a D, I have a FDM right now. So that is M. Okay. So similarly, if I have to adopt this design thinking words, so I will always say EAST, EAST. So E stands for empathize. A is analyze. So E and empathize and analyze is okay for me. So empathizing, getting all the inputs through empathizing, then trying to analyzing the situation, and then try to solve the situation. So solve means these two, ideate and prototype is both solved. Ideate and prototype. Ideate and prototype is both are solving. And finally, testing it. So these words, so now onwards, design thinking in our case studies, we'll talk about EAST. So you will tell me whether it is a term or S term or T term or E term, empathizing or analyzing or solving, or it understood. So this part is taken care, or I'm just I'll seek your questions. You please put your questions in the chat box before we I'll take another 1 minute and just ask you to when to use design thinking. And there are two possible scenarios which I found. One is surprise oneself by self-regarding a domain within the one's domain only. Say you are electronics engineer, I am mechanical engineer. Within my domain, I surprise myself. I try to think some kind of problem solution while after I have empathized with people, empathize with the word, and then try to develop something. Say, for example, I'll talk about a multi-purpose convertible prime bag which got developed when empathizing has been done. So within my domain, I did not do anything beyond that. Only thing, I empathized initially and try to find a solution through EAST. E is empathize, analyze, solve, and test it. That's all. So that's what is design thinking. Word is empathizing. Similarly, if I do some kind of product development, product development in Jaipur Food, which has been a mechanical product, it is not having any kind of controls, any kind of electronics. So I'll do some kind of work in this manufacturing standardization I'm doing within my domain. So that is surprise yourself once you are empathized with the situation, and surprise yourself, that is referred as within the domain. Or if you can do out of your domain also. So what is out of domain? You can very quickly come to the newer domain. Say I tried doing something in biomedical in last 3-4 years. So it's an unfamiliar domain to me. As Professor Chaudhary told, I was into metal machining and metal finishing and CAD/CAM, CAE and all kind of work since my early career in Chennai. So from there, I don't know out of what I moved on to these biomedical devices, developing an orthosis or developing an ankle foot orthosis, which was not in my domain. Of course, the technologies were taken from mechanical engineering, electronics engineering only, but it was not a domain of mine. So you sometimes can do in others' domain also, not a problem. Okay, so that is what design thinking can be used. Okay, so we are here. We moved on from product, is design, and understanding design and prototyping. We now know there are 7 technologies of rapid prototyping as per ASTM. We now know that design thinking is different from rational thinking, and we talked about certain scenarios. We understood design thinking, and within design thinking, the most important term is empathy, and which is different from sympathy. So now onwards, of course, once I understood the difference between empathy and sympathy, now my behavior has changed. I don't tell people in terms of sympathizing people, but when you initiate a talk or even you try to get something from others in terms of solving their problems, whether a construction worker or a parent whose baby is ill or whatever it is, you have to move in this term, because nobody wants दया कोई दिखाना नहीं चाहता. आप किसी पे दया दिखा के आपको बन के आपको जरूर हेल्प कर वो समझ सकता है. Okay, so we have spent time up to now, and now I will request you to come out with a kind of quick question if you have anyone. Then I'll talk to these studies. So let me see. See, Dr. Sila is saying empathy is about feeling the situation. No, madam. Empathy is not about feeling, it is understanding. See, that you rightly said. That's what I am here to dig into deeper. There is a difference between feeling and understanding. It is the understanding, not the feeling. Understanding the situation, not only in terms of poor situation or a bad situation, but sometimes even happy situation. So, yes, design thinking supports any kind of culture. In every culture, design thinking can help. Say you take any kind of thing. Say look at this, the product which are there, the IT solutions which are there for. It's the biggest case study. This jam problem, the jam solution which has been provided. Okay, there are questions. So I'll take to this question is from Dr. Sarnu. So I would like to tell you that it can be there in any kind of culture.
Okay, sir. Okay.
Any feasibility. Okay. So jam is the biggest example. Lots of case studies are there. I think this based on IT information technology only, things have changed, like Ujjwala scheme. Lots of case studies have been done by this jam. Jam is this Jan Dhan, Aadhaar and mobile phone. Okay, account and mobile phone. Okay, so many things have come based on this design thinking has solved this problem. So another question is Dr. Naveen Rathi is asking, how about critical design thinking? Is it the same? How deep we think? Okay, critical thinking, rational thinking. Critical thinking is one word. Yes, critical thinking is different. So when we say in our school, whether are we able to talk about understand things in terms of critical thinking. So critical thinking is another word, but critical thinking is thinking only. It is an initiation for design thinking. So critical thinking can be a tool for design thinking, right? So design thinking is a mindset which involves critical thinking, yes. And then of course the problem solving, right, Dr. Rathi? Naveen sir? Then I see the next question. What is the role of design thinking in electronics? Yes, electronics or mechanical or see as Dr. Professor Chaudhary said, I moved out of Rajasthan and went to Chennai and then across India for 10 years and then moved to Chandigarh for another 10 years. The moment I landed in Rajasthan, here it is the problem of these states like Rajasthan and UP. Sorry to be on this platform and saying slang is everybody is interested in your caste, right? So very similarly, we engineers have started doing ourselves. We have divided into different castes. So I tell my students, जिस तरह साधु की कोई जाति नहीं होती, वैसे कोई इंजीनियर की जाति प्रॉब्लम की कोई जाति नहीं होती. That means you don't divide yourself into that. You remain domain expert as electronics, mechanical, civil, electrical, whatever it is. But when you look at the problem, The problem has to be interdisciplinary always. It will not have any kind of compartmentalized in terms of electronics. So we'll talk about it, Dr. Sila, that it is not only in terms of so these are all different solutions for your you may need electronics circuitry in it, you may need some kind of coding, you may need some kind of
I'm
mechanical.
working in electronics department, so I asked the question.
Yes, yes, ma'am. Not issue. Absolutely not a problem. But what I'm trying to emphasize is the problem. As far as problem is concerned, you may be paying more attention in terms of electronics circuitry part. I may pay more attention towards the packaging part of it, and say, for example, if you look at this particular product, it is an interdisciplinary product. It may have circuits, it may have programming language, some kind of chips which are there, which have been programmed. In the end, it has been casted from outside. So this is injection molded. So very similarly, it is not that particular branch of engineering that matters, that problem solution matters. So very similarly, if you make some kind of IoT device, say for an adult person who is situated in electronics thing, it could be a mechanically packaged, it could be a circuit, a control device. So that way I'm trying to emphasize upon. All right. So there is a question from Dr. Reddy.
Thank you. Yeah.
Yeah. Shall I move forward? Dr. Reddy says, every stage of design is a decision-making process. You are right, sir. Every stage of design is a decision-making process. And that's what I tell my student. They say, I asked in the first year itself, what is the difference between a draftsman or woman and a designer? So draftsperson, the person who does the drafting, is very good in drafting. His free sketch or everything is excellent. On the other hand, what is a designer? Designer may not be having those ISO-based drafting skills. He is an excellent person or she is an excellent person. But I try to differentiate. Correct me if I'm. Please do some adding on this. The designers have to take some decisions. So decision making is designers. So everything in design is decision making, right? So that's rightly pointed out, sir. Everywhere it is a decision making process, and that decision making will be, of course, influenced by this EAST. And what stage you are making decision, whether you are going back and again empathizing, or whether it is solvable, or finding the right kind of solution in terms of testing. So that's what is your decision making, right? So can you elaborate more on product peculiar? Okay, peculiarity is like, okay, product peculiarity is one. Say you just see, I was giving an example of we inhale science and we exhale products, right? So when we differentiate, see this bottle has, there are so many cars in the market, still there are new cars are coming. So that means similarly, if you look at the mouse, there are so many which will be having different design, different versions, different I mean shapes, sizes, and still some more ergonomically product will be coming. So those things are like a uniqueness or a peculiarity for that particular product. So if I have to design a watch for someone who is a young girl of say 14 years of age, her taste will be different from a gentleman who is in 50s. Okay, that is what I mean by peculiarity. Okay, so that again involves lots of decision making. It of course involves empathizing sometimes, but that's what is known as peculiarity of a product. Then there is a question from Dr. Sanu, sir. If it needs the redesign, what about the steps? Remain same or different? Okay, redesign is what? Redesign is again cyclic process. So what you say? We talked in terms of mechanical word. We call it concurrent design. So when I say concurrent means redesigning only, concurrent.
Okay, sir.
Concurrent means at every stage, even from the manufacturing stage, you can come back and redesign your product. Okay, so that is what is concurrent or parallel processing, we say, parallel design, we say.
Okay, sir.
means variation of a product. Oh yes, you are right. Variation of the product in a larger word you can say, but unique to a situation, unique to a kind of user will be peculiarity. Okay, just to as per the ambience of the माहौल के हिसाब से देखिए हम देखो कैसे बदल जाते हैं. If I am going to a marriage party which I have not gone in last 45 days, I mean last 20 months or so, I'm missing lots of weddings and lots of things. We all are missing. Or if we go to a friend to tell that somebody is not in the right condition, or somebody has lost someone in his family. So how we adapt ourselves, that is what is known as peculiarity. All right. So here we are. We can move on to this case study. And of course, we'll talk about these case studies. If something is left today, we'll do it tomorrow morning. Tomorrow, same time, possibly. Yes. So now I'm back here and I am taking it to this condition. Please empathize with this. What do you see here? A product. I think it's a very popular product. It's a pram, and it mostly you'll find having prams. So they are used for transportation, leisure activity. Okay, during that you can supervise your kid or sleep away from the home, or likewise you take your kid to the park and evening. And I see lots of new faculty members with their newborns. They take it to MNIT campus also. So this is what everybody knows, the stroller or the pram. Now there is another situation. What do you see here? There is a single parent. It is not always that both of us will go together. See, if me and my wife both are working, then say for example, she has to cook. By the time I'll take the baby out and come back. So if my park is not close to my residence, I might use a bus or use a step or stairs. So in that case, what happens? How do you manage the pram? Because you at least need conventionally 2 persons. Am I right? You need 2 persons to manage this pram. And of course, sometimes you may end up doing accidents here. All right. So there is a situation that the world over people are using. It may be having, of course, millions of products are there. People are using it. It's a very common product. But there is a possibility that whenever you have this kind of situation, single parent cannot manage with the pram and with the newborn inside. All right. So how do you solve this problem, particularly in urban environment? If I have to use some kind of means of transportation between the park and even sometime at the airport, but there things are better. But how we can manage this? Is there a problem you see here? Anyone? So means hinge plate is kept used as a ramp. Okay, good. You may have a hinge plate for the buses as a ramp, so that you can take the baby in. Yes. What else? You are straightway going to the solutions, right? But let us understand. How many of you are a parent? And have you undergone this kind of situation? That's the question. If you are saying, hey Roger, see, don't say straightway an answer. My question is different. Have you understood? Have you ever been to this kind of situation? Have you taken a baby to the park alone? If you have taken, then say yes. And have you talked to somebody? Most of us are saying no. So what is important here is we should not jump to the solution, but we should design should include it, feeds and okay, right. We'll talk about it. Yes, ma'am. Abe sir, I am a parent. I have taken my kids to Singapore. Okay. Yes, there are multiple appreciate this. Dr. Abhay, what could be the solution? Abhay sir, you can unmute and tell me. You can empathize more comparing to someone who has not done this. If you have a young one and if you are going for a LTC travel, you would like to, okay, your mic is not working, doesn't matter. But yes, do you think there is a problem? You are saying, Dr. Rathi says he experienced the same problem in UAE. Yes, that means there are problems, and many of us can empathize it because we ourselves are parents, right? So obviously now we cannot go travel. Yes, Rathi sir, that's a poor thing. But anyway, here we are. So we need some kind of solution, right? So we can come and brainstorm, talk to people. Ramp providing is like changing everything. It is like the world is full of problems. हमें बचपन में से बोलते थे कि world is full of problems. आप पूरी दुनिया में दरी बिछाने की कोशिश मत करो, बहुत सारे कांटे हैं. आप पूरी दुनिया में दरी नहीं बिछा सकते, कारपेट नहीं बिछा सकते. What you can do? You can wear slippers in your foot. आप चप्पल पहन लो, पाँव में जूते पहन लो, वो ज्यादा बेटर रहेगा बजाय सब जगह से कांटे उठाओ. Professor Momin. So the ramp providing may not be enough. So I'm critical, but this is one of the solutions. Yes, society should do it. All the municipalities should do it, provide ramp and all those. But there is a problem, right? So we can come out, brainstorm, empathize, talk to people, and then there will be sometime a solution. Then there will be sometime a solution for that. And just look at what we can do. We can think on multiple solutions. So you are given lots of inputs. If you want, I can read one or more chats. You can talk about Dr. Anup saying increasing the step size. Yes, that could be the one. A plate is kept inside the bus itself. Yes, but that again, it's not in our hands sometimes. Can we solve in a different perspective, from a user's perspective? Okay, so let me tell you this case. And anybody wants to participate, or shall we move forward? Okay, let's move forward because we are running out short of time. So you're given lots of input, and thank you for that. Okay, single wheels with support and lots of solutions are there. Please look at this solution. So this is the product. Do I need to repeat the video, or you understood? It's a convertible pram. Very good. So Masood SK sir is saying it's a convertible pram, and the pram here is, it can be converted to a carry bag on your shoulder, and it can remain like a stroller. So this is right now a stroller. If you press few buttons, this will get converted to this kind of bag, so that you can take your baby on your shoulder, travel where, whatever you want. And one of the possible solutions. It is not that it's the end of the world. This way you can safely keep your baby on the shoulder. You can have multiple colors. This good kind of product. So my question to you is, how many marks do you will give to out of 10 to this kind of a solution for a problem which I discussed? Out of 10, how many marks? Anybody? Just write some number, 0, 1, 2, 3, 4, 5. Anyone? 6. No, need not to be bodybuilder. It can be made lightweight. Yes. Need not to. It looks like a bodybuilder kind, but it can be made lightweight because you know there are lot technology has come up with lots of solutions. Very lightweight products. You see, what 30 years back the materials which were being used in parachute are being used in these days strollers and bags. Okay, so good. Lord, thank you for grading the product. Now look at this was initially the problem was stated to these 4 students, Ankur, Elvis, Sabyasachi and Shubham. Which year? 2013. And when we empathize with parents and when I had this problem in mind, say when I moved from Chandigarh to Jaipur in 2012, and I told them, let us make some kind of arrangement, some kind of a device which is convertible. So this is the first prototype, what you see here. And this is the design, what you saw here. And this pram bag or backpack, which has been designed traveling with their baby in unfavorable settings, right? So convert it to the minimal ease. With this was the problem statement which has been done, and this was the first mechanism developed, CAD model, simulated mechanisms developed. Then of course its weight was around 7 kg that time with using the conventional materials. What you see is now this particular product weight. One of the students, Sabyasachi, in 2017 he went to Helsinki University, USA, Finland, Helsinki University, and he participated in this product was participated in one of the competition. He won it, and then he started developing this product, and now he has sold around 30 pieces in last 1.5 years to European countries. Okay, so this is when you empathize, when you solve it, when you try to identify the user's perspective, understand them, you will come out with this kind of solution. Okay, that's the moral of the story. Okay, right? So that's what we talked about. Then I can talk to you. We have another 15 minutes. I can talk to you on another product. Of course, this is a great product, but we'll see how this has been done. So now what I'll do is I'll talk about this particular product called Jaipur Foot. So before we move on, any question? Quick question? Of course, there are lots of marks only. Thank you for that. But I'll take you to this particular product called Jaipur Foot. Okay, and what has been done in Jaipur Foot. So if you look at anybody who don't know Jaipur Foot, say yes. Anybody who has not heard of the product called Jaipur Foot, please do write yes here. Possibly no one will say yes. Okay, ऐसे बोलेंगे भी नहीं. But I think everybody, when I say, okay, service, yeah, thank you for being so honest. So you say yes means that means you have not heard of the product called Jaipur Foot. Yes. Okay. Anyone else? Thank you for being so honest. Anup sir, thank you. Who else? So heard about it. Okay, there is one solution for the same. I have seen it. When such issues are there, they have a folder type with different designs. Okay, all right, Dr. Naveen will talk about it separately. Okay, heard about it. Okay, so that means most of us have heard it. Majority have heard it. And when we go out of India, and if I say I'm from Jaipur, at least 3 people out of 5 told me, oh, Jaipur Foot. They have heard about Jaipur Foot. Particularly those engineering people, those product developers, they will definitely talk about it in biomedical crowd particularly. Okay, so we'll talk about this Jaipur Foot. So this is a story of a famous surgeon who was in Jaipur, SMS hospital. His name was Dr. P.K. Sethi. He was a surgeon heading the department of surgery, SMS, and he in 1968. So remember the days, 1968. He was getting lots of patients who were amputees from lower limb. Amputee means okay, by accident or उस वक्त क्या हो रहा था? If you recollect, in India we had lots of farm machineries were coming. So because of the farm machinery, people were losing their limbs, either hand or leg. So इनका amputation हो रहा था. Amputation होने का मतलब somebody will dissect your leg, otherwise this will get infected to everywhere, or maybe some accident, car accident, or farm accidents were so many were there in this region, Rajasthan, Punjab. Okay, so he was trying to get a low cost prosthesis. We call this prosthesis. So prosthesis is one word, prosthesis. That means if you have some limb loss, artificial hand or artificial leg can be referred as a prosthesis. So he was looking for a low cost prosthesis, and because the patients who were coming to him were so many from this region. So what he did, he came up with the cheapest ankle foot, the cheapest foot which was there in that particular time was Sage. Sage is solid ankle cushion heel. This is a European design, and this was costing around that particular time around say 300 USD. That means none of his patients could afford this kind of, though it was a low cost, because modern the blades and all are very costly. But this design coming from Europe, or then the manufacturability and many things were there, it was still costly. Though it is at par world standard, this was the cheapest product available. Hourly means pound. Okay, so Sage was very comparatively costly for Indian crowd, and it required lots of fitment. And another problem is Sage foot was not suitable for Indian people. Why? Because Indians lifestyle is different. What is the lifestyle of Indians? We mostly walk barefoot during going to temple. We sit cross-legged, and while eating food and all, squat we sometimes do. So this particular foot the Sage was not suitable. So he came up with an idea how he modified Sage foot to suit to the Indian condition. Or not only it's a modification, it is one of the beauty of very wonderful design. And based on that design, this Time magazine has held this foot, Jaipur foot, as the greatest invention of the 20th century. Even this was held at UN. And can you remember the dancer Sudha Chandan? She may be aged now, but if you may not be knowing that she is an amputee, and these days in India, major reason for amputation is, anybody? Major reason for amputation is foot amputation का major कारण क्या है? Diabetes. Diabetes is a major reason which is coming up for amputation in India, particularly now. So it is coming up, and this is altogether different world which we engineers should also look into. So now the case is, this was a foot which was developed by Dr. Sethi in 1968 with this philosophy in mind, that it should be synthesized using, number one, low cost, inexpensive. He told that it should be synthesized using low cost material which are easily available. So what are the easily available material at that time in India? Say those materials by which you make footwear. So chappal, jute jo banne ke liye kaam aata tha, that material was used, and he designed in so way that an artisan kind of people, locally available people, who started manufacturing it, and they will do all kind of cutting, grinding, joining, and he designed some kind of dies for this. And that's what it was done in MRSC Jaipur, part of the work, particularly casting. This is what I heard from my seniors, and he used this rubber material in place of wood of the Sage foot, and he also used partly he used wooden block also, so that it remains strong, and some materials like tire cords were used. The material out of which the tires are made, he started using it, and finally he used a skin colored rubber on it. This is the kind of foot which was developed, and it has excellent flexibility. And now you can do Google. His friend Dr. Mehta, D.R. Mehta, he he was a SEBI chairman, senior IS officer. He joined hands with him, and then they started an NGO called BMVSS, Bhagwan Mahavir Viklam Sahayata Samiti. They have presence in more than 150 countries, and they create lots of charity, and of course they supply this Jaipur food and feed to the patients free of cost also. So this is a food which is costing less than $10. Less than $10. $10 means 500, 400, 500 rupees will come. Is it okay? Right? So now, what is this design? What it has? How Dr. Sethi has done? That is a story which we may not be knowing fully, but there it has some problem, and how we tried solving this problem, that I want you to discuss. So what are the materials I said? It will have an ankle wood. This is made out of wood. It will have a steel bond. This will be microcellular rubber. Around 30 years back in India, all our chappals were from MCR only. Little more density. Again, microcellular heel block was there. Then least density is this MCR TOS, and then you wrap around a tire cord, and then of course you put some rubber, skin color rubber, and put everything inside a furnace. I mean for sintering inside a furnace, and then the product is ready in 4 hours. 4 hours, the food is made. Okay, so this is the story of Jaipur food, which has been developed by Dr. Sethi, some say around 50 years back. This is held as one of the best, most frugal product. You understand the meaning of frugal? Frugal means which will do kind of disruption in the world, the way things are happening. So tomorrow we'll talk about what disruption is, what technological disruption things can go about. Okay, so that is what is your the Jaipur food story is. Now what we have done, I think we'll spend some 5 minutes tomorrow's class, and we'll more talk about Jaipur food, because now it is hardly 2-3 minutes are left before we wind up. Okay, so this case study will be taught in tomorrow's session, part of it. Okay, so if any quick question is there? Yeah, polio people doesn't require, Dr. Momin, a prosthesis. They require a support system, and the support systems are known as orthosis. So we'll talk about orthosis. Orthosis are those devices which will help our limb. So a polio caliper is a orthosis. Is it okay? So orthosis are those devices which will support the limbs. Okay. On the other hand, so even if it is your back belt and all those things, there are orthosis. But if somebody is having amputation, it will be referred as prosthesis. Prosthesis is one which will be replacing your limb. God forbid somebody has to go through this, but there are people, and the famous, I think the case, the Blade Runner, he was notorious, and I think he shooted his girlfriend and all those. Those are, you may be aware. I don't recollect his name. So that is your prosthesis. There are so many. Tomorrow we'll talk about what is the SIS. What is the population in the world over which required orthosis and prosthesis, and this is one of the domain where we engineers should do lots of work, but we need to empathize first, and design thinking can help a lot. Okay, so I think I stop from my side, and then if you have any question, the organizers can read the question.
The participants may ask any questions if you have. So I think it was a very hectic session today.
You understand?
We started at 9, and right from 9 to 1:30, or rather it was 1:45. We were engaged in 2 sessions, then thereafter after 2:30 to 4:30, again 3rd session. But the best part is we had very good sessions. Like this session, we are able to understand so many things, because engineering, most of the time, the problem is I interact with my students, and if I ask them what is to be done or what they want to do, at least they should define the things. Like you were talking about the subject or a branch or mechanical or electrical or electronics. It's a big problem that a student do not know what is the meaning of profession. Rather, I have literally made a survey that more than 90% engineering students, as well as teachers also, they don't understand what is the definition of profession or professional. What is the meaning to be a professional? And we are just producing engineers and engineers. So the important thing is engineer has to learn that I am not required to do some activity. I have to target the problem. Now problem will tell me what are the activities I have to do, whether it is mechanical related, it is machining related, it is to be provided some IoT. And the beauty is we can see your example that you had a mechanical background. Now you feel that your requirement is in biomedical. So you are filing patents in biomedical. So we can see that from where you started with the aeroplanes and with the different sort of equipment. Then you are moving with demand of the situation. So that is the demand of the situation or demand of the society or demand of the user patient. That is more important. My expertise is not important. I may be very good in just flying the aeroplane. But if somebody is having a problem in Bikaner, he wants me to drive a car, and if I don't know driving car, there is no value for my ability to drive a plane or fly a plane. So it has to be understood that we need to be ready for each type of activities in engineering if we want to go for product development. I have seen a lot many students or my friends who first ask, sir, this is not my area. And I just want to tell you about an example. In 2012, one of my friends who was going for PhD at IIT Roorkee, I given him a paper, just go through it, we can publish good papers out of that. And he did not saw the title of the paper, and he said, sir, it is not my area. You don't believe that around 2 months back, he sent me a paper, but sir, my PhD is almost complete. Please just do some editing. And I was stunned to see that all the material which was in that paper in 2012. So that same thing he was doing in that area. So I asked, why didn't you saw that paper? You could have published some good paper in International Journal of Climatology, or that is having impact factor of almost 8-10 as of date. So we are just binding ourselves. We are just categorizing ourselves in a smaller area. We have to think about the problem. We have to target that problem. And whatever the problem will tell us, we have to create that solutions. That's all. And I think our head of department, Harjeet Singh ji, is also there. So I would like to
Sri Akal, sir.
Few words.
Sat Sri Akal, sir. It was great session, sir. Especially the last one, very interesting, and we were able to relate to the problems in the practical way, because most of us know about Jaipur food, how useful it is, and how widely it has changed the life of people over a long period of time, especially the poor, very needy people having medical problem. So very good example, sir, and a very interactive session. That was another part of it. In the lazy afternoon, it was a great energizing session with a lot of case studies and examples other than more academics. So this will rather make us understand more deeply and appreciate the things rather than just clipping the slides and giving more and more information. More than this is a very effective way of rather transferring of knowledge, sir. Thank you, sir. Great, sir.
See here, I would like to just mention that if Dr. Sethi had assumed that my job is not engineering, because Jaipur Foot is not a medical output, that is not a doctor's output. A doctor who was having an engineer inside his mindset, he produced that Jaipur Foot. So same way we have to come out with different type of products. So tomorrow also we would be having some good sessions. Tomorrow first session would be taken by Mr. Virendra Gupta, who has founded the Delhi Hunt. That Delhi Hunt is an IT giant company. It's a innovative idea he had, and he founded that company in 2009. Then thereafter, Professor Ranjan Maheshwari would be taking the second part, and third part would be taken by Dr. Halal Singh Mali. So I think we should end up now. We thank Professor Mali for being with us, and tomorrow in same session, third session, we will again meet with him, and he will be discussing some more details about design thinking, because design thinking is that basic concept behind product development. If that is not there, we can't say we can build up material, but that will not be product. That will not be a usable thing until unless we don't have that attitude, empathetic attitude. So thank you very much, sir. See you tomorrow.
Thank you, sir.
Thank you.
Thanks to all the participants. Have a nice day. See you tomorrow. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.